And we are live. Hello, everyone. Welcome to the Global Online Summit for Java Developers.
Hi, everyone. Pleasure seeing you.
Yeah. Hello, guys.
Right. So we have, as always, we have a lot of content ahead of us. This is the Java event, as you obviously all know. We have like more than 8 hours of sessions today, and we also have a senior track tomorrow, which is like around 10. So definitely lots of stuff happening. So, and I want to welcome and we'll say, first of all, thank you to our amazing community manager, Julia, who was responsible for this event. And I want to give you a microphone to tell our audience a bit more about what to expect during this event.
Yes, hello, guys. Welcome to our Java Online Summit. And we are happy to see you here. And what I can say that we just here because of our program committee members help us. And I want to say many thanks to them because it's amazing people who helped us with our program. They were searching for the best topics. They helped us to evaluate them. And I want to say many thanks to Xian Chen, Brian Brands, Christoph Ellenberg, Igmar Paltenberg, Ottavio Santana, Theo Bias, Almond, Shai Almond, Suyash Yoshi, Edwin Dirks. And I'm really happy that guys helped us and we are here and now we can enjoy our amazing agenda and topics. I hope you will be happy to hear these topics because it's nice speakers from Microsoft, Amazon, Google, Red Hat, and also what I can say is that it's almost speakers from all the world because we have like speakers from the Europe, India, Asia, USA, Argentina, Canada. Can you imagine this? I hope it's gonna be a really nice conference. Enjoy this day. Thank you that you are here.
Yeah, and please write also where you're watching this from, because yeah, as Julia said, we have people presenting from all around the world. So I'm pretty sure like we also have the audience from around the world as well. So yeah, definitely write where are you connected to us from.
And also we wanted to say a huge thank you to all the partners, to everyone who supported us throughout this course, to every Java community around the world, around the globe who joined us, and also to every speaker from every company who decided to contribute to this community. Also, big shout out to amazing Java champions who joined us as speakers, and those who helped us with previous events. And also we wanted to say thank you to our sponsors of today's summit, to Microsoft, and we will have one of the first presentations, I believe even the first presentation, we will have Bobur with us, and he will be talking to us about Azure, and we will also have some special links for free accounts, for free registration for the Azure. So definitely give it a try. If you are building, I don't know, on-prem or on the edge, then it's worth trying it, since it's for free. And also we will have today many topics about cloud infrastructures, and also about Kubernetes and Git actions. So lots of cool, interesting stuff. And also, I believe we will have some special offers for the upcoming events. For the QA Global Summit, for Architecture Global Summit, we still have open spots for the early bird registration, so you can get yourself some tickets at the lowest price. And also, if you need maybe enterprise tickets, enterprise packages, then I'll also post my my email at the chat. So hit us up if you need some group discounts, if you need some group tickets, or maybe if you want to join this community as partners or sponsors. We have lots of cool events. So let's make some amazing events together.
Yeah, and also like we also have offer for tomorrow senior track. So definitely like today we have like more introductory part where we have suitable for juniors to watch. But I'm sure everyone like who interested in Java will learn today a lot today as well. And tomorrow we have senior track, and so we have an offer just for today. We have first 5 tickets available for only for price of only $99. With the promo code Java99. So if you go to our website, go to the full access ticket, so the first five people will be able to grab themselves an early bird price. And I'll post the direct link to the ticket in the chat as well. And also we'll be posting links to our upcoming events in chat as well. And some just final words about this broadcast. This is definitely going to be recorded. So don't worry, if you miss something, you'll be able to catch up with some talks right where you're watching this right now. Same links will work after the event. And so we have today 4 blocks of sessions. We'll have Q&A at the end of each block. So please be active. Please prepare a question for our speakers. That's why we have assembled them here for not just to give their talks, but also to answer your questions and help you maybe with something you encountered or you wanted to know more about. And I think we're good to start and to invite our first moderator for today. So I want to welcome Andres. So Andres, can you please join the stage with us? Hey Andres, welcome.
Hi, welcome everyone.
So how are you feeling
to participate on this version of the conference?
Right. Okay. I think it's high time we start with the first session. So Andres, the stage is yours. Please introduce us the first speaker.
Well, thanks. Our first speaker is Bobur Umurzokov. He's a developer advocate, specialist in software developer and leading developer audience. With more of 9 years of experience in IT, Bobur blogs about technology and community around. Also, he has working as software engineering training for several years to train the engineering of the future. Bobur is highly skilled in developing, testing, and design software, knowledge of backend development and the best practices by having more than 9 years of experience on software developer in the biggest software company in the world, Microsoft. He's a Java developer originally and can write a code in any program languages. He will talk about build a real-time event-driven solution in Azure. A great topic. I want to learn a lot of that. The idea is create an application stack which describe a real-world scenario. The best tend to be the most efficient and reliable. Many workload and event-driven in their nature. In this session, we are going to learn what event-driven means and how to build serverless Java solution using the power of serverless event-driven computing, Azure function, and send event-based telemetric data in a real time to Azure Cosmos DB. So let's start with the presentation, and Bobur, is all yours, the stage. So when you want to start.
Everyone, and welcome to one of my sessions in building real-time event-driven Java solution in Azure. In this session, you will learn how to enable automatic updates on a web application using event-driven Java solution and Signal R service. Let me introduce myself. My name is Bobur, and I am a developer advocate, a speaker, and mentor specializing in software engineering and leading a developer audience. You can reach out to me on the following channels, and I will be happy to discuss further and answer your questions regarding these sessions. With that, let's get started. Here is our agenda for today. Throughout this session, we will talk about current Microsoft investments in Java and Java on Azure, possible solutions and offerings, and we review the common scenarios for real-time serverless messaging. And also we evaluate an existing project that implements all the polling-based approach, and we update this application architecture to support push technologies like a Signal R service and Azure functions. And we build our serverless functions using Java that interacts with a backend database such as Azure Cosmos DB. And we use, let's say, for the front-end web client application, JavaScript and Vue.js for this demo part. Over the past several years, Java ecosystem has changed a lot. We moved from monolith Java applications running on application servers and Spring framework to the modern, smaller footprints like SpringBoot, Microprofile, or the Jakarta EE microservices. And today, more and more Java developers are looking at how they can bring their existing Java applications to the cloud, or how to build the new cloud native solutions from scratch. And many organizations have a significant investments in the migration of mission critical Java applications running on premises to the fully supported environments to run these apps in the cloud. Well, I expect this comes as a surprise to some people, as I was really surprised and had a ton of questions in my mind, and how it came to be Java on Azure, or why Microsoft's choice is Java. Why not use other public cloud providers like AWS? Because at that time I was totally new to Azure, and as I got used to developing, building, deploying apps in the AWS ecosystem. After making the small investigation, I found out that Microsoft actively supports all the community, Java community organizations to help and promote the future of Java, including the ongoing development of the Java language and the JVM. Microsoft is also contributing directly to the OpenJDK, and nowadays they're supporting spills of all the OpenJDK, like starting with Java 11, 16, or latest one 17, and providing support for these binaries on Azure as well. And of course, we cannot forget about the GitHub, which hosts millions of Java repositories, CI and CD, and vulnerability scans, not only for Java, but other programming languages. Last but not least, there are more than 2 million JVMs running across production products and services at Microsoft. For example, the LinkedIn relies heavily on Java, or the backend of Yammer also written in Java. I surprised to hear that this Bing, Microsoft's web search engine, which also powers the search feature in the Windows start menus, also uses Java. You can read more about the tools for the Java developers on how the Microsoft applies a Java ebook. Over the past few years, Microsoft had several strategic partnerships with major vendors in the Java ecosystem, and these partnerships empower developers to code and deploy without worrying about the infrastructure. Well, another surprise comes with the Azure offerings for the Java ecosystem, as it includes very diverse technologies such as Java SE, Jakarta E, or Spring, numerous application servers and other frameworks. Whatever you are doing with Java, building an app or using a framework or running application on a server Azure, supports your workload with plenty of choices, let's say, and the deployment options, including infrastructure as a code. With new architecting or code changes, you can migrate existing apps, or you can use, for example, container as a service and fully managed platform as a service, for example, Azure Spring App, which provides a managed platform for hosting SpringBoot microservice applications. Or maybe if your organization leverage containers, you can use a Kubernetes service on Azure known as AKS, Azure Kubernetes Service, or you can use Red Hat OpenShift. It's a project jointly managed and supported by Red Hat and Microsoft Azure. Or there are some other fully managed passes for Tomcat, JBoss, EIP. You can also manage the VAR and ER using the tools of your choice. You can also leverage fully managed databases, which are always up to date, highly available, and with a low latency. Sometimes you don't need to build an entire Java-based microservice. You can build the serverless APIs with the help of Azure functions. Because the serverless computing enables the developers to build applications faster by eliminating the need for them to manage infrastructure. With serverless APIs in the cloud service provider automatically provisions and scales and manage infrastructure to be required to run this code. And Azure functions allow you to write this code in several programming languages, including JavaScript, Python, C#, and Java as you see today, and that triggers whenever any event in the cloud occurs. You can see that Azure function can listen for various events and triggers, and then it can connect with messaging queues or storage resources to finish end-to-end business logic flow. Also, by using Azure functions to integrate these events with Azure Signal R service, you will have the ability to notify thousands of clients whenever this type of events occur. Let's say a change made in an Azure Cosmos DB collection, and this change event is propagated to the Azure Cosmos DB change feed, and then Azure Functions is triggered by this change, and using it is Cosmos DB trigger. And Signal R service as output binding for the Azure function publishes a message to the Signal R service. And then Signal R service that uses this client part of this application with the Signal R SDK that can publish messages to all the connected clients. That can be browser, desktop application, or the mobile application. Some common scenarios for real-time messaging that you can implement together with Azure Function and Signal R service, including real-time location sharing, or visualizing IoT device telemetry data on a real-time dashboard on a map. Or even you can send an application notification when the new orders are created in the Salesforce. Or simply you can take any real-time two-way communication chat, or anytime user interacts with a web page and tries to refresh this web page to retrieve some new data, or maybe this page implements old Ajax long polling to retrieve this new data. It is a very, very good candidate for using Signal R service and Azure functions. Or maybe one of the common scenarios, like when a new post is created on the user's blog and all these subscribers will receive notification about this new event that post is created. For today's demo, let's consider the following scenario. Your company is planning to launch new service or the website that provides stock price information to customers. And now your task is to first prepare the prototype that to update these, to implement these automatic updates of the stock price information. But you need to make sure that communication between the clients and the server should happen only when data changes happen on the server side. One of the simple, straightforward solution can be following. The stock price information is stored on the server in Azure Cosmos DB database. Let's say the simple client, they also use Vue.js maybe to compose a UI, and it has an Axios HTTP client library to handle this request to the Azure function. And the page also uses a timer to send this request to the server every 5 seconds to request stock data. When this trigger work with HTTP request to the function use it is input bindings to return this content from the database, right? And then it returns to the web application. The response returns maybe an array of stocks, which are displayed later to the users via the client web application. And nowadays, majority of APIs only support this kind of requirements by having the consuming application constantly poll for changes. This means that consuming application has to make frequent API calls to find out any changes of state on our desired resource. However, there are some limitations in this simple solution or this approach. In the timer-based polling prototype, the client and web application contacts the server whether or not changes exist to the underlying data. Once the data returned from the server, this entire list of stocks is updated on a web page, right? But again, regardless of any changes, maybe this request can return just empty response. And on the other hand, this selecting the best polling technology, polling the interval also quite challenging, because you never know on which at which time the poll start to work. Timer-based request call will start to work, and we can start to fetch this data, especially when we scale up our application with a high load. It can bring some issues when we are requesting for this data. That's why, as we understood, that the current polling-based implementation is not a good solution. Next can be the better solution for us in this scenario to make use of pushing server solution. Let's say we can implement one function in Azure function that runs only when data changed in the database. In our case, is in Azure Cosmos DB. Then we implement another function that broadcasts changes to the connected clients using SignalR service. And that the web application uses this SignalR service SDK to establish connection with the server, and then SDK can retrieve this connection information to another second function called negotiate to connect to the service. And then we can update our client web application to respond to this SignalR service, so that we only change. We only push the changes when something changed on the database. Actually, it's kind of we had now a back and forth the direction. I'm going to show you these all good two examples in my demo, and I have also this source code you can find on my GitHub. Now you can just scan this QR code, and it will bring you on my repo landing page on the GitHub, and you can have a look how to get started with it. There are some prerequisites you can install and so on. So now let's jump into this demo part of this session. After you open the GitHub my repository, it's called Build a Real-Time Application with Azure Services. You can find there 4 branches. The main branch is final implementation. We have 3 more branches like after, before, and CI/CD, where we implemented also the CI/CD for bringing your Azure function changes to the cloud. And this repo demonstrates these following things, like we integrate the SignalR service for the front end, and there are some prerequisites, as you can see, to install first, like Azure CLI to interact with some commands that you need to set up some Azure resources, like create a resource group, storage account, and you need to create Cosmos DB that access our database, and you need to also retrieve some connection strings for the storage, and also for the Cosmos DB, and also you need to create one more Azure resource SignalR account. With it is connection string that after you will retrieve this. In total, you will see soon now on Azure portal some 4 resources, at least, like it's will create under my resource group. I call it like a real-time stock application, and we have some resources, as you can see. The function of resources I created after, and manually I will show you also during this demo how we can initiate. And if you open the Cosmos DB database, we have initiated some mock data inside the stocks collection. As you can see, it has some items, like 3 items with the stock price information. Of course, you can add more items to have more data visible on the web application. And if you open the source code and navigate to first before branch, that shows when we use the old polling approach. And let me introduce with a code structure here on this before branch. We have 2 folders, like front end and serverless, for the backend and UI respectively. And we have a simple web application on the UI with a single page that shows some stock price information when it fetches from the backend function app. In function app, it has only single /API get stocks endpoint, and this endpoint will be triggered every 5 seconds, as you can see from the JavaScript code. If I navigate to now the setup.js file, you can also run npm setup command to pre-populate all the necessary data. And on the serverless folder, you can see the Maven project, because we are using Java to build our single function HTTP trigger based. It's called get stocks. And as you can see, it has a Cosmos DB input binding on the stock prices. it just simply returns this stock data from the database in this format, like it has symbol, price, and change direction to the increasing or decreasing, etc., and so on. And then if you look at the local settings for Azure functions, there are some connection strings that we retrieved in the previous steps, like after we created the Azure resource group and Azure resources. Now I will jump into the terminal, and I will start to run my backend first. Backend application, my Azure functions, and I need to navigate to start serverless folder, and I'll do manual clean install to install some necessary packages and bring some dependencies for my Azure project, Azure functions project, and then I will do manual Azure functions run. That it runs locally my API stocks. As you can see, now it's working, returning this 3 data from the Cosmos DB, because we have Azure function Cosmos DB connected already with connection string. Next, let me open another terminal window, and I will navigate to front end, and we'll do npm install to install all the necessary dependencies for the UI. And if I do npm start on my front end project, it will open on the localhost 8080 this UI. This is our UI, how it looks like. As you can see, there are some stock information with stocks, the letters, and as you can see, it is calling every 5 seconds on the browser. Next, now I showed you this old approach, and I can open now another CI/CD branch. That's a final result branch where we have both new approach, push-based approach, and then I added the GitHub Actions to make some sort of automation on the top of that. And I also introduced 2 more functions, as we discussed on the slides, like functions called negotiate and stock change it. That the negotiate function's task is to return connection information to the server by using Azure function. It requests connection string, and then our function just returns this Azure Signal connection string back to the Signal service, which is SDK on the client side. And then I have this main function that event driven. Depending on the changes on the Cosmos DB trigger, for every data change, it puts this data to the Signal service and sends it as a message. As you can see, because it's an array of information, we're using loop to put all this information. If you navigate the front end to have a look what is changed from the previously old approach, you can find these changes on the public folder in index.html file. Also, there are some changes to automatically update this stock data on this div based the table. This stock information comes from the JavaScript. I will show you later this one. And also you see we're using Signal RGS library and scripts for this also demo. And if you navigate to index.html.js file, it is possible to use a local base URL or the Azure base URL after you deploy it into the Azure. And we put this also extra code to Vue.js. And we removed, of course, this trigger-based approach, like every 5 seconds. We are not going to call this API. Instead, we are making connection with a negotiate function, and we are getting traveling connection data, and we are listening for the events coming from a Signal R service. It's called update stock, as you can see, and also on close and start functions. Now I can show you how things works with a new approach. I do the same when the functions run, and now as you can see, we have 3 functions instead of 1 function in the old approach. And then I will run also my front end to show you how the changes are reflected on the UI. On the browser side, on the UI side, nothing changed, but we changed the backend so that every time Azure Cosmos DB data, new item created or existing items we added, these changes will be reflected automatically on the UI side. Let me show you this. If you go to these items under this stocks collection, look at this on the right side. If I change the data, the price information for the ABC currency, this data will be reflected automatically on the stock information. That's a funny part of this our solution. Like we are actually listening for the events that created by the Cosmos DB change feed. And now everything is working, and now maybe we can try to push it to production. For that time, we can create one Azure function app, because we need to deploy our 3 functions to the Azure function app. You can also use VS Code to do so, to make it automatically. There's some extension called Azure extension or function extension. Now, for example, you can deploy easily these functions by using some extensions command. You can see in a couple of seconds, I can just bring this function to the cloud. It's very, very straightforward. And then I need to deploy my web application, the UI side, to the storage static website. For that, you can use the storage account we created in the previous step, because storage account also can host our static web application. To do so, you can just run some commands like deploy, for example, to static websites. You choose the folder where your UI source code located. You can just navigate the public folder and select this folder to deploy all the static files to the cloud. Because I did already before this demo, this deployment, you can just follow these steps and bring this website to the Azure Cloud Storage. And now if you can even open it on the Azure Cloud. Previously, we run this UI on the local host 8084. Right now, it's already hosting on Azure inside the storage account. So now both functions and my storage account on Azure and ready to use by my customers. And this prototype, simple prototype, is ready. But the final thing you can do, you need to update the course information under function app. You need to specify to allow the multiple domain access from Azure, from the UI to the Azure functions. I just need to specify endpoint of my storage account where we are hosting a website, our static website. Now the final thing is we can make sure that everything's working and test one more time if the change is affected as quick as possible. Yes, everything is working, job is done, and now we have a very great solution that can work both in real time and event driven. And if you are already familiar with Java implementations on Azure, or you are just getting started with it, I collected all the useful links out there. You can have a look at some learning resources how I learned to build Java solutions on Azure, which are real-time and event-driven. So you can have a look at also best practices and guides. I hope you found this session very interesting. And now, if you have any questions, now we can jump into the Q&A session. Thank you.
Hi, welcome back. Thanks, Bobur, for all your for your presentation. Our audience, please join to us in the meeting, in the QA meeting, in more or less 1 hour, and we will discuss with Bobur and the other speakers about your question. So keep in mind your question or write in the chat, and we will discuss in more or less 1 hour. So it's time to move to our next speaker, which is Trista Pam. She's co-founder and CTO of Sphere X, Apache member and incubator mentor, Apache Sharding, Sphere PVC, AWS Data Hero, and China Milan Open Source Community Mentor of Trista Cloud TV. She used to be responsible for the design and developer of the intelligent database platform of JD Digital Science and Technology. She now focuses on the distributed database and middleware ecosystem and open source community. Recipient of the 2020 China Open Source Pioneer Award and 2021 Oscar Top Open Source Pioneer. Her paper, Apache Sharding Sphere, an holistic and pluggable platform for data sharing, was published on the ECDC in 2022. Most recently, in 2022, he was voted as Chief CTO Officer of the Year by Global Awards, which is excellent. As the first author, he wrote a book titled A Definite Guide of Apache Sharding Sphere, which was published in the last year on PAC. And she will talk about automatical and scale out your traditional database on Kubernetes for true digital transformation. All the applications are migrating to the cloud or Kubernetes, but how about your databases, MySQL, Postgres, Oracle, etc.? And traditional database support your application services so well, but you're still trouble with big data, data management, and auto-scaling, query performance, or tenant issues. When these database issues encounter the cloud-native transition, problems will scale exponentially. Thanks to a Sphere DB Plus engine and the Apache Software Foundation top-level project Apache Sharing Sphere, we are focused on these rising database issues and create a distributed sharding database system based on your existing monolithic application. So, Trista, it's all yours, the stage, and share all your knowledge about this interesting product.
Guys, this is Trista. So today I'm so happy here to give this talk about how to automatically share and scale out your traditional databases, for example, MySQL or PostgreSQL or Oracle SQL Server on Kubernetes, so that you can meet the new requirements from the background of the digital transformation. This is something about myself. I'm the Trista Pan, and now the Sphere X co-founder and the CTO. Because I spend a lot of the time in open source, especially on Apache Software Foundation, so now I'm the mentor and incubator mentor and a member of Apache Software Foundation. And also, today we will use a great open source project to help us to reach that goal. That is the Apache Sharding Sphere and the PMC Project Management Committee of Apache Sharding Sphere. It's a top-level Apache software project. Yeah, so sometimes I will post some of the articles around the open source, around the database, especially database cloud and distributed system on my LinkedIn or Twitter. If you're interested in such topics, welcome to give a look. All right, so let's get started. Today, our content will include the following item. The first one, I will give something about the background. Because we use some of the new background, that means we read the new new needs or requirements for our database infrastructure, right? And then in order to solve the new issues, we have done the solution or new the project to help us to do such the work, right? And then I will give the demo to identify that this solution is work. But if we have no enough time, maybe you need to refer to these slides and to do the demo by yourself. So the first part is about the digital transformation. I guess it's the buzzword these days, you know, right? And everyone talk about it, and the companies are working on the digital transformation to like improve their customer service or create a new product to make their customers feel happy and use this new technology and to help their company to become the larger enterprise, right? So based on this background, you know that especially when we just to look at the database infrastructure, because if we talk about the data transformation, there are so many new technologies are happening, right, based on this transition. But today we will just focus on the database. It's a small part, but I know it's important. So about the databases, especially on the cloud, what's the new needs for this part? The first one that the company needed to manage more data, right? And all the data, some of the unstructured, some of the structured. So you need to consider about how to manage and leverage such so tremendous data, right? And to make the queries become efficient, even though there are so many data for you to query. The next one about the traffic, the governance. I mean, how to like feedback or how to render the results quickly, and how to use your replica databases to make this cluster become the high availability and make it become a slight scaling in or scale out, and to manage your traffic, to design some of the traffic strategy, right? To use all the stuff. For example, like I want to like make a strategy for my database cluster so that some of the the traffic or queries will be routed to a replica. But I hope that some of the queries with some conditions will be routed to another master, a non-master, the primary nodes or the replica nodes, right? That means the traffic governance. So all of the new needs, we needed to figure out some of the new techniques to fix them. So here I gave some of the techniques. So for example, we needed to use the data sharing architecture or distributed system, database system or architecture to help us to split the tremendous one big table into a lot of the smaller portions sorted in different locations, right? So that means we can make our monolithic database become the distributed one. And also we can use some of the rewrite splitting traffic strategy to improve the throughput of your database cluster. And also we need to consider how to trigger some scaling in or scaling out strategies based on your scenarios around your database cluster. And now the last one, that how to provide some of the tools or the Helm operators on the Kubernetes or on other cloud to make people found that it's so easy for them to deploy it and manage it, right? So that's all the techniques to help us fix all of the new issues. But techniques is just the techniques. We need to use some of the specific projects or tools, right, or softwares to include all of the techniques to help us solve all of the new issues. So what's this project or this is the solution? So today I will give this solution, including all of the key points. Before we enter into the solution introduction, I just want to give some of the background about the database and the database transition, because if we know all of the fundamental knowledge about our databases, that we can use all of the fundamental knowledges to design a new databases architecture, leverage your existing MySQL or PostgreSQL or SQL Server, all of the stuff. So if we rethink of our databases, you found the fundamental capabilities of your databases are, first one, computing power, a second one, storage power. That means your database can help you return your queries, right? And also help you store your data. So that's our databases, the main points or main capabilities. And now if we want to create a new the distributed database cluster or the architecture, that means we need to split our computing and the storage nodes in different parts and stored or deploy it in different machine. Therefore, we can reach the new design. That means your computing storage splitting, right? Therefore, we can skew out your computing nodes or your storage nodes. Even though one day you found your data are so large, so tremendous, we can also leverage the distributed system to make this system become the larger and larger to meet your new requirements based on a new point, right? So therefore, how do we use or leverage your current databases, for them, the PostgreSQL or MySQL? At the beginning, maybe you have this traditional architecture, your application just connected to your database cluster, which made of your primary nodes and replica nodes, right? And now we will create a new database cluster. Your existing database cluster will become the storage nodes of this distributed database system. And we will import a computing nodes into this distributed database system. So you can see here, you don't need to worry or you don't need to overturn your existing PostgreSQL cluster, right? Just regard this existing PostgreSQL cluster as one of the storage cluster. So you can see here this picture, there are two storage clusters, right? One of the storage cluster will be regarded as the shared one. And we will import another global computing nodes to work as a database proxy or to work as a database computing nodes in this distributed system. Therefore, your application don't need to connect to your storage nodes or this shared cluster immediately. You need to connect to this global computing cluster or this computing nodes. Here is just one, but actually you can deploy many of these instances, right? So therefore, you can see here all of the existing PostgreSQL cluster will become the storage nodes. And here we use Silnitsky as a database proxy and the computing nodes of this distributed system. and your application just regarded the sharding Sophia plus your databases as the single logic database server. So if we create this new architecture, what's the benefit from this new architecture? If we use this one, you will reach the goals we introduced before. The first one, sharding Sophia, can help your application or users to manage all of your storage nodes. Currently, there are only 2 clusters, right? But I guess in your production environment, you will have thousands of the cluster, right? And your application just connect to this computing nodes. And sharding Sophia will help you manage the thousands of your database cluster. And also it can help you make your databases, I could do the auto scaling and skew out, and also can help you shard your data into different PostgreSQL instance or MySQL instance. Is based on, it's up to the database you choose, right? So that means the sharding Sophia can help you do the data sharding, the auto scaling and skew out, and it can help you to do the automatically read-write splitting. That means the traffic governance. It will automatically send your queries to one of the replicas based on some algorithm. Or if you sharding Sophia found the new queries from the application, it's the update DML update or insert or delete such the Sacco. Sharding Sophia will route this Sacco to one of the primary nodes, right? So it can help you do the traffic governance. And then actually, sharding Sophia can help you do more. And for example, if sharding Sophia found that one of the sharding cluster crashed, it will route your new queries to the different backup database cluster, not to this crashed one, right? If you have no sharding Sophia, you need to deal with all of the issues by application or by your DBA. So that's the magic of sharding Sophia. All right, so what's the sharding Sophia? I just introduced some of the key features of this project, but if we come back to this project, you found sharding Sophia, actually it's a big open source it has a big open source community, and sharding Sophia is one of the top lab project of Apache Software Foundation. And now it has been open sourced for more than 5 years. So it's relatively mature, and we have a lot of contributors from the world, and that's for their help. So this project looks healthy and active. And if you want to learn more about this project, actually you can just look at his documents. We wrote these documents detailed. So Apache sharding Sophia, actually, it's a database proxy or database driver, and it will deploy it between your application and your databases. If you use sharding Sophia, like I said before, it can help you manage your databases cluster and make your database become a distributed database system, right? And don't need to overturn or like the offline of your existing database. You don't need to do all of the troublesome work, and just use or leverage the existing database cluster and to deploy sharding Sophia into your application and between your application and your databases, and it will help you like efficiently transfer your databases, monolithic database cluster become a distributed one, and help you manage it with a lot of useful features. So Sharding Sophia provides two clients or two products for you to choose. First one is Sharding Sophia proxy. You can see here it's an independent database proxy to help you manage your traffic in your databases. Another one, it's a lightweight JDBC driver for your Java application. It's so lightweight, you can just import Sharding Sophia JDBC into your application, and it will also help you shard your monolithic database. So Sharding Sophia JDBC and Sharding Sophia proxy, they share almost of the features, but have different, deploy ways. Yeah. So what's the most same features? You can see here: data sharding, elastic scaling, scale out, distributing transaction, rewrite splitting, distributed authentication, and like a SQL audit, you're logging all the stuff. So Sharding Sophia can help you manage your RDS, MySQL, PostgreSQL, and SQL Server, all of the stuff. Actually, here I gave this this map. This illustration for you to understand like the what's the database Sharding Sophia can support, and what's the clients for you to choose, and what the features you can use. So now we know that we will use Sharding Sophia to work as the computing nodes or database proxy to help you manage and shard your databases cluster, right? And now we will consider how to make it manage and deploy it so easily. Here, we also, on this repo you can see here, we create our Sharding Sophia chart and the Sharding Sophia operators. All of the tools can help you deploy it by one command and on your Kubernetes, right? And also can help you to do the HPEA such features on the Kubernetes. So here you can just, if you already have your existing PostgreSQL on your Kubernetes, then you just need Sharding Sophia charts to deploy it on the Kubernetes by use the Helm. Yeah, and if you want to have the HPA, auto scaling features, you need to use Sharding Sophia operator chart to deploy Sharding Sophia operator on Kubernetes. So that means it can make everything happens easy. Yeah, so here I just gave some the demo show or a case. We can first use Sharding Sophia charts and one of the PostgreSQL charts to deploy two PostgreSQL instance and deploy Sharding Sophia cluster. So this PostgreSQL database cluster plus Sharding Sophia computing nodes cluster will become the single one logic distributed database system. And then we can log in Sharding Sophia to run some SQLs to trigger Sharding Sophia to help you create the sharding table. So you can see here, I want to mention that here we will use, there's no one. We will use traditional PostgreSQL SQL and Sharding Sophia SQL. That is the dist SQL, the distributed SQL, to help us to create a sharding table, the distributed table. Because you know that if you just run a SQL through your PostgreSQL, that means you just create a single local table, right? But now you use Sharding Sophia, you can run the Sharding Sophia SQL on Sharding Sophia CLI or on Sharding Sophia instance. Then if you run the Sharding Sophia SQL, it's a SQL dialect, And then you will create a distributed table. This table is made of many subtables or the shared tables located in different here two PostgreSQL database instance, right? So here I will use certain Sophia SQL, that means the dist SQL, to do the DDL, I mean create a table named an order. And this order table, actually it's made of four tables. All of the subtables or actor tables located in two PostgreSQL primary instance, right? Each of the primary PostgreSQL instance will have a replica, right? So if you currently run a SQL, Sharding Sophia will calculate it, which primary nodes has the data of this query. You don't need to worry about all the stuff. And the Sharding Sophia will get the result from the different or the target PostgreSQL instance and merge the result, return to your application, the final one. And if you run a select SQL, then Sharding Sophia will route this SQL to a replica one, to a target replica one to gather result. That means Sharding Sophia help you do the rewrite splitting. It will route the some of the query SQL, I mean the select SQL to the replica instance, but will route the update, delete, insert SQLs to the target primary PostgreSQL instance, right? So that's the simple demo. Okay, now you can see here, actually, I already introduced these slides before. You can see here all the stuff, right? And then this demo show, we needed to use the following all of the steps to deploy PostgreSQL and sharding proxy, and then to run some of the distributed SQL. That means the Sharding Sophia dialect SQL to create a sharding table and to do the test. I mean, insert some of the test data and to execute or to test the select is correct or not. It's so detailed, but I just want to give a little introduction about what's the Sharding Sophia SQL or the SQL diet. You can see here, create a sharding table user, right? If you just excuse a traditional SQL, maybe it will become the create table T user. But now we use create a sharding table T user to create a distributed, table. All right, so I have no enough time to introduce one by one, but you can see here if you insert some of the test data and to select the run this select query, and it will return the final result to you. Yeah, so that's all about today's talk. And if you have any questions, I will answer you later on, or we can talk more on my LinkedIn or on my Twitter. Yeah, see you later. Bye.
Welcome back. Thanks, Trista, for your talk. And again, to all our audience, please join in our QA session, where most of the speakers are present and we can discuss most of your questions. So in more or less 30 minutes, we will have a QA and discuss everything. So it's time to our next speaker, Justice Assiga.
Yes.
Hi, Joseph. How are you?
Hi. How are you?
I am fine. Well, a briefly introduction. Joseph is a senior consultant at Red Hat that work on OpenShift. The work consists of deploying OpenShift to customer, deploying application on OpenShift, make product demo, and introduce customer to open source technology. So the stage is yours, Joseph. If you have anything from me, just let me know.
Okay. Hello, everyone. Today we are going to speak about Quarkus. What about me? My name is Joseph Assiga. I am a senior consultant at Red Hat. I am working mainly to install OpenShift to customer, help migrate workload on OpenShift, give a customer some kind of best practice for the presentation and also presentation for Red product, and also assist them to on the DevOps adoption and also in the practice. What we are going to see today, we are going to speak about Quarkus, why Quarkus, how Quarkus works, and we are going to end it with a little demo. Why Quarkus? As you may know, Java has done 28 year this year, and at the beginning, Java was created in the day that Kubernetes and container were not existing yet, and also the startup time and also the CPU in memory was not really a concern. As the new paradigms appear, like microservice architecture, event-driven architecture, we have to define a new tools and also a new approach how to solve, for instance, the startup of the application, and also solve the issue with the consumption of resources like memory and the CPU. That is where Quarkus is coming. Quarkus came to rethink how Java is built, and also to build a runtime that is comparable to a Go application. And Quarkus being many capabilities and functionality. The first one, the developer choice. Quarkus, as I said, Quarkus is based on standard. We are using a lot of standard library that has been using for decade now. The library has been tested, and what we have with Quarkus, we can do mainly 80% of the common tasks. The second benefit will be, for instance, Quarkus also is built in mind with microservice architecture, and also with the function. Why? Because Quarkus provide, for instance, the low memory utilization, which optimize the container density, and also container density microservice architecture, and Quarkus also deliver a significantly reducing size of the application, which will produce application to start up very fast, and also will give application the possibility to have a good speed when you start it, or when you want to debug it. Quarkus also, what I really like about Quarkus is also the possibility to use either the imperative programming or the reactive programming. You can use both if you want it, but Quarkus gives you the possibility to use that. And when you use it, for instance, if you use the mix of this programming, Quarkus will guess what is happening for you, and will do the building of your application for yourself. You don't have to worry about that, or to build an imperative application build an imperative application, build an imperative application and a reactive application separated. You can build both. What? And also, aside of that, Quarkus give you the possibility to use, as I said, to use the best framework, the best library that we have out there. We have a Vertex that is used for reactive application. You have a microfile that is also used for reactive application for Java Enterprise. You have the extension to deploy on Openshift, to deploy on any Kubernetes application or any Kubernetes platform. You have, for instance, a library for Jaeger, Hibernate, and REST-easy, and Apache Camel. Aside of that, you can also aside of that, Quarkus also give you the possibility to build your extension from scratch if you want. Now, what we need to know how Quarkus work. To begin with that, I'm going, for instance, to show you how a standard framework is working. A standard framework is working like this. You have at the build time, you have the packaging with either you are using the Maven and Gradle. And the runtime, at the runtime, you have a lot of action that is undermined of the runtime. You have the load of config file from the file system. You have the class path scanning to find some annotated class to embed them, and you have the construction of topology of the application, and you have the start of the different application. This is the standard. This is how we handle, how a standard framework is handled to build an application. How Quarkus is working, as you can see, everything at Quarkus is done at the build time. We have managed to handle everything at the build time. At the build time, what you will have the loading of the different package. The loading of the different package will be done at the build time. Do it once, not each time when the application is started. You do it one time. All the bootstrap of the class are not loaded anymore. You do it only at the build time. And also you will have less time to start and also less memory to use, because everything is done at the build time. It's done at the build time. Less or also no reflection are also done. Quarkus also make a native application, and you have the runtime. At the runtime, you just have your artifact that will be executed for your application. As you can see, you have much of the work that has been done on the build time, where you will construct all your application. You will load all the package. With that, you will have an application that is more dense, and also the startup of the application will take less time than a regular framework. With that, I will show you a simple demo. The demo will in this demo we will have, for instance, two microservices, a person and a calculator. I will show you how to create, for instance, the microservice. And when we will evolve with the presentation, I will show you, for instance, how a microservice can communicate with another microservice if we don't have, for instance, an API gateway. How can we do that? And how also, for instance, the microservice person can use a method or action that is belong to the calculator microservice. in Quarkus, if you want to create a project, you can use this one. We will not do that here. I have already done that. For us. You have the RESTful person service here, and also I can if you want to launch it, you just want to launch it. I don't know if you are looking. Okay, sorry. Okay. Now I will launch this. I will launch the person microservice. I will do it firstly in the. We do it first in the local when we want to launch the microservice. You just do it. You just make a Quarkus the dev, and Quarkus is the CLI to develop a Quarkus application. He will start. He will make he will make all the build for you. As you can see, the person that we are using a person with a name buff eyes, and also we are using a database, an H2 database locally, and you can get access to the really easily. And get access really easily of the application right here. And you have the different method that are developed for the microservice. Here it is the different REST API that will handle the different microservice that you have here. Now, what I will do, I will try to deploy it on OpenShift. Hope it is work really fast, because locally I don't have a Postgres application. I will deploy a Postgres application. As you can see, I came here in OpenShift. I just choose a database. And also I choose ephemeral instantiate. Give him the different name. And then I will create my instance. I will create my database instance. While it is creating, I will deploy it. To OpenShift. And if you want to deploy, I will wait. Okay, everything is good. You have everything. I will give him. I will deploy. I will show you the command to deploy. This one, it is deploying the application. Okay, doing the different test. Okay, but before doing that, you need to be sure that locally you are connected to the OpenShift. Okay, as you can see here, he has created a build config, and also he has created a build that is. He will create a build. Okay, he has created a build. the builder will be launched to create an image. Okay, it is working. Okay, it is building the image. It is building the image. As you can see, I don't have any Docker file in my application. He is doing for that automatically. Okay, he has finished the building. When he's finished the building, he will create all the different, as you can see, he has created the deployment for us, and also he has finished. You have the application, you have the application that is deployed, in fact. And you can go, for instance, here in the terminal to see if the database has been populated. Okay, as you can see, the database has been populated, and you can also get them here. We do it. Okay. Now you have seen that we can how we can deploy with OpenShift. What we are going to do now to deploy to OpenShift, you have this command. Now what we are going to do, we are going to help, for instance, to help help communication between two microservices. How to do that? You add this extension Quarkus REST client to the project that want to use the remote method. You add an interface with the same signature as the remote method. You inject the interface, and also you configure the application property with the FQN of the interface, and also the different the host name of the microservice that you want to obtain. For instance, if we'll okay, for instance, I will try to I will start this application. We see that if I want to use a method that is not in the person, I will want to test the using of the method. Okay, everything is correct. Localhost. Okay. I want to use person calculator 23 or 22. If I try to use that, we will have an internal error because the calculator is in another microservice, and the microservice is Quarkus calculator RESTful service. I will start it. Okay. I will start it. Okay. As soon as I start it, if I refresh it, I will have an answer. I will have a 57. You will see in the log, this new microservice has received the call. I received the call, the equation to process 34 plus 33, adding 34 to 33. And you see the first microservice is not responding with error anymore. is just sending it's just giving you this log. That means that everything's went well, and the second microservice is taking the call, accepting the request by giving you this kind of log where you find out that he is responding well to the different to the call of the first microservice. This is how you can do you can make a communication in Quarkus. In fact, Quarkus, when we will configure the application point property, Quarkus will generate a REST client for you with all the configuration that we have given to Quarkus, and will make the call for yourself, in fact. And the second thing that I wanted to show you, I will stop the second application. The second thing that I wanted to show you is how easy to have monitoring on Quarkus. In Quarkus, you just need to add this library, Quarkus Micrometer Registry Prometheus, as easy as this, and you will have an endpoint. You have an endpoint where you can have a basic metric. For instance, if I do, as I have already done that, I will just do have your basic metric. And with that, this one is coming out of the box, and you will discover automatically all your different endpoints that you have been building. As you can see, this is for instance the endpoint person calculator with error, because with success, with error, the time is taking. This thing has been built. It is building out of the box. You just need to configure Prometheus to scrap these metrics and construct your Grafana, and also you can use Alert Manager on some metric to make a monitoring of your microservice. As simple as that. You also have the possibility to build your custom metric with Quarkus. And also we can have some security. To that, with security, you just need to add a Quarkus security GPA, and you can add this kind of annotation on top of your endpoint to specify that this endpoint is only allowed for a person who has a role admin. It is already developed. If I go to Quarkus, if I go to this endpoint person admin, you can see I have access to local resource was denied. And if this is here, and if I remove it, if for instance, because Quarkus is giving us a live reload, you will see that I can have access now to the endpoint. It is reloading. You have access to the endpoint because I've removed it. Everything is building is reload automatically. You just need to save. Everything is reloaded. As you can see, it is reloaded, and we have access to a local endpoint deny. You have a 403. Once we finish, we will have also you have also the possibility to build a fault-tolerant application. To build a fault-tolerant application, you just need to add the library Quarkus Morai fault-tolerant in your project, and you can use this kind of annotation, retry, max retry of an application, the timeout, and the fallback. All of them with just annotation, you can do a lot of things. How do we do that? I have created this class. If, for instance, I will, for instance, the first time I will comment the retry. In fact, what's happening here is that this endpoint in fact is failing 15% of the time. If I go, for instance, to the endpoint fault tolerant, okay, if you refresh, you have an error. If you refresh, you have the endpoint. 50% of the time, the endpoint will fail. If you want to remove that, you can have, for instance, the retry. The retry will help mitigate that issue, because it will retry automatically the endpoint for you, and normally you will not have an error anymore. As you can see, we don't have the error anymore because the retry is taking into effect, and everything is done for us. You see, you have the error. Because you have the error, you have the retry that is called, and retry the method for us, and then we don't have the issue anymore. In fact, another method that I wanted to show you in the fault tolerances, it is about the timeout and the fallback. Sorry. The timeout and the fallback. In fact, you have when you will be in the timeout, you will have a method, a fallback that will be called. In fact, how to put it in practice? I have, for instance, this method that where I wanted to have a certain person ID. If I don't find this person ID, I will have an error. And you have an error. I will first comment the two. Comment the two. I will put fault person. I will okay, fault person. I have that because I have the ID. If I put, for instance, 8, because 8 does not exist, it will send me an error and will point a pointer exception. Now, because of that, I will try to do something. If you add, for instance, a timeout because you have either a null pointer of exception, or either a backend that does not, your database does not respond in time, you can add a timeout. And also, you can add the fallback. For instance, if you want to handle this issue more beautifully. If I retry it, normally what the fallback method is doing, the fallback method is this method, and you need, when you construct the fallback method, the fallback method need to have the same signature as the method that will call the fallback method. As you can see, we have the same signature. The signature is what I return and what I receive. This is the signature. The name is not really important. In the signature, you have the return and you have the receiver. As you can see, it is the same type. And if I do it again, normally it will, voila. As you can see, the fallback, we have the fallback because I have this user, in fact. I don't have any more an issue. As you can see in the error, falling back to fault tolerance resource, and you have this one, in fact. Okay. I think it is. Thank you for coming. If you want to have more knowledge about Quarkus, you have the information here. I have also the repo that is also public. You can also follow me on Twitter. And you have 2 books, Quarkus for Spring Developer and a Reactive System in Java. Thank you.
Thanks, Joseph, for the presentation. And to our audience, please write your question because it's time our QA. But the QA need more people, more speakers. So welcome, Trista. How are
guys.
you?
Hello, everyone.
And we need one more to
I
discuss.
am here.
Hi, Bobur.
How are you doing?
Hello.
Now we have our first speakers during this conference, and we have some questions for all of you. The first one is for Bobur. There is any way to simulate locally the way of Azure Cosmos DB, like I don't know, local stack on AWS or something like that? I think in an integration test or something like that need to run every time in a pipeline, or I don't know if exists or not.
Yeah, if I understood correctly, I was asking how to set up dev environment for the same demo I showed, right? It's possible with Azure. You don't have to deploy anything. For example, what I showed also was on my local host. The functions were running on my local host, and I had also the storage, Azure storage installed. Even we can a little bit simulate the upcoming events and items from Azure Cosmos DB. That is also in my example. You can have a look. Otherwise, of course, I fully understand that yes, you need to test everything first before going to Azure, and maybe write some integration tests. Integration tests, yeah, can be written also in Java. Maybe you can use Cucumber framework and maybe similar frameworks you are familiar with. Yeah. I hope that answers the questions.
Thanks. I have another one to Trista. When do you recommend the use of the JDBC instead of the proxy? In which case?
Okay, all right. So because I did some statistics from our open source community, and I found that if your application was developed by Java, and then I recommend use the Sharding Sophia JDBC because you know that it's the fitting for JDBC program. But the second one that actually JDBC, it's a driver, right? There is no database proxy, so you no need to deploy it in a machine or in a server. Therefore, I guess that will easier for user to use it and set up. And also because there is no proxy, so the performance of Sharding Sophia JDBC is higher than proxy. But actually, for in terms of the proxy, I guess most of the people love it because it's really like a database server, right? So people don't care about their development programming, their language. They just deploy the proxy and use it at the database. So that's the difference, I guess.
Thanks for the answer. And one more. If I add a new cluster, because in your example, your presentation, you have 2 different clusters. If I add a new cluster, the detect automatically? I need to do something. What is the situation in that case?
Oh, actually, if you already have a cluster and then you're questioning that you want to add more instance to there, right? So if your application it's built in the Kubernetes, I guess you can just use our operator. You just to declaring that you want to add more instance, then everything is automatic.
Great. I have one question for Joseph. If I want to write Kotlin application using microservices, there is any restriction in your experience to use Quarkus? Or is a best alternative use Quarkus with Kotlin? I reformulate the question.
I don't think there is any restriction. Quarkus is we have a lot of example of using Quarkus with Kotlin, and we don't have any. We have not have any remark yet that we have any issue with using Quarkus with Kotlin. I think you will be fine.
Okay. You show to us the process of build an image. There are some guides, some best practices that you need to know to improve the performance in the build process, because the build process in your presentation is take more time, but the run process is just so quickly to run an application. So there is some tips or something like that, or a link or a blog or something like that contains all this kind of information?
I think there is always a way to build a better image, to have a small container or something like that. I don't have the link here, but I don't know if there is a way to send you a link, because I have some colleagues that have done a lot of work around customizing or customize. How can I say customize? Around of designing a better container or something like that. Is there a possibility to send this information to the person who asked the question?
Okay. I have a question for Bobur. Does the event publish from Cosmos R store as well? Kind of event store, or for the audit or troubleshooting purpose?
Can you repeat one more time the question? Like event stored somewhere outside of Azure or Azure Cosmos DB?
Okay, makes sense.
Can you repeat one more time the question itself? Like, if I gotta understand it correctly.
I think it's not event. It's when you throw something and the database detects that something need to be run. I think this event is stored in some place. I know.
Got it.
I don't know if it exactly works the same that a queue or something like that.
Yeah, now I understood the question. Like, yes, in Azure Cosmos DB, the events stored in events storage, they have a separate storage. Then let's say when something is created on Azure Cosmos DB, it creates another event change feed that stores inside event change feed for some time until some other connected services such as Azure Function and maybe something else gets this data and fetch some of this kind of events, and then after that maybe it just cleans this change feed after some period of time. Until then it's storage, of course, as a cache in the middle of a layer.
Great. I have a new question from or to Trista. What is the difference between sharding sphere and load balancer?
Okay, so load balancer, I mean, actually sharding sphere, it's open source named. It consists of 2 clients. And then one of the feature of the sharding sphere is it can help user to do the load balance. I mean, especially about your databases, because your application want to visit your databases instance, right? And if your databases instance have their role, like the primary role or the replica role, then people no need to care about, I mean, from their application view, no need to care about your the replica role or the primary node, because when your application just visit sharding sphere, proxy or GDBC, proxy and GDBC can do the SQL parsing. You know that this querying is just for get some of the readouts from the replica. Then it can help a user automatically do the load balance. Yeah. But actually, it has another, I mean, great features that the load balancing is just one of them. Yeah.
Next move to Joseph. What is the advantage of use Quarkus instead of SpringBoot, for example?
Yes, in fact, both as a reminder, just as disclaimer, Red Hat offer the possibility to move to migrate application from SpringBoot to Quarkus very easily. And the second type is Spring Boot and Quarkus are mostly the same, but Quarkus is building in mind with Kubernetes platform with Kubernetes platform in mind. That means smaller footprint of container, smaller startup of application, and also the best library to build Java enterprise application out there. And everything is outsourced, and also you have the support of the Red Hat community of the Red Hat if you have an issue, for instance. In fact, it is the best tool to build a Java application right now if you want to have the runtime of your application that is similar than like Go, in fact.
Yes, and in fact, there are a lot of similarities in the notations. More or less change words, but if you want to migrate from one to another, there is not change radically.
Exactly.
And there are a lot of similarities, so perhaps take less time to migrate to SpringBoot to Quarkus that another frameworks like, I don't know, Spark framework, which don't have a lot of documentation, but looks great.
And also the reactive Quarkus also give you the possibility to make a reactive application and imperative application. You can mix the both. There is no issue with that.
Next question. Could you discuss the backend of Signal service?
A nice question. Do you know, like Signal service, the history, it's coming from basically .NET technology, because at the beginning it was initially built for .NET. There was open source project called Signal service, and then Azure enabled it on the cloud. Now you can use the same open source Signal service in the cloud. But this time you can also write some code in Java in your maybe programming language you are familiar with, like JavaScript and so on. Basically, Signal service has a set of SDKs that you can install on the UI and import as a library, JavaScript library on the UI side. And that's how it works. Actually, it doesn't work on the backend, but mostly for the front end. That can fetch some data in real time from backend server.
Looks great. Next question for Trista. How do you maintain a data consistency across shared cluster?
Oh, that's a good question. I mean, currently, because you choose to shard your databases, I mean, one single databases become many portions. So people will consider how to do the data consistency. And currently for sharding Sophia, actually there are two plans. The first one, we just use the XA pathology. I mean, XA, I mean, how to say that? A Java transaction protocol to guarantee the data consistency there. Because like with the MySQL or PostgreSQL or SQL Server, most of the DBMS, they persist that the XA topology or so therefore we can just call such the functions among different database instance. But sharding Sophia, it's like the manager, right? The transaction manager, and it will coordinate all of the XA process between among different database instances. The second one actually will consider a more better, I mean, the data transaction, global transaction solution, because in some of the cases, people will want to get the final, I mean, the consistency. So in that case, we also support the soft, I mean, how to say the soft? I mean, the final or the global transaction consistency. And there are two scenarios.
Okay, there are one question related with the shared and the transactions. If I have data is shared among several blocks, it's possible to make a deployment system that doesn't cut off a current transaction, for example, in a retail, not lose information with a card.
Not losing the info. If a shard among several blocks, it's possible to make a deployment system that doesn't cut off current.
I think that our audience tried to say that if I have a transaction running and I need to deploy something, what happened with the transaction that are running?
Okay, so like I explained before, if you use the XA transaction tab, and actually we can guarantee the transaction. I mean, it will not lose the data or the each SQL or each execution. But there are issue in these scenarios. That is, maybe you will see some commits during one global transaction. So that's the issue. But it will guarantee that data will not lose. Yeah.
Well, next, our speaker, Joseph, what are the new features that will have the new version of Quarkus?
The new feature with
have support, for example, have support with the latest version of Java. I think the last one is 20 or 21.
No, I think the last one is what we are supporting right now. It is Java version 17. We have Java version 17 and also Java version 11. In terms of what will be the new feature? It is a tricky question because I am not in the engineering.
It's okay.
Yes.
Most of us
I'm just a consultant.
New.
I'm not in the engineering side. But sorry.
Let's move for another one. In your experience, what is the most common mistake that could happen during a deploy on an OpenShift application using Quarkus? I don't know,
think
the
the
connection.
most common mistake is that when you needed to be sure that your secrets are really secrets, in fact, and not put everything everywhere. Avoid committing some information on GitHub. We have a lot of tools right now that can handle secrets for you and help you, for instance, hold your secrets but encrypted on a public repository. That is the first thing. The second thing I will say, the S2I, the method that I use to build the image in this presentation is not something that you can use for any type of application. For instance, some client that I used to work with them are using that the S2I, because the S2I does not use a proper Docker file where you will have you will put the different instruction to optimize the construction of your image. You don't have that. The S2I will do it for you behind the scene, and with that, it will take a lot of library that can be at some time can double or can double the size of your image. Don't be careful with the S2I. If your application is really monolithic, don't do the S2I. Don't do the S2I right away. Try to use a microservice and remove some library and re-architecture your application to use the S2I. And also the last thing, I think I will advise it is really use the GitOps practice in your development. Some people does not use that, and in OpenShift you have a lot of tools that can help you with the GitOps really easily, and everything is already installed with your OpenShift cluster. You just have to get them and work with that.
Thanks. What we have another question to Trista. Is RDBMS with sharing sphere equivalent to a distributed SQL database like CodeRanch or Gigabyte?
Oh, I think it's a good question because I guess the question reader really look at the sharding Sophia's feature. Yeah, in some degree, they're saying the solution for user to consider the distributed database because when we talk about the corporate DB or Yugabyte DB, all of the distributed database are made of two components. The first one, computing node. The second one, the storage node, right? So if we talk about sharding Sophia, actually, it also consists of two parts. The first one, your DBMS, it works at the storage node. And about the global computing node, you can use sharding Sophia GDBC or sharding Sophia proxy. It will work as a computing node. Therefore, and also sharding Sophia can help you shard your data, right? Make it become the distributed one, and also can help you do the reshard later on if you found you need more storage or computing power, right? So from this perspective, yes, sharding Sophia, it's almost equivalent to a distributed database. But actually, some of the people will doubt about that because you know that no matter Yugabyte DB or Corporate DB, they develop all of the project from the storage layer, right? But the sharding Sophia just leverage the currently or existing database system. Yeah. So for some of the open source community users, they prefer sharding Sophia because they think that they don't need to totally change all of the database infrastructure, right? They can continue to use the existing database infrastructure, just import sharding Sophia into their database system or database infrastructure. Then it can help them efficiently to own a distributed database infrastructure or architecture. Yeah.
Thanks. Next question. Bobur, which frameworks help to developers to simplify the process of integration of events node? But which framework? For example, I think SpringBoot have a lot of modules that create some kind of abstraction, and you can build something. There are another ones, or are not recommended.
Yeah, sorry. Nice question. I think, of course, I'm not quite aware of all the solutions currently in this ecosystem. Not only in Microsoft ecosystem, outside of Microsoft, there are many solutions. One of them I can suggest is Apache Kafka extension for Azure functions. This is actually a nice feature. I think we demoed several times, and there are also some tutorials that you can reach and learn about this. It is for more advanced event-driven solutions. That what I gave to that example is more about how you can get started and then integrate the advanced the Kafka solutions in later stage. Or maybe you can use even event hubs on Azure for IoT devices or IoT solutions. That's another event-driven the framework you can use. Now, of course, as you mentioned, you can always use Spring. Spring has some other features, and it under the hood it works also. It brings event-driven solutions, and we have this Azure Spring app. There are some other resources you can have a look.
Great. Next, I think it's not a question; it's a request. You need to share the
link. Yes.
Yeah. We will share in the chat of YouTube, so you have the entire question or the comments. So it's okay. Well, let me think. Someone. It's just in your experience, Joseph. There is any restriction to use Quarkus in a microservices?
No, I don't know. I didn't know. I don't see any restriction. Quarkus is really built for the microservice world. In fact, everything that is micro X, Quarkus. This is the world where Quarkus will shine. In fact,
I think this one we discussed, which is what is the main advantage of using Quarkus. And more or less we discussed during this QA. But if you want to add something more, Joseph?
Yes. Apart from the fact that we have a better startup for the application, and also the footprint of the different application of the different container, I think we need to emphasize in the fact that Quarkus really give you is build the model of Quarkus is that we are using the library that has been tested. It's not something that is taking like that. It is the extension that Quarkus will give to you. It is the extension that has been used for a decade now in the development of a Java application, and both of these and those extension will have will be built around imperative and reactive programming that you can that you can use in the building of your application, and you have a lot of extension to deploy to create a Kafka, to create an event-driven application, to an extension to use monitoring. For instance, if you want to use OpenTelemetry to have an observability for your application, you can use it with Quarkus. So we have a lot of things in the pipe. And lastly, Red Hat. I think Red Hat support is not meaningful. And if you're using it and you have some issue, you can also ask support to Red Hat, and they will help you.
Next question, and we are near to the break. Which resources do you recommend to learn more about event-driven, Bobur?
I have tons of resources I can share, and if you don't mind, maybe I can share some of the links. If you can pass these links, that would be great. Because now, if I count any of them, it will be difficult to find out or Google some sort. The links, I will provide the links for sure. Thanks for the question.
Thanks, and I think this was the last question, because now it's time to have a short, very short break. So thanks all of you for your time, for your presentations, and for sharing with us your knowledge.
Thank you, Andres.
Okay, thanks.
Thank you,
everyone.
Bye.
Bye-bye.
See you. Bye.
What an awesome day to be together here at Global Summit for Java Devs. We want to say thank you to our sponsors from Microsoft. Thank you for joining us. And just a quick shout out to their Azure team, to their amazing products. So Azure is a cloud computing platform that enables you to build, deploy, and manage your applications across multiple clouds, whether it's on-premise or at the edge. So basically, Azure allows you to develop in the cloud and access a range of services that can help you to streamline your workflow and accelerate your time to market. And today we will have a special link in the chat that you can use to get yourself a free account at Azure. So definitely give it a try, and we hope this community will build lots of cool projects using Azure. Thank you, Microsoft, once again for supporting this event and this community.
The Microsoft Cloud runs in data centers which must be operational 24 hours a day, 7 days a week, all year, every year. This requires continuous monitoring of the data center's critical infrastructure, including power, cooling, network, cybersecurity, and more. It's all overseen by a Facility Operations Center. The Facility Operations Center checks hundreds of thousands of data points per day, each measuring the data center's operational metrics. Highly trained technicians inspect automated trends, resolving any issues as they arise. And beyond the data centers themselves, Azure AI uses machine learning to review those same data points. AI Ops is moving from reactive to predictive monitoring, so it can better prevent future issues. We also have teams of software engineers around the globe always monitoring our services, and thousands of cybersecurity experts analyzing trillions of threat signals daily. It's important to have constant availability and resiliency for our global infrastructure and cloud services. We continue to invest in and innovate on ever more precise monitoring and a more predictive approach to always be prepared for whatever's next.
Hi, everyone, once again, and welcome to the next block of the presentations. My name is Paul, and I will be your host for the next block of speeches. And the first speaker for this session will be Swapnil, and we will hear his presentation about Java in Visual Studio Code. So let's welcome Swapnil Gupta to this stage, and let's check his presentation.
Everyone. So we all know that Visual Studio Code has been very powerful among the developers, and we can use it for our Java development. As we know that Visual Studio Code has been used for many programming language, and what makes it very great when for Java development is their extension involved in that. Let's get started and learn how we can use these extension for our next Java development project. So getting started with Visual Studio Code, what you have to do, first you have to go to their website code.visualstudio.com and download it. So once you get downloaded for your Windows machine or your Linux machine or your for Macs, you get into your system and you get started with this. So what is the first thing that you will need to get started coding in Java and Visual Studio Code is the reading their documentation. So let's go head to the documentation website. As we can see that once you go to the documentation of Visual Studio Code of Java, they have very well written what is the thing that needed and what are the things are requirement. So basically, in starting, you can see they have a coding pack for Java. This is very essential. You can just download it and get started. You don't have to put hassle of anything, right? So you get once you download it for your Windows machine or your Mac OS, you will just get started. So what are the extension you will get with our machine? You can see that like these are the two extension you will get, right? But before that, one thing that you will get inside this development kit is a Java development kit. So there are this much development kit available for you, but by default or for this session we are going to use OpenJDK. right? You can download OpenJDK from this website, Microsoft for Java developers. You can get the Microsoft build of Open JDK, right? Or apart from that, you can go to the official website of OpenJDK and get downloaded it. Once you get downloaded it in your machine, you can just search for environment variable. That is one most important thing that we have to set up before coding in Java. It's very important if you set up as variable. So we will click to environment variable, and we will set Java home, and we will point that folder as our path, right? So this will become our Java home, and we will edit it and browse this directory to the path. And right, and other thing that you can do, you can edit the path, right? And you can just set it over here as well, Microsoft JDK, right? You can just browse to that path as well. Okay, once you done this thing, you will set up your environment. Your environment will be set up, and to verify that, we will had open the command prompt, and we will just type that Java space version. Okay, so you will see that I have two Java version running in my environment, right? You can just look into that. If you see this message, uh, your Java development kit has been successfully installed on your machine, right? So once you get installed, once you get done with this, you will have extension and you're ready to go. After this, we will head out to our Visual Studio Code to write our first program. So we have created a file named as hello world.java, and we can just type it system.out.print new for new line, and just type our message. Let's call it hello Java, and we can run our first program in Visual Studio Code. So you see that hello Java is printed on our screen, and instead of writing system out.println, we can just write so, and you will get same thing. So there are extension that is used inside our Visual Studio Code that will help us to code easy, and it will also find us error and debug our code. Let's see what are the extension that is available to us. So first extension that is available to us is language support for Java by Red Hat. So language support for Java Red Hat always help us whenever we write some wrong code, or whenever we wanted to code autocomplete. It always comes into picture, right? It always come into picture, and it helps us to find where we needed to get our code corrected, or where we needed to add some more code. So this support our whole throughout project, right? So apart from this, you can see, go to the next extension that is available. It is debugger for Java. So basically debuggers are used to debug our code. So it is very helpful when we are finding the bugs in our code or anything. So we can just check in our Visual Studio Code how does it work out. So let's see. There is one more file that is let's say we call it hello, and there is one message we have printing, right? We have passed a message hello world, and there is one more message, and also there are two variables that is there, and we have passed into some. And let's try to debug our code whether the every value is passing in every variable or not. So once we click to debug, it will start a debugger. We will start in debugger mode, and once the debugger is started, you will get something similar interface. So as you can see that in our message variable that we have written, it's a hello world right now, right? It is passing correctly, and you can see the message hello world is going correctly over there, and the code will not execute till the end, right? The code will not execute till the end because we have a breakpoint over here. This red dots are breakpoint here. We can put it anywhere in our code, and we can just have capability to stop our code in between, right? So another pointer we have put over there, so our next code will execute over there, and let's check whether in A we are getting the correct variable or not. So yeah, let's check it out. So here you can see that in our let's check it out. Let's run one more time. Yeah. So in our A there is a 5. In our A there is 5, and in B there is 6. In B there is 6, right? So in they give total sum of 11. Let's see, check it out. And then program will completely run to give you output. And then when we program run execute it completely, you will get output on your screen. So debuggers are very helpful when we are finding our code. So this is a small code, but in case of loss scenario we need to check line by line, or we need to create breakpoints at different places. So it comes very handy to have a debugger as a tool in your system, right? So let's talk about the next extension that we usually see is that test runner for Java. So testing is also very important. When you have to test your code, when you have uh, run some test or debug and then run some test on that as well, you can use this tools. And this has three frameworks that will help: JUnit 4, JUnit 5, and TestNG. So this will very handy when you write test cases for your project, or you are just wanted to test your project, right? So this is very important tool as well. And one is project manager for Java. So apart from that, you get similar support. And other thing is that when you are building a Java project, you need a dedicated project support. So you can see that Visual Studio Code also gives you a Java project explorer or Java project manager, where you can manage your project and see the classes name, see the file name, and see the directory name. You can build the project from over here. You can do a lot of actions from here as well. You can configure path as well. You can export as jar file as well, right? So this will become also very handy while we are doing Java development, right? Let's talk about next debugger. So next is Maven for Java. Maven for Java is also a project manager that helps you to build the project and gives you short command like uh, in Visual Studio Code we can run Maven command. Basically Maven is project manager that helps to manage your Java projects. And this is especially comes into picture when you are making Spring projects. So we can get a lot of option over here. You just have to go to your Visual Studio Code and just type Control Shift and P, and you will get your command palette, and you can just type Maven, and you can just get a lot of commands that is available here that we can use it, right? You can add a dependency, you can create a new Maven project for your next Spring Boot or a Spring project, right? So this tool is also very handy. And apart from that, IntelliCode, this is very also important code. If you try to write some wrong code, or if you try to make mistakes, like this will start highlighting things that, see, you are doing right wrong thing, see you are doing right thing. If you wanted to do things with that, if you wanted to make change, update things, so this will give lot of support to us, that it sends our code, it reads our code and auto corrects it. That's a very great tool, right? So these are the extension that is available to us. And you can see a whole bunch of extension that is available to us, especially also talking about, you can also get the Spring Boot extension, right? So when you work with Spring, you can get a Spring Boot extension. So this is also very handy tools. Personally I used to use STS or another projects for building Spring Boot, but once I get to know that Visual Studio Code has whole dedicated support, I'm loving this feature, and I do all of my project on Visual Studio Code. You should also give it a try, because you should create a Spring Boot project on Visual Studio Code and just give it a try, right? So these are the tools that we have available to us. There are a lot of other extension support that we have. And you have also Eclipse and IntelliJ IDEA key bindings. So shortcuts that we have using key bindings using in your Eclipse, in your IntelliJ, that you must be comfortable with, you can use it over here as well. Apart from that, you can basically, if you do work on if you work on Azure, there are a lot of tools, lot of support available over there. You can run Visual Studio Code environment over there, so you can just check out those things as well, how you can use that. There is documentation, and I have also given you the link. And one more good thing, that you can check out this website, how to get started on Java on Azure. Basically, you will get Visual Codes like Visual Studio Code environment over there. So it will be very handy if you go through this, right? So you can create your application, and you can scale your application with that. So that's all. So far we have seen that how we can run our program in Visual Studio Code, but let's see how we can run our Spring Boot program in Visual Studio Code. Spring Boot is basically framework of Java, and how we will learn in this section how we can create Spring Boot project, and how we can open it code spaces. And first of all, what is code spaces? And to make our process easier, Visual Studio has come up with some extension that have shown Spring Boot tools, Spring Boot dashboard, and the Spring Boot initializer, and Spring Boot extension pack, right? So let's get started. So once you go to the documentation of the website, you will see that there is a special documentation for Spring Boot in Visual Studio Code as well. In that, they will show you that there is Spring Boot tools. Basically, Spring Boot tools help us to handle day-to-day operation that we do in Spring Boot, right? So basically, it will provide you to access all the Java files or the application properties files and the YAML files. Basically, this is the Spring Boot tools. Basically, the popular Spring Boot tools STS support has been now supported by Visual Studio Code. And apart from that, there is a Spring Initializer. So what Spring Initializer is, basically if you wanted to create a project just inside your Visual Studio Code, so Spring Boot Initializer will help you to create your project. It will help you to create Maven project or the Gradle project. So this is really very fast to get your Spring Boot inside the Visual Studio Code. You don't have to leave the application or go to some another website. There is one more way that we will talk, right? How we can create Spring Boot project. So there is one more thing, Spring Boot dashboard. So basically, Spring Boot dashboard basically shows what are the application you have been working on till now. So it will show you all the beans, all the Spring Boot projects that has been opened, and what you have been working on, whether you are debugging it, testing it. So everything is available over here. So these are the three extensions that we will talk about. Convention before Spring Boot support, and in Visual Studio Code, there is one way where we used to create our Spring Boot project, that is start.spring.io. So we will select our project type, we will select the language, that is Java, we will select the version, we will select the group. Let's say call it Swapnil XI. You can name it any Swapnil XI. You will name it as Spring Training, right? So it will give you a Spring Training artifact. Just you have to keep it small. Spring Training, and you will put the Spring description, training project. You will choose the jar as a packaging, choose the Java version, add the dependencies, right? Spring Boot Dev Tools, Spring Web, Lombok, right? So you choose some of the dependencies, and then you will click on generate, and the project will be generated. You will extract it and open in Visual Studio Code. But there is native support provided by Visual Studio Code, that we will see just how we can just open inside our Visual Studio Code. So for that, let's hit to our Visual Studio Code, right? Visual Studio Code. So once you open your Visual Studio Code, one way is to go through this. You can get started with from here, right? You can get started from here. And another way is just to go click Control Shift P. And if you wanted Gradle, just search Gradle. You can create a Gradle project, but for now we will want a Maven project. Bring just a second. Control Shift P, and we will need a Maven project. This is on the top. Spring initializer. Create a Maven project. We will create a Maven project. We will choose the version just like we did. We will choose the Java as our language. We will call it Swapnil Okay, as my group, and we will name it as Spring Training. We'll choose the jar, and we will choose the Java version, and we have selected some last from over here, and you can just explore yourself and choose some version, choose some dependency. You are always free to choose new dependencies or whatever dependencies you will need as per your need, and this all dependencies will be shown in your pom.xml file. Let's see, we have selected some dependencies from the last time, and this will generate your project. We will go and choose your desired folder and generate into that folder. Your Spring Boot project has been set up, and you can just open inside your Visual Studio Code. Right. Once you have opened inside your Visual Studio Code, you will see the dependencies you have selected, you have imported, is going to reflect over here as well. And you're always free to add dependencies inside your Spring Boot project. Say Control Shift add dependency, and you see, we talked about the Maven extension, right? And the project is based on Maven, so the Maven help you to add a dependency, whatever dependency. Let's say you need a JPA dependency, JPA. It will show you the list, and you can choose from over there, or you can choose any dependency from over here. SQL. Or you need a MongoDB dependency. Let's say MongoDB. We'll search MongoDB. Mongo. It's not working properly. Let me check. Let's add a dependency and let's put a keyword Mongo. Okay, so this is taking some time to load it, and you see that there is a Mongo dependency. We get a lot of version, lot of plugins from different project builders, right? So we can choose as per our need. So this is the MongoDB driver, so we can use that, right? So this is the we can we don't need to leave our Visual Studio Code, and we can add dependency, whatever dependencies we wanted to add, right? So this is very handy when we are working with the Visual Studio Code and Spring projects, right? And let's go to the main and try to run the program. Let's see, this is the program, and we can run inside our Visual Studio Code. Spring so this is beginning. Okay. Once you've done that, you can run the project. Okay, apart from that, let's explore the extension. The first Spring Boot initializer, you have seen that. And once the project is running, it will show you the output, right? This is not the perfect way to show your output. We will cover it in the Spring Boot section, but this is just for demonstration purpose, right? And let's explore the Spring Boot dashboard, right? Our dashboard, Spring Boot dashboard. See, here is your project, and it is running. It is showing you can stop your project right here, and you can open it in your web, right? So this Spring Boot dashboard become very handy. It will show you the list of beans that is available, and there is one is highlighting the beans, right? So there are a lot of advantages of using Spring Boot inside Visual Studio Code, and every support is given by Visual Studio Code natively. Let's see what else. So we have seen that how we can open it with code spaces. So you once you upload your project to GitHub, let's say you uploaded your project to GitHub, right? So you added your GitHub log. For now, I have uploaded one project to GitHub, that is Spring Training, that is already available on GitHub. So you have to go to the code. You have to go to the code. You have to go to the code spaces, right? Or once you go to the code spaces, you will choose a code spaces. This is one of the code spaces already running on main. Always you have always option to create new code space. And once you click the code space, the whole project, the overall project is also available in the cloud as well. The overall project is also running in the cloud as well. Extension that we just studied is also in the cloud, right? It will take some time, but once it is loaded, it is very fast. It is native like support. It is and just inside your browser. So code spaces are the basically project by the GitHub and the Microsoft. They work together, and you can open Visual Studio Code right into your browser, and you can open any repository, any project, just like you open inside Visual Studio Code in your terminal, you can open inside browser. And if you have low end computer, then basically this is a very good space. You can change the computing power of this, and everything will be available online. So this is a very great tool uh, to run your Spring Boot online. So basically you can prefer those. Let's check out whether we can get our Spring Boot extension over here or not. So you can see that the all extension are available here as well, and you can install here as well. So everything is running and everything is available here as well. Let's try to see that. In the project will be open just like inside your local machine. It will open over here, and you can run this project right inside the browser. Let's see. So once the project has been running, it started running inside the browser. Let's see. Okay, so basically our project is already running in the some port. So once you get started with Visual Studio Code, you will open inside your code spaces. The same interface of Visual Studio Code is available over here as well, and you can run your project just as you run inside your local machine. So just you have to click run. The project will start running inside the code spaces. And you can see this is a Spring Training project. You will get the Spring Training project. Let's check out whether we can get the extension over here or not. The same extension, the same things. Let's try to create Spring Boot initializer. So you will get the Spring Boot initializer. Maybe an add dependency, you can just simply go to the pom.xml, and you can add a dependency anytime you want, right? All you have to do is all you have to do, so you see that Mongo is dependencies are also available over here as well, right? So you can click and install and add your dependency on the go. So all you have to do, you don't you just are not able to open your project. Even you are able to open some other people project. You can contribute to other people project, and Visual Studio Code will directly open inside the browsers. So GitHub code spaces are very powerful tools if you are starting new. So I would highly suggest you to check into that. So we have talked how we can run our Spring Boot application inside VS Code or inside the code spaces. So we have seen lot of extension and how you can make your Visual Studio Code to run into Java environment, and you can do your Java coding and Visual Studio Code. There are a lot of resources that you might need for your future project, and you can just check out these project that I have put into links. If you get to chance, explore one by one, and you will learn how to code this better. And also do check out the Azure resources that will also help you to scale your whether your Java application or your Spring Boot application or your Spring application. So check out those. These guys are doing very great work. So it's been a great session, and thank you, Geekle, for inviting me, and thank you for listening to me. You are very great audience, and I'm looking forward that you will check out Java development and Visual Studio Code. So looking forward to you guys. Thank you so much. Thank you so much for joining. Yeah.
All right. Thank you for the presentation, Swapnil. And if you have any questions, please write them in the chat because we will have a joint Q&A session with Swapnil also. So please write your comments, write your questions in the chat. Maybe you have some questions about the dependencies or maybe about the plugins. And our next presentation will be from Utkarsh Srivastava. And we will talk about GraphQL with SpringBoot. So let's welcome Utkarsh on this stage, and yeah, let's have this next presentation going.
Everyone, and welcome to the exciting world of GraphQL and Spring Boot. In this session, we'll dive into the fundamentals of GraphQL and explore how it can be integrated with Spring Boot. But before we dive into it, allow me to introduce myself. I'm Utkarsh Srivastava. I work as a software engineer at Atlassian, and here are my LinkedIn, Gmail, and GitHub details. In case you want to connect with me, please reach out to me on any of these. Okay, so now let's get into the agenda for today. First of all, we are going to talk about what GraphQL actually is. Then we'll talk a bit on the need of it. That is, why was it created? Next part is which I love the most, and we are going to spend majority time of this session. I'll teach you how you can integrate GraphQL in a Spring Boot web application and show you a demo on my IDE. Then we are going to do some comparisons between GraphQL and REST. At the last, I'll be happy to answer your doubts and questions in case you have any. So let's begin and answer the first question. What is GraphQL? The official definition says GraphQL is a query language and runtime for APIs used to load and manage data needed for applications. Let me decipher it for you. So basically, GraphQL is a query language for your APIs. You can understand this by making an analogy with SQL, structured query language, which most of you would be aware of, is used to fetch selective data from your database. Similarly, GraphQL is a query language that allows you to fetch selective data from APIs. As you might have already guessed that in order to process this query language, there needs to be a runtime present at your server, and which is what the definition says, that GraphQL is a query language and a runtime for APIs. This will be more understandable when we'll go into the demo. So bear with me till then. And next thing which I want to talk about is that it was created by Facebook in 2012 and was being internally used there. And it was then in 2015, it was open sourced. GraphQL has two major components. First one is the schema definition language, and the second one is the query language. Again, I'll dive deep into the demo section. What are these two and how they can be used, right? So let's jump onto the next slide and discuss why it was created. So the USP of GraphQL is that it allows client to have a control on what data they want to fetch, and hence reducing overfetching or underfetching. What I mean by this is, if you look at REST or SOAP APIs, in these APIs, servers mostly dictate what is the data which the client is going to get, right? So if you consider this situation, client one is asking for a user data and the server returns it, but it returns something which client one does not really need. On the other hand, client 2 is asking for user data, server returns it, and it needs some extra data which the server is not able to return. So in this case, you can see client 1 is overfetching something, whereas client 2 is underfetching. Right, this is the problem which GraphQL tries to solve, and again, it will be more understandable when we see a live demo of it. So yeah, let's go to the most interesting section and let's just open our IDE and start working on it. Before that, these are the topics which I would like to cover in GraphQL, and I'll just go on them one by one. So let's open in our IntelliJ IDE, and So I have a simple Spring Boot project here. So I'll explain the initial setup of it. So let me jump into the pom.xml file. So this is a Spring Boot application. So obviously we have a Spring Boot starter web. And then I have these two dependencies for database connection. So I have starter data JPA, and the next dependency is H2 database. The next dependency, which is our hero for today's session, is Spring Boot starter GraphQL. So this is the dependency you need to import in case you want to use GraphQL in your Spring Boot applications. Next, we have Project Lombok because I'm lazy. And then we have some dev dependencies, which is Spring Boot DevTools. So yeah, and then the last dependency is test dependency. So we can just see what all entities or classes we have. So you can see I have basically two packages in my project. One is entities. So I have an interface called entity, which has a method getID. And then I have two entities, which is post and users. So I'm trying to maintain a relationship between users and post, wherein post is the entity which contains the post data and user as the author. And a user contains the list of posts which this user has made. Then there is an enum, which again is entity type, and these are the two entity types which we have. So yep, I'll explain why I've created this enum on the later part of it when I'll talk about GraphQL enumerations. So just bear with me till that time. I have a repository, so I have a post repository which is extending JPA repository. Similarly, I have a user repository which is extending JPA repository. So this is my initial setup. Now let's just dive into it and create a GraphQL endpoint. Before that, so we want to expose a GraphQL API, right? So we'll have to do certain configurations in order to create that API. So what is the first thing which you'll have to do is that we have to create a directory in our resource package, which is called GraphQL. If you ask me why this particular name, this is the default place where Spring Boot looks out for the schema config in GraphQL. So as you import your Spring Boot GraphQL starter, it will look out for this directory and any files which are present in this. So I'll similarly, and for the same reason, I'll create schema.graphqls file in this. And this is the file where I'll declare my schemas. So if I talk about the first thing which I wanted to discuss about, that is scalars. So scalars are certain predefined types in GraphQL schema, such as, so if I can write type of X is ID, if I define type X with the field A, and I can name this to be ID. If I hit command and click on this, you can see there is a scalar definition. So you can see a bunch of scalars defined. So we have a scalar ID, we have scalar string, we have scalar boolean, we have scalar float and int. So these are predefined types, and by ID, what it depicts is that this field needs to be unique in this entity, right? So let me just go ahead and define our custom types, and I'll map the same entities which I have declared in the project. So there was this post entity. I'll pick all the fields from this Java class and declare a type as post. I'll paste all the fields here, get rid of annotations and these access modifiers. Right, now I can just declare the author was a user, right? So I can declare this as a user. Now this will obviously complain because it does not know what a user is. So we'll have to declare that later. Body was a string, we'll declare this as a string. Title was a string, again we'll declare this as a string. ID, I'll name it as ID. And if you notice, I have added this exclamation mark, which says that ID is mandatory for this type. So if we go ahead and now if we want to get rid of this complaint, we'll have to declare another type, which is type user. Oops. Yeah. So type user, I'll do a similar thing again. I'll copy all the fields from this. I'll paste it back here, get rid of annotations. and get rid of access modifiers and data type. I'll name it again as a scalar ID. Then this is string, so I'll give it a type as string, give email a type as string, and similarly password a type as string. And the last thing which I want to do is, now if you notice, this is a list of post. So how do I declare it is that I use square brackets and I write post. Now interesting which I can do is I can add an exclamation sign here which says that this list cannot contain a null object, and I can also write exclamation mark here which says that this list can't be empty. So this is how you can use the exclamation operator, and you can define certain conditions there, mandatory or non-mandatory conditions on your entities. So this is how we have declared user and post type. Now the next thing which we want to do is we want to declare our interface similar to what we did here. So if you see entity, we had an interface here. It's not that we have to map all the entities which we have in our project to the GraphQL schema, but I've just created the entity so that it is more logically mappable and like easier to understand and easier for me to explain the concepts as well. So I can create an interface entity, and I can define that this interface needs to have a field called ID. Now, if I implement this interface on post and user, I'll still have to declare these fields in these types. But if you notice, if I get rid of this ID, the compiler starts complaining. It says that the object of type post does not have a field ID which is required by interface entity. So this is how it enforces the types to have certain fields. So yep, so we have covered till here. So the next concept which I wanted to talk about is enumerations. The detailed usage of enumerations I'll explain in a while, but I'll just declare the enumeration. So I'll again use this syntax, and I'll declare entity type, and I can declare user in post. So yep. So this is what we have learned till now. And now let's jump into the core of it, like how do you actually perform operation, how do you query, how do you mutate. So the next thing which we have to define is which is a query, like how do you actually fetch out data from a server using an API. So what you have to do is that first you have to define a type, and this needs to be of type query, QUERY, and then you can give your operation a name. So let's say I want to fetch all users, so I'll say all users, and what this operation should do is should return a list of users. So this is how I have defined. Similarly, if I want to define all posts, I can define list of posts. So this is an operation which will return me a list of posts and list of users respectively. Now the next thing which we have to do in a Spring Boot application is that we have to define a controller. So I'll create a package controller. I'll create the controller here. User GraphQL controller. So the first thing which we have to do is annotate this class as a controller. And next, what I want to do is that if you see, there are certain annotations which the Spring Boot GraphQL starter provides us. We'll have to annotate methods in our controller class with those annotations. So this was a query, right? So so in order to map this query, we have a query mapping annotation. We have to declare a method which will return a iterable of user. And we can say all users. I can import this entity and I can return all users. So in order to return, I'll directly import private final user repository, and I can use Lombok to inject this dependency on constructor @auto_add. So I'll use this as find all, and this is how I can map my query. So if you notice, this name should ideally match with the name of my method. So this is what Spring Boot checks by default. This name should, the name of my method should match with the name of my operation in the query, right? If it does not match it, then we can use, let's say I want to rename it as all users, whereas this query is all users. So I'll just give this query mapping argument saying that this is the query I want to map this operation to. Okay, so the next thing which we want to do is we'll go into GraphQL. We want to enable this GraphQL. You see this configuration, GraphQL.GraphQL.enable is equal to true. What this does is that if I start my application, I jump to this URL. So if you see, this is the console which we would get by enabling that property. So Spring Boot GraphQL Starter again provides you with a beautiful console which you can use to use it as a API client for your GraphQL APIs. And if you notice, this documentation which this console has all the queries which we just provided. So it has all users, all posts. So we can use either of these, and let's try to hit a query. So what the syntax which I'll have to write for executing this query is I'll have to write a query, and then I can name this query anything. So let's say I want to name this query get all users and posts. And then I can define my operation, what I want to execute. So it is all users. And then I can define in these all users what I want to fetch. So my users can contain, if you look at my entities, my users contained ID, username, email, password. Let's say I want to fetch ID, then username, password. Let's just beautify it. Yeah. And I want to fetch these three fields only. So I can hit this request, and you can see I'm getting all these details from the repository. So if you notice, I've directly interacted with the user repository from my controller. This is not a production ready application, so I have not used the service layer. In ideal cases, you would have service layer interacting with your controller and then so on. But yeah, for ease of explaining, I have directly used repository layer. So whenever I'm hitting that request, I'm getting a call at this method, and I'm fetching the users from the repository, and I'm just returning them. And if you look at the users table, you will see a similar set of users, 1, 2, 3, and same set of users is inserted into the database. Similarly, what I can do is I can perform multiple operations. So if you compare it to a REST, in REST, you would have to make two separate calls, one for fetching all users and the other for fetching all posts. In this case, you can do that simultaneously. So I can write another query, which is I want to fetch all the posts. I want to get post IDs and let's say title of the post. And if I execute that, you can see there's data, and then there are all users, and all post is null. Obviously, because we haven't defined the query mapping and the controller for it. So let's define that as well. So similar to user GQL controller, we can have a different controller for post GQL controller. And then we can have all posts as the mapping. Let me just confirm it. Yep. So we have all posts, and now I can rename this to be post. Sorry, I can have this post repository, and I can rename this to be post repository, and this will return a iterable of post. Okay, so this is done. If I restart my server and hit the request again, so we have got all users, and then we have got all posts. And this post contains ID and title, which is what I wanted to fetch. Let's say for some case, I want to fetch user email as well. I can just write email here, and I can hit, and now I'm getting email field as well. So this is the flexibility which I was talking about. Clients can have a control on what data they actually want to fetch. Also, interesting fact about GraphQL is that since we have executed two queries in a single request, these queries are actually executed in parallel at our runtime on the server, and the result is then aggregated and returned. So whereas like if you see, this is a huge performance advantage. So if I specify multiple queries in a single request, I can hit a single network call and all the queries can be executed in parallel and the data can be returned. So this was about queries. The next thing which I wanted to talk about is mutations. So this we have learned how to fetch data from a server, right? Now the next use case, how do we actually manipulate data on our application? So if you want to make a like create a new user, how do we actually do that? So the concept which GraphQL provides us is mutations in that case. So similar to the way we provide, like we wrote down queries, we can define type as mutation. And then we can define what is the operation we want to do. Let's say we write add user, and what we want to do is that we want to create a user and then return a user. Now you would obviously expect I would need certain details from my client so that I can create users. For example, what should be the username, what should be the password, what should be the email. So I can get all those details as an argument. So I can write the argument as users, and now I can define what should be the type of it. So if I define user, you'd see this would give an error, and this says that the type user is not an input type, which is a point to be noted. For every argument which you accept in your GraphQL APIs, the input argument type should be input. So I have to define an input type, and let's say this is request, so add user request. And I would need, let's say, username from the client, which will be a string and a mandatory parameter. Then there will be password, which will again be a string and mandatory. And then I can have email, which will be again string and mandatory. Now I can define that this user request will be add user request. So like you would have already guessed, we have to map this to the controller as well. So let's jump back to our controller and let's copy this down. So in case of query mapping, there's another thing called mutation mapping. And in similar fashion, we have to map the name of it. So we can map it and we can write it as add user, let's say. An argument which we were expecting, we'll have to create an object for it, a class for it. So we can create a DTO object maybe, and we can create add user request. In similar fashion, we can have this to be a data entity, and then we can have private string username, private string password, and private string email. So this is our request entity, and now what I want to do is I want to accept this as argument. So I can accept this as argument, but additional thing which I'll have to do is that I have to write an annotation called argument, and I'll have to name it as the argument which I've specified in my schema. So I will pick this user, which is the name of my argument. I have to write this down here. So now, and obviously we'll be firing save method instead of find all, and we'll have to create a user entity. So we can create one final var user is equal to new user, user.set password, user.set email, and user.set username. So we can have add username, add user request.get username, and then request.get email, and the last is user.get password. And I can pass this user. Now this the repository will actually persist this in database and will assign an ID to it. Maybe I can return the entity which will contain that ID. So I'll just remove this iterable, and this way I can return the entity which is created to my client. So I hope this will work. Let's restart and see. Let's hide this. Also, if you want to refresh this after the application is up, yeah, you can see you got another definition here, which is mutation and add user. So like this is how we can, and it shows you what the exact request which the server is accepting. So you can refer and then fire that request. So if I can duplicate this tab and I can write, instead of query, you would expect this to be a mutation. Then I can say add user mutation. And then I'll have to write, obviously, add user. And from the created user, these are the fields which I would want. I would also pass an argument as user. And here I can define what is the argument. So I can define the username to be, let's look at what are the usernames which we currently have. So we have user till 10, we can have user 11. Then we can have password. You can have similar way password 11, and then we can have email as user 11. So this is how our request looks like. And if we fire this request, you can see we got a ID as 11. And if we refresh our database, we'll see a row inserted here. So this is how you can provide mutate your database and provide mutation requests to your server to manipulate data in your application. You would have already guessed I can do like add post in similar fashion. So I'll leave it up to you to do that. I can jump on to the next section. So the next section is subscriptions. So if we talk about subscriptions, like if I imagine a use case, if I want to subscribe to the event where I should be notified, or the client should be notified on every user creation, right? Then what can we do? GraphQL provides a very intuitive way to handle this situation. And in this case, we have to define a subscription. So in similar fashion, we'll define subscription. And let's say subscription is called on user creation. And this subscription will return a user, right? So like we'll obviously have to define a mapping. So we can copy this, and this will change to subscription mapping. And the name would obviously change to on user creation. And this doesn't need an argument, although you can provide if you wish to, but yeah, this doesn't need an argument. So I'll just leave it as it is. Now what I want to do is I want to asynchronously publish every user creation event as a response of this method. So I have to use reactive programming here. So I can write publisher from reactive streams, and this publisher will be written. Where do I get this publisher from? I'll use reactive streams again. So I'll have to define a user sync first, which will collect all the events, and then I'll use the sync to publish it I'll use the sync as a flux to publish it. So I'll have to write it as many syncs.many of user and user syncs .many multicast on back pressure buffer queues, small buffer size, and yep. So I have my sync here. Now I can create flux or the publisher, public final publisher user publisher is equal to, I'll use the sync, user sync as flux. Now I've got my publisher. So I can return this. Now you would obviously expect where would this sync get events from. So what I can do is I can use the sync here. So I can store this as final var db user, or I mean, like it is a bad name, but I'll just use it. And I can return db user, and I'll try emit next, and I'll publish this user. So I've published this event, and this will be returned. So if I try rerunning this application, Okay, and let's have a look at it. So we have provided a mutation. This is get all users. Okay, let me use this. Okay, so I can provide a subscription. I can name the subscription anything on user creation or whatever. Creation. And then I can obviously write my operation name. And what I want from the user, I want the ID, let's say I want username and password, let's say. Okay, if I fire this request, you see we have got error. And the reason for this is if you open debugging console for this, and let me just move this to a side, yeah. Open network, and if I hit the request again, you see this GraphQL request is actually a WebSocket request, and our SpringBoot application does not know how to handle WebSockets because we haven't enabled it yet. So what we are going to do is we'll have to enable WebSockets, and for that we'll have to head back to our pom.xml and add a dependency. So I'll hit command and add dependency. And if I search for it, Spring Boot starter WebSocket, if I click on this and add, so I've got this. I'll just hit a refresh on dependencies and hit a restart. Another important point to consider is even if you import this dependency, WebSockets are not enabled by default. So even if I hit this request again, this would fail again. So what we'll have to do is that in order to tell Spring Boot that you can use WebSockets for subscriptions, you have to head back to your configuration file and you have to define GraphQL.WebSocket.path is equal to your endpoint. And now if I hit restart, you could see that it has subscribed. And if I head back to my mutation query, where it is, yeah. So if I now create user 12, let's say, and head back to my subscription, you can see I've already got an event of user 12. And if I similarly create a user 13, if I hit this request, I've got my user 13 here. So this is how you can subscribe to events from your application using WebSockets. So if I can see what all topics I need to cover. So we have already covered inputs. And the last topic which I want to cover today is unions. So union is pretty simple. So you can define a type which can contain multiple types of values. So I can write a type as union, and let's say type is entity, and this can be a union of this needs to be equal user or post. So this is how you can define your type to be. So these are called unions. And now just let's head back to our presentation and let's look at our next slide. So like you've seen, there are a lot of advantages for GraphQL. So is it like a magic bullet which can be used for every solution or every application out there? So no, GraphQL is obviously not a magic bullet. It has its pros and it has its cons as well, like any other thing in technology. So the few considerations which we have to make is that first thing is the rest is simpler to learn and implement. So the learning curve for GraphQL needs a little bit understanding of the query language, the syntax, the schema, and how do you actually interact with the application. So it is more of a logical thinking shift, which you'll have to undergo when you actually use GraphQL. The other thing is GraphQL has a runtime overhead on the server. So if for very simple application, let's say if you just want to make a CRUD application, it might not be a great fit for you. I mean, obviously you can do that if you want to learn out of it, but for using it as on production application, let's say if you have a really simple application which just needs to do CRUD and there's no such dynamic data available, then GraphQL might not be a great choice. Also, the performance benefit might or might not impact that much since there is a runtime overhead. So for simpler cases, REST could prove to be faster than GraphQL. Then obviously there is a maintenance overhead. So as you saw, we have to maintain a separate file which maintains the schema for GraphQL. So there is a maintenance overhead there as well. Yep, that was it. I open to any questions if you guys have any questions on GraphQL or have any queries. Thank you.
Alrighty, thank you for the presentation, and we're looking forward for our Q&A session, which we will have next after the presentation from Nathan. And with Nathan, we will look at the case of 2,000 event-driven microservices and how to actually what kind of lessons we can learn from that situation. Yeah, so let's check out the Nathan's presentation.
To a microservices architecture is not simple. Moving to an event-driven microservices architecture is even more challenging. Welcome, everyone. My name is Nathan Silnitsky, and I'm a backend infrastructure team lead at Wix. And for the last 4 years, I've been developing messaging and event-driven architecture infrastructure for our microservices at Wix. And today, I want to share with you the story of how we adopted an event-driven architecture for our microservices in order to be able to have much higher scalability, and the issues and problems that we faced, and also the lessons that we learned along the way. First, a few words about Wix. So Wix is a powerful website building platform for all skill levels, from creating a website completely automatically to having a bespoke custom design. And you can manage your online presence, but also manage your business online, from scheduling your yoga classes and bookings to having sophisticated tools like third-party dropshipping. Wix has very large scale with close to 100 billion unique visitors that use the Wix platform every single month, and also 500 billion daily HTTP transactions, and more than 70 billion Kafka messages produced every single day. So these 2,300 microservices in production help us meet our ever-growing scale. And having those in event-driven architecture means that we can easily increase the scale, but also have better fault tolerance and recovery. But along the way of adopting the event-driven architecture, we face several issues. So today I want to talk about the challenges that we faced, including producing message failures that led to data inconsistencies, and also processing events out of order and processing duplicate events that also led to data inconsistencies between various databases, sending large payloads that actually failed for our Kafka message broker, and also troubleshooting production, because investigating our production system when it's on the event-driven style is harder than the alternative. So as long as we were able to solve these challenges and have success in adoption of event-driven architecture, it was like a enforcement cycle. So the better the tools that we offered, the better the processes and patterns that we offered, the faster the integration was with event-driven architecture, the more issues that came up and we solved them, etc. But how does event-driven architecture actually work? So let's take, for example, an e-commerce system, which I will reference throughout this talk. And we have the cart service that is in charge of managing the items that the shopper puts in the cart during the shopping process, a catalog service that manages the product catalog for the store, user service to manage the registered users and visitors that do some shopping, and an inventory service that manages the product inventory. So if we look at request-reply communication style, then we probably have the cart service that requires all kinds of things from the catalogs, users, and inventory services, it will communicate via HTTP, like REST API, or maybe RPC. But there is a issue here that you need to face as the scale grows. And it's about slowness of operation, for instance, where each of our database tables are actually hidden behind the microservices, right? That's part of the microservices architecture. And you need to go by and fetch from these services one by one. You can't do a join, which can be very slow. And database can actually also be bottlenecks here because they have a lot of high query RPM. So they become bottlenecks. One way to solve it is to put a cache before the request. But you know that caching can be quite difficult. One of the hardest things to do in software engineering, and you can get stale versions and need to have tough decisions to do on when the data is considered stale. Also, the network can be unreliable. So maybe you can't reach some service. And maybe there's actually a chain of requests that's happening from service to service to service. And if the last one, for instance, is down, you get a cascading effect of failures, which is really harder to manage. So you can add retry mechanisms and circuit breakers, but it's hard to do that on a global standard scale for all of your microservices. If we compare it to an event-driven architecture style, then we actually have an intermediary message broker. Specifically for Wix, we're using Kafka. So the catalog service produces an event to the product updated topic. And because there's a broker involved, it can actually go up to very high scales of producing events. And you just increase the amount of capacity you afford to produce to this specific topic. And what's more is that the catalog service that produces the events has no idea who consumes them. So the cart service here is a consumer, and it's completely decoupled from the catalog service. And if something happens to the cart service, it doesn't affect the catalog service. It continues to produce the events. So no impact here. Now, once the cart service comes back online, it will consume from the first event it hasn't processed yet. So it can catch up. And so you have a lot more robustness, and the event processing is guaranteed to operate, especially with Kafka-type message brokers. So I'm going to talk about the story of how we adopted event-driven architecture and the challenges that we faced along the way. But it's important to note that I'm going to tell it in a linear fashion, but actually some of the things happened in parallel. And the issues came up in various products, but I'm going to focus on the e-commerce product just to have better clarity and simplicity. So we really started to implement event-driven architecture back in 2016 at Wix. And problems were soon to materialize. For instance, with the e-com cart service, the database, it was discovered, did not reflect the actual catalog products. So the outcome was showing wrong prices in the cart, which is really, really bad experience for our users. So after investigating, we found out that the catalog service sometimes fails to produce events. So it has product updated events, and sometimes they fail to be produced. So then the cart service cannot consume these events and updated the product price in the cart database so that prices will show up correctly in the user interface. So that's a big problem. So this is our first challenge of this talk, how to handle producing message failures. The idea here is that we have to make database updates and event producing following the database update to be an atomic operation. So the idea here is that we're going to handle this by catching the unsent events. So we came up with the concept of a resilient producer, and in case of failure to produce, to Kafka, will first produce the event to S3. And then we have a separate healer service that pulls S3 periodically, continuously, and produces the events to Kafka instead. The resilient producer is actually part of Greyhound, which is our Kafka client at Wix, which we also open source big parts of. So the Greyhound producer wraps Kafka producer, and the Greyhound consumer wraps the Kafka consumer SDK. And it actually offers quite a lot of features. So in addition to the resilient producer that I mentioned, you also get parallel consumption out of the box for each pod to have as much parallelism as possible, and also batch consuming in case that handling and processing events in batches make a lot more sense performance-wise. And on the resiliency aspect, other than resilient producer, we also have different consumer retry strategies to make sure that eventually the event is successfully processed. And also other features that I won't get into at this point. Now, in 2018, we had mainstream adoption of Greyhound, both the resilient producer and the consumer retries, to gain better resiliency in our distributed system. But using the resilient producer and fallback to S3 actually introduced a new problem. We get out of order processing. So for instance, when the catalog service owner, the store owner decided to introduce some discount to a product, but then changed their mind and they removed the discount. So in case the introduced discount event failed to reach the Kafka broker, we could have the remove discount reach the cart service before the introduced discount event, because the introduced discount is handled separately by the healer service, and only if with the delay it's produced, right? So we get out of order events. So here we're talking about our second challenge of the talk, out of order and duplicate processing and how to handle them. So for handling out of order processing, we introduced a revision ID. So each of the entities, for instance, product entity, actually had a new field called revision ID that is also part of the database schema. So when the introduced discount fails to be produced and moves to the healer service, then it has version 10. And the remove discount comes up as version 11. So the cart service will first handle remove discount, which is okay because 11 is higher than 9, but it will ignore introduce discount event because it's older, it's version 10. Now, this can work if the event includes the entire entity and the product prices. Otherwise, if it's only like the delta, I'm introducing a 5% discount, the cart service will not be able to know how to update the price if it only gets the remove discount event, right? Another way to mitigate out-of-order processing is to use the Debezium connector. The Debezium connector is actually an intermediary between our databases like MySQL, Postgres, and Mongo, and our message brokers like Kafka, RabbitMQ, and Pulsar. So this connector scans the underlying bin logs of the databases that are used for backups and replication. And they are basically sequences of events. So it then reads these database stored events and actually publishes them to the message broker. And Debezium makes sure that no out-of-order events get into the broker. Of course, there can still be issues with out-of-order processing when you actually work with databases and you get sometimes failures. So the best thing to do is actually to put the revision ID because it's a global fix. Now, of course, as Ecom adopted the event-driven style, more issues came up. For instance, suddenly the inventory database did not reflect the actual inventory. So there were it showed that there is less inventory for the product than there actually was. So the store owners actually risk losing potential customers because they show that a product is out of stock while it's not true. There's still inventory for it. So upon the deeper investigation here, it led to the conclusion that the inventory service sometimes has duplicate processing, which then reduces the item counts in inventory without needing to. And this was because of the Greyhound retry mechanism that we introduced. So the inventory service on the first event successfully updated the database, but it also needed to update the delivery service to actually deliver the products. And that failed. So the event had to be reprocessed. So the inventory database was again updated, and item was decremented by 1 again. So it was decremented twice instead of once, which means that the inventory service was not idempotent. So for each item, the state in idempotency, the state doesn't change if you get duplicate processing. In order to solve this, we introduced the concept of transaction IDs for each of the events. So each event got, in addition to the payload, also the transaction ID. Then the inventory service, when it consumes this event, can actually put the transaction ID into the database because of the inventory, because it's part of the schema. And then if there's duplicate processing, the database transaction can fail because, hey, I've already put this transaction ID in the database. So this new update should fail because it has the same transaction ID. Cool. So by 2019, we introduced revisions and transaction IDs to solve very urgent, critical user production impacting data inconsistencies. So we got more and more adoption, and some interesting new issues arose, like can't produce large payloads suddenly. So even for something naive as product description in the product catalog entities, for some reason, when you get to a big usage in user base, you get to weird situations like having descriptions so long that it gets longer than the allowed size. Specifically, in Kafka, the default size of a message is 1 megabyte. So we get to challenge number 3 to failing to send large payloads. Now, we can increase the default size, but then we can adversely affect the performance of the Kafka clusters, because remember, we have high scale, and the bigger the messages, the slower performance will be. So the first thing we set out to do is to introduce global compression. We tried out several compression types. We ended up with gzip as default, but the services can also change to a different compression if it suits them. And another important note is that it's important for the compression to be on the Kafka level, and not on the application level, because then the Kafka SDK can use its batching process before it produces the events and compress everything in a single batch. Now, introducing compression helped, but it didn't completely eliminate the issue, because still compressed events could go above 1 megabyte. So in order to fix this, another method is to perform chunking. So the catalog service splits the event into chunks and produces them in chunks. And then the cart service consumer needs to consume them and reassemble the chunks into the original event. So this is quite a complex operation to perform, and it's rarely used at Wix. Something a bit more popular is actually to upload the payload to S3. So the product catalog uploads big messages to S3, produces the event with just a URL or a reference to the object store. And then the cart service needs to consume the event, get the URL, and download it from S3. Great. So in 2020, we added compression by default, improved performance overall, and solved large payloads issues. And as our scale was really massive now, and many developers joined the event-driven architecture style for their microservices, it became apparent that it's becoming more and more difficult for them to debug and maintain all these event processing happening all around their distributed system, as they needed to solve it for a lot of microservices. And also, they needed to fix bottlenecks that happened from time to time because of consumers not keeping up with the speed of producers. So consumer lags were building up. So our team really started getting bombarded with questions and requests for help, how to find a specific Kafka message, for instance, and investigate it. So we created our own like Kafka backoffice, and one of the first views we did was live streaming. So the developer can choose a topic, and they can choose to find events from a specific point in time for specific topic partitions, and also very importantly, to search and filter the events for specific keywords in the payload, in their headers, etc. So this can really put the developer in a position they can really find the exact event they are looking for. And another very popular request was to know how to investigate these consumer lags. So like I mentioned, if the producer produces faster than the consumer consumes, then the consumer is not keeping up, and it may be stuck on some event or something like that, so that it has to speed up its processing in order to reduce this lag. So we had an additional view where the developers can see the actual lag in each of the topic partitions, and maybe they saw that some partition has the most of the lag in it because maybe like consuming is stuck on some event. So we made it possible for them to actually see the content, the payload of this stuck latest event that is not committed and completely processed, so they can better investigate the situation. And then they either are able to skip the event, because we also allow a mechanism to skip events, or they can go ahead, fix the bug in their handler, deploy the service, and then it will automatically process the events and the lag will be reduced. Now, like I mentioned, we have a huge 2,300 microservices distributed system, and sometimes the events were not completely processed and side effects didn't happen. So users wanted help with understanding why something didn't happen, why a database wasn't updated. So in order to facilitate understanding the flow inside our distributed system, we propagated the user request ID and the user ID throughout all of our events flow. So Grand, when it produced, it actually put these IDs inside the Kafka headers, serialized them into the headers, and then the consumer deserializes the headers and also puts the information into our monitoring infrastructure. And then it's propagated throughout the system because it will also serialize it to produce and to consume, etc. So all of the context is propagated through Kafka headers throughout the system. And then developers can actually track the events, no matter if they reach gRPC or Kafka, and understand which services actually got the events to be processed and find the area where things failed and got stuck. In addition to that, the monitoring infra, the ground producers and consumers also put transactional information. So you could see how long of handling took place, and in a graphical way in Grafana using OpenTelemetry protocol, and also see how long database transactions took, and you get a lot of very important insights for your event-driven architecture. Cool. So we put a lot of important tools in production in order to help our developers to investigate event-driven failures and issues, and also readily fix them. So to summarize, with all the tools and patterns that we put in place, we were able to give the confidence for Wix developers to fully embrace event-driven architecture. And meeting these challenges made our microservices more decoupled, resilient, and scalable, while keeping complexity low and data consistent. If you want to get a more deep dive onto the topics I mentioned in this talk, you can actually go and check out my blog post on this particular topic, where I mention more details on each of the lessons we learned and add a few more. And if you're an advanced user of Kafka, you can actually check out this talk I gave on migration of 2,000 microservices to a multi-cluster managed Kafka environment with zero downtime, talking about how to move to a multi-cluster environment and do migration without losing any messages or having any downtime. And if you remember, I've also mentioned Greyhound, which is our open source tool library and soon to be service, which you can check out with all the features that I mentioned, including performance features, resiliency features, and also production investigation features. So with this, I want to thank you very much. And you can find out all the slides and links on SlideShare in this with this link right here on SlideShare, or just search for me in SlideShare. And you can also follow me on Twitter and LinkedIn to get latest updates on everything we do on my team at Wix on Kafka and event-driven architecture. And you can check out previous blog posts and talks I gave at my website at nathansil.com. So thank you again.
Alrighty, everyone. Welcome to our Q&A session, and thank you to all the presenters for the topics in this block. So we will have our speakers, our presenters with us. We have Nathan with us. Hey, Nathan.
Hi there. Hope you can hear me.
Yeah, we can hear you. We have Utkarsh with us also.
Hey, hi,
How are you
Paul.
doing
Hi,
today?
Nathan.
And we have Thomas with us. So let me check if Thomas is joining our presentation, or I guess yes, since Thomas is here. Thomas, are you presenting with us during this Q&A session, or?
No, it's for the next one. Sorry.
Okay, you're the next speaker. Okay, so but still, if you want to stay and hang out with us, you are more than welcome, because we don't have another speaker, so we don't have Swapnil with us. Okay, so we have a couple of interesting topics to discuss, and maybe Thomas, you will help me with questions for Nathan and for Utkarsh. Yeah, because I'm not super advanced in Java development, so I'll need some questions with help, and I'll need help from our audience with questions to make this Q&A session really interesting and beneficial. So, okay, let's start with this question. Okay, So is there any generator which could generate a schema from entities? This is for Utkarsh.
Yeah, so I haven't personally explored, like I believe in writing them myself rather than testing auto-generator. But yeah, I get the pain point of if an entity has like a long list of fields, then you would want them to be auto-generated. So yeah, I guess there should be some online tools which can just revamp. Since Java is also a strongly typed language, I think the types would help, and I think there should be some online generators which could help auto-generating of GraphQL schemas.
Okay, thank you. So also we have this question, and it's for Swapnil, but I don't know, maybe someone else can share something about the IntelliJ versus VS Code. So let's talk about this. Is it better to use the VS Code from Java development instead of IntelliJ idea? So what's your experience with this? Anyone can answer. So if you have any experience with this, and if you compare those two, so just from your personal point of view.
Well, IntelliJ always had amazing refactoring tools available for Java. I know as a Scala developer that it always frustrated me how better Java refactoring is than Scala. But I don't have experience with the Java plugins for VS Code. Some of the plugins for VS Code are amazing and have a great set of features. It all depends on the plugins, because the platform itself, VS Code, doesn't give you a lot out of the box.
Okay. So, Thomas, maybe you have some kind of experience with, since I forcefully left you in this Q&A session. So maybe you have your opinion on VS Code versus IntelliJ.
I wouldn't like to say anything stupid. To be honest, I'm an everyday user of IntelliJ. I sometimes do presentations with VS Code, but that's it. I know a lot of my colleagues at Red Hat are actively contributing to the support of Java development in VS Code, and a lot of users say that they appreciate it. But yeah, I'm not an experienced user, so I don't want to say anything stupid.
Okay. At the end of the day, I guess whatever works for you.
Yes.
I mean, I've had multiple tries. Like I'm just out of curiosity. I've tried VS Code multiple times, but I always switch back to IDEA for some reason. So
we have consensus here with 3 IDEA users. At least that you have.
Okay. And Thomas, if you need to drop, we will continue. So thank you very much for being with us, and we'll see you during the
You're welcome.
Thank you
You're
very
welcome.
much.
Bye.
Okay, so let's continue with the rest of the questions that we have. So we have another question about GraphQL.
Mm-hmm.
So just a second. Looks like,
yeah. I can see the question.
Looks like I'm lagging a little bit.
Yes.
Yeah, just a bit.
Yeah.
Hmm.
Yeah. So the question is, what is the biggest advantage of GraphQL compared to REST? So like we saw, one of the biggest advantages in the querying efficiency, and also the control which the clients have, that what data they actually want to fetch. So like we saw, we executed 2 queries in a single network call, right? And that number of queries you can you can add 2, 3, 4, 5 as number of queries as you want. And that one biggest advantage is that all of those queries will execute in parallel, and then the response will be returned. So could add as a huge advantage in terms of performance. Also, the other part of it was the control of
what data you want to fetch, so you can avoid, like, this becomes a big factor when you are working at really big scale. So like imagine at the scale of Facebook, if you get to choose what is the payload that you would want from the server, that is a huge advantage.
Okay, got it. Please pardon.
Oops, looks like he is dropped.
Yeah, where?
Okay. Very interesting. So this is what happens when you're talking about Java and everything, and you're using an ARM Mac, and it just doesn't want to cooperate, I guess, with computer technology.
I kind of got used to it while working in an online scenario. So
yeah, so it just crashed on me. It just crashed on me, and I have like just a couple of tabs open. Yeah, I guess sometimes it's like the Google spreadsheet and the StreamYard is way too much for a modern laptop. Nathan, can you hear us?
Yeah, thanks. Can you hear me?
Okay, yeah, super. Nice. So, okay, we have a question for Nathan. Using a Kafka client like Greyhound from the Java code to send events might lose events to out of memory errors, right? How to prevent this? Is Debezium the only solution to tackle this problem?
Okay, great question. I guess we're talking about the producer side here, right? So out of memory is one thing that can cause event loss. Okay, let's split it up. For consumer side, no matter what difficulty the pod currently experiences, it can always do reach-wise, as long as it doesn't commit the current message that it's processing. Nothing is lost, and you can do reach-wise, and hopefully you take care of duplicate processing that doesn't affect your performance, like I talked about in the talk. And regarding the producer side, so out of memory is probably something that resilient producer won't really help with, like I mentioned in the talk. But if you somehow manage to update the database and then you got out of memory, your application now is in completely non-deterministic state, right? Because of the JVM running out of memory. So maybe the Debezium is a better solution here, but from now on, you really don't know what's going to happen. Like, are you going to succeed writing to the database or not? And so the best thing when such a situation is recognized is to quickly either kill the pod completely or remove it from getting traffic completely, and investigate why happened and why, like do heap dumps and understand what's going on with your memory pressure. And because, like I said, we're coming into non-deterministic territory when the JVM hits these things.
Got it.
Yeah, that's it.
Okay, thank you.
Sure.
We have another question. Let's continue with you, Nathan. So, do we have a Java repository for implemented producer and consumer open source? Since this is kind of related to this one. So,
if you're referring to Greyhound, which I mentioned in the talk, so although it's written in Scala, it does have a Java interface on top, so it is available for Java producing, and of course Kafka itself is open source, and you can use that if that's what you're referring to.
but both are available open source.
Okay. Thank you. So this one is for you, Utkarsh. What is the purpose of user interface in GraphQL schema?
Yep. So this was the part I wasn't able to cover because of the shortage of time. So there's something called fragments and in GraphQL. So when let's say if you had like we were returning two APIs, right? One was user and one was post. Let's say you had an API which would be returning just the entity. And now entity was the interface, and now at the client side, depending on what type of entity you are fetching, you could have different fields in it, right? So then you can use interfaces, and you can create a fragment of that interface saying that if the entity returned is a user, then I need this set of fields, and if the entity returned is post, I need some other set of fields. So that is where that comes in handy. Also to enforce certain fields, like it is a best practice if you can like it becomes a best practice if you have some common fields across multiple entities in your schema, and you want to enforce each entity to have those fields. Then you can probably implement that interface on each of the entities, so that by mistake or there's a typo by which you just removed one of the fields, you can get your compiler to shout that hey, you have removed something which was supposed to be in this entity. So yeah.
Okay, thank you. And we had similar question, why use an interface in GraphQL, so I guess we answered this one also. Thank you. So we have another question for Nathan. Is the Kafka backoffice tool only for proprietary systems, or is it available somewhere for public?
Yeah, it's a great question. I get it a lot. So unfortunately, it's actually closed sourced and only for internal use, because we have a lot of code we rely on for like our microservices infrastructure that is not open source, unfortunately. But there are great alternatives out there in the marketplace. Confluent has its own features. There is Conductor. There's Yahoo has a good open source alternative here. And I have a blog post. I wonder how to share with you a link, but it's about troubleshooting Kafka, and I list there good back office options. So you can just hit Google for
you can send it to the chat over here, and we'll repost it to the general chat. So
okay, cool.
Yeah, just post it here, and we'll share it with everyone right now.
Great, I'll post it. We can continue to the next question for now.
Yeah. Okay. Thank you. So another. How do you send the failed messages to S3?
Well, basically, we use the AWS Java SDK, and we wrapped it for our own code that we use for Scala Zero. But basically, it's the SDK. But of course, there's also REST endpoints available. There's a rich diversity of ways to reach S3. But I guess for Java developers, it's mostly like the Java SDK.
Awesome. Thank you. Another question to Utkarsh. Do we have a Java repository for this producer and consumer open sourced?
I think
I think this is from
this one is for you. Yeah, we'll save it then because probably we missed. So let's have this one for Utkarsh, because I don't want to populate Nathan with too many questions. We'll get back to you right now. So is there any framework that allows code first GraphQL APIs implementation without writing the relative interface documents related in interface documents?
Not that I'm aware of, but I think the heavy lifting part of it could be to an extent removed with certain Maven plugins, which can generate Java entities based on your GraphQL schemas. So you'll have to define a schemas, but the boring part of it, like creating a Java entity mapping to your schema, that part maybe can be automated using Maven plugin or a Gradle plugin.
Okay.
But,
okay.
Yeah.
Thank you. And I wanted to ask our team on the back end if you can please return the previous question, because it disappeared from the list of questions
I think
for me.
the previous question was already asked about open source, right? So I think we've already answered it.
Okay. Got it. Then let's head to another question. And another one would be for Utkarsh as well. How query for users post will behave? Will post be eagerly loaded?
Yeah, so it actually depends on the way like you structure your JPA contract to be. Like if you want it to be eagerly loaded, it would already be. But how it works is that if you, so for my case, I was using lazy loading. Like I wasn't fetching post if I am not asked for returning post, right? So if you specify the field post in your request, then it will fetch it. Else it will be lazily loaded.
Okay. Thank you. And also, we have two more questions for you, Utkarsh. But I have one question that we were discussing internally with our architecture team, and maybe Nathan, you can say something regarding this. What's your opinion about the GraphQL Federation about this? Because this is kind of still new, developing, kind of popular on the very edge of technology. So what's your opinion
regarding GraphQL?
GraphQL Federation.
I'm not sure about like Federation. I know that GraphQL is a great way for the front end developers to get exactly what they need without a lot of hassle for like backend development. But I'm a big favor actually of switching to event-driven style and like WebSockets when it's possible. But of course, GraphQL will be more for the general use case, and communicating with events and WebSockets is for more like special type of use cases where you want to do like more long-term processes where you want to get the requests back, but both of them actually make the backend developer lives easier. So that's nice. I hope I answered the question.
Utkarsh, what about you?
Yeah, so personally, I like this is a new term, and like I am not much aware about it. So I won't be I'm like I've just Googled it and like got to see that it enables you to use internal APIs and sort of orchestrate it to return your responses. So I haven't personally tried it, so can't comment on the future of it or how easy or relatable it is for me. But yeah, I mean, for GraphQL, I think Nathan explained it really well. All the points he said, that hold true, at least for GraphQL. This is Federation thing I'll have to go and check.
Okay, and I hope we'll have it covered at our Global Architecture Summit, so Worldwide Architecture Summit. So everyone, please join if you're interested in this topic. So we'll discuss it there. And since we actually touched on this question, so what's the biggest advantage of GraphQL compared to REST? So your opinion, Utkarsh.
I guess like this was the first question which we answered today. So I mean, like, yeah, I can reiterate on it if you want.
I guess I didn't delete it, so we have another one. So I just don't want to miss any useful question, because this one somehow floated up my list. So,
but again, it's actually for me, I think, as a
okay.
Okay.
So this one is for me.
All is good. What if data input consists of a lot of messages from Kafka? What happens to the sink? Would it just store all the data, or does it clean itself after a while? So I guess we're talking about like the consumer side, and the consumer is polling and getting new messages, and there could be like the producer is really in high rate, high throughput. So specifically, like with the vanilla Kafka Consumer SDK, you poll, process, complete processing, and poll again. And so you won't get to a situation where you get like bombarded with a lot of messages, because like you control how many messages, how many bytes to fetch, etc. The approach that the Greyhound actually takes is to take up messages into an internal queue per partition, and if the queue is filled up to a certain point, then this specific partition is paused because the consumer is not keeping up, and only once enough processing is done and the internal queue amount of messages is lowered, then processing of this partition is resumed. And in today's world with Kubernetes, what usually happens is that we get a lot of CPU activity and stuff like that, and we get auto-scaling. And so the consumer lag will be resolved by adding more pods to our service mix and getting more processing done in parallel. So either you just wait for your next fetch with processing before moving on. So or you do like fetch and pause partitions when you get to a situation where you have a lot of data, like Greyhound does. But basically the cleanup is done with the garbage collection, right? So as long as you keep control on the amount of data that you process at a time, there shouldn't be too big a memory pressure and like auto memory, like the previous question asked about.
Okay, thank you. And I guess I'll need help with this one, because I don't see I don't see words that I can recognize. So this one doesn't have the graph or Kafka. So I'm kind of so I need your help with this. This one is
looks like GraphQL.
Okay, awesome.
There is always return fields regardless of.
So does the request body change the select statement executed on the service, or are the return rows always?
I think the question is more about like, does your API call also control what query is getting executed on the database? So like obviously there is a separation of concern in between, like GraphQL is just acting on the entity which is which is your DTO layer basically. So any database interaction, GraphQL APIs do not have a control over that. So obviously, I mean, for our case, I did not use a service layer sitting in between your database and controllers, but in production service, you'll obviously have a service layer sitting between, which will control the abstraction of what all information is being passed to the controller layer. So to answer this in short, no, the request body will not have a control on what select statement is going to execute on the database, unless you like do something specific to give this control.
Okay, awesome. Thank you. And we have another one which was for Swapnil as well, but maybe this one will have some I would say relative experience in your day-to-day coding routines. And so, I mean, the second part, the question: have you tried refactoring in VS Code? How can it be compared against IntelliJ in that aspect? So, just I guess this part of the question.
Yeah, again, I mean, I don't want any VS Code hits, but like I have tried it personally, and like For me, again, IntelliJ did it beautifully as compared to the VS Code. So like whenever you refactor your class name or method name, it does it for in the entire code space, even if you have a multi-module project. So that is something just really blows out my mind in the like in the perfection which IntelliJ delivers in that sense. But I've not had that great experience with VS Code, especially for Java side of things. So yeah, but that is my personal experience.
Okay, Nathan, maybe you have something.
Similarly, the experience is usually more like seamless in IntelliJ for sure.
Okay. So I hope we will have Swapnil with us maybe someday today or maybe tomorrow joining us, and maybe he can or maybe at the at one of our other conferences, and he can basically share his opinion on this, and maybe we're missing something. Maybe there is a trick. Maybe there is something that we need to update our VS codes and everything like that. So yeah, but anyways, thank you very much, both of you, for joining us. Thank you for your presentations. Have an awesome day, and yeah, I hope to see you at our next edition of our Java Devs online summit, and yeah, maybe at our architecture summit. Oh, yeah. We have Swapnil with us over here. Okay, so I guess
I have to go, but
Nathan, thank you very much. Tada rabah. Have a nice day.
My pleasure. Thank you, Utkarsh. Thank you.
Yeah, thanks a lot.
Pleasure. Okay, so I guess we will have a short break now. So since we have finished with all our questions, we will be back in 10 minutes, and we will have our next moderator with us, Chris Engelbert. And yeah, until then, let's grab some coffee, let's grab some sandwiches, let's grab some snacks, maybe something healthy if you're doing healthy food. So it was my pleasure to be with you during this vlog, and see you next year at our online summit for Java Devs. Have a nice day, everyone. What an awesome day to be together here at Global Summit for Java Devs. We want to say thank you to our sponsors from Microsoft. Thank you for joining us. And just a quick shout out to their Azure team, to their amazing products. So Azure is a cloud computing platform that enables you to build, deploy, and manage your applications across multiple clouds, whether it's on-premise or at the edge. So basically, Azure allows you to develop in the cloud and access a range of services that can help you to streamline your workflow and accelerate your time to market. And today we will have a special link in the chat that you can use to get yourself a free account at Azure. So definitely give it a try, and we hope this community will build lots of cool projects using Azure. Thank you, Microsoft, once again for supporting this event and this community.
All right. Hey everyone. It's cool to be here. Thank you for Paul doing the last slot. This time I'm your moderator for the next free. So yeah, first of all, I'm Chris. We'll see a little bit further in the interviews or in the discussion afterwards. But first of all, with the first session is Nicolas Fränkel. He's a real good friend. We know for many years. He's developer advocate at API 6. He's doing that for many years. And today he's here to tell us a little bit about how to practically get OpenTelemetry into our applications and to make all that happen. And with that, thank you very much. Nicolas, take it away.
Hi, folks. Thanks to be here for this talk about an introduction to OpenTelemetry tracing. I'm Nicolas Fränkel. I've been a developer or an architect or whatever for a long time, like more than 20 years nowadays. And since a couple of years, I'm also a developer advocate. So given my history, I can tell you about what happened a long time ago, like perhaps even before some of you knew about IT. So in the good old days, or not so good, we had monitoring. And monitoring meant that you had a bunch of people, like sitting in front of a huge screen full of like widgets, with dashboards, with graphs, with whatever. Sometimes they even had an additional screen in front of them, and they were actually monitoring, like visually monitoring the situation. Sometimes you had even alerting, or alerting came afterwards, but basically monitoring meant you had like low-level information into your information system, and you had to have people who could like realize that, hey, this like slight anomaly here and this slight anomaly here meant that actually something bad was happening. It was working more or less, but actually the system became more distributed. You can do this kind of stuff on a huge monolith, but when you have components starting to interact across the network with different machines, with different nodes, then having this kind of like insight into the system through experience becomes very, very hard. And so monitoring gave way to something called observability. So you can think about observability at the next level as to provide insight into not only one single component, but about distributed system. And there actually are three main pillars of observability. The first is metric, the second is logging, and the third is tracing. And though I will focus this talk on tracing, I still need to introduce the others two because they make a lot of sense and probably you need to be aware of them anyway. So as I mentioned, the first step to monitoring was to have metrics, and it was easy because nearly all operating systems give some way to release the data of how they operate. So you can have the CPU usage, the memory, the swap memory, the number of threads, or whatever. And this is very easy to get, but as I mentioned, if your system becomes more complex and involves more machines, it's not possible to have them. So nowadays, we still rely on those metrics, but we want to have higher level metrics. They can be like still technical metrics, such as the number of requests per second, or the HTTP status code, or it can be like business metrics, such as the number of orders and this kind of stuff. Now comes logging. Logging is another level of complexity. Logging, there are different questions you need to solve. The first question is what to log. For example, in the past, it happened that I used like a Java agent to log whenever I entered a method and whenever I exited a method. So when I read the log files, I could see like which steps were used. So I could do some kind of debugging in production just by looking at the log. This is good. This gives me some insight. Actually, it's more like tracing, but it doesn't tell much about how the business side of things. So again, perhaps we want to log more interesting stuff, such as who is connected, what's their session ID, how much items do they have in their code, this kind of stuff. This is much harder and it requires manual intervention. So you need to have a requirement and the developer like actually writing the code to log this. Of course, with auto instrumentation, you cannot log every parameter of a method by default because some of them might be a password and you don't want to log the password. So auto instrumentation in this case of logging is easy, but doesn't provide much value and can be actually harmful to the operation. Then the logging formats. For a long time, we use whatever logging formats the framework provided us, whether you are using SLF4j, Log4j, Log4j2, whatever. But nowadays, it's perhaps better to use directly JSON so that when you send it to another system, which expects JSON format, you don't need to have an intermediate operation that actually transforms the human readable log into JSON format. Like directly print it in JSON format and you avoid one additional potentially expensive operation. Then where to log is also important. When I started coding, I was explicitly forbidden to write to console. Like if you use like Sonar or any other quality tool, they will tell you, hey, it's forbidden to use system.out.println or system.err.println. You don't write to console. Nowadays, however, with containers, you probably will want to write to the console so that it can be scraped and again, like sent further. Logging on the system is good when you've got a single component or perhaps two components. As soon as you've got a distributed system, you need to aggregate the logs together so as to understand again what happens across all those components. Therefore, you need to get all the logs from all the components into a single place, into a centralized logging system. And again, that's more question. Basically, you need to ask yourself, should I send the logs? And basically meaning that my application will lose some performance to send it and actually might crash the app? Or do I expose only the logs so that another component can scrape them? This is how Prometheus works. For example, you add some endpoint and Prometheus will scrap the metrics. Loki will do the same. I mentioned about parsing the logs. Again, it's better to actually write them in a format that the centralized logging system can directly exploit than to have an additional operation in the middle. Then you need to store the log, of course. Then you need to somehow search for the log because, well, just having the logs one by one is not interesting. So you need to search for them according to some filters, for example, the timestamp, for example, the transaction ID or anything. And then you need to display them in a certain way to look for the interesting bits. For example, the components that produce them. And I didn't write it, but of course you need to somehow afterwards get rid of the logs. Otherwise, your logging system will grow and grow and grow, and well, you probably will have your disk full in no time. You probably used one of those systems. In the past, I've been using Elasticsearch a lot. It's quite useful, but any other system will do. Then comes the third component, which is tracing. The Wikipedia definition, I love Wikipedia definition. In my opinion, this one is not a great one. So I've come up with my own. You will excuse me, probably it's not my own. I've got inspired by lots of people that I don't remember, but well, credits to them. So basically, tracing is a set of techniques and tools that help follow a business request across the network through multiple components. This is really, really important. Again, in distributed system, you've got multiple components. Your transaction, your business transaction, will require all of those components to work together to achieve the business goal. If one of them fails, you're in deep trouble. And if it's repeatedly the same component that has an issue, you need to be aware of it. So tracing the request across all those components is important. I believe you probably are aware about some of the tracing pioneers existing already. So there is Zipkin, Jaeger, OpenTracing. Those are the three most widespread and famous. Every one of them had proprietary interfaces and implementation. But as you know, we want something to be standardized so that the whole software that you write, we can write libraries that have one standard. And for that, there is something called the W3C trace context configuration. It's quite easy to read, so you can already do that at home. And basically, if you don't have time, let me refresh it for you. Basically, you've got two important concepts. The first concept is the idea of a trace. And the trace is actually like the abstraction of the business transaction. So the trace will go from entry points to the utmost deeply nested component and back again. That's the trace. And then you've got a span. The span is actually the execution of one part of the trace in a single component. And you can have, of course, for each component, you can have multiple spans if you're interested, where inside this component, where the flow of the request goes. And each of those spans are bounded together in a parent-child relationship. So the first one is the important one. The first component is the important one. It gives the first span ID, and then the next component will check the span ID of the parent and will say, hey, I am this span ID. So it also generates a new span ID and say, hey, I'm bound with this one. And through all those parent-child relationship, you can actually make sense of the flow and check the flow overview in one set. OpenTelemetry is a set of tools that implements observability and that relies actually on W3C trace context. So it's an implementation and more. So it's compatible, and it also go beyond, because W3C is good for web stuff, but perhaps you want to trace a request through, I don't know, Kafka. So somewhere where you can store. And in this case, the specification doesn't handle it. OpenTelemetry allows you to trace these business transactions across many different components, not only web ones. If it's a merge of the OpenTracing and OpenCensus projects, so it's one of those few merges that were successful, where people decided to join their efforts to create something better. It has become a CNCF project, which is good, meaning that it has support. It will be supported for a long time. It's licensed under the Apache license, so it's also good if you want to use it right away. You don't need to acquire a license or whatever. And it's hugely popular, especially on GitHub. The architecture in itself is quite easy. Basically, you've got components, whatever they are, and then you've got what they call an OpenTelemetry collector. And this OpenTelemetry connector like accepts data in a specific format. And this specific format allows to have this like parent-child relationship between spans. So the idea is on the client side, you've got stuff that dumps data into the hotel collector, and then you've got something that is able to search and display data from the hotel collector. The OpenTelemetry collector in itself doesn't provide anything. It's just the storage stuff in a certain format. So we need something afterwards. OpenTelemetry provides a dedicated collector, but actually Jaeger and Zipkin, which are also like tracing providers, they are able to provide the same collector, or let's put it that way, they also provide a collector which accepts OpenTelemetry data. So basically what they did, they kept the storage engine, they added a new interface where you can state your data in OpenTelemetry format. If you already have your architecture, your tracing architecture, you can easily move to OpenTelemetry because, well, the collectors of Zipkin and Jaeger, they have this additional interface. You just need to change the formats and the ports, because I think every one of them has different ports. On the client side, it's, well, I wouldn't say easy, but the first step is straightforward. First step is auto-instrumentation. This is only available when you've got a runtime. For example, on the Java side, you have the GVM that is on runtime. On the Python side, well, Python is a runtime. Node.js is a runtime. In this case, you will delegate to the runtime to do like auto-instrumentation. I told you about like automatically logging, entering and exiting a method. It's exactly the same. Here, you will do that automatically. It gives you already a lot of insight. Now, if you want to go further, you can actually get the library depending on your tech stack. Again, you can check the OpenTelemetry website. You will notice there are lots and lots of stacks that are supported out of the box. And for Java, there is one. For Python, there is one. For Rust, there is one. Whatever rocks your boat, probably you will find there. And then you can either like call an API or use some annotation. As I mentioned, auto-instrumentation, very easy to do. You don't need to couple your application to OpenTelemetry. It's a low-hanging fruit, so you should probably do it right away. If you are using a distributed system, it will give you a lot of insight into your application. I mentioned it's practical introduction, so here let's try to do some practical stuff finally that we have delved into the theory. So here is my use case. My use case is, well, simple for a real application, but a bit more involved for a demo. So at the beginning, an API gateway, I'm using the Apache API Seeds gateway. It forwards the requests to my main application, which is a SpringBoot Kotlin application. Actually, it gives like products API, and then it has the detail for the product itself, but it relies on two other components. The one for the pricing is implemented in Python through a Flask framework application, and for the stocks, so how many items do I have in which warehouse, I have created a Rust application using the XM framework. So the entry point is actually the reverse proxy API gateway. Most information systems have such an entry point. You probably never expose your application directly over the internet. You have something in between because, well, you are like you want to protect your information system from illegal access. So that's the most important part. As I mentioned, I'm using Apache API 6. Perhaps you don't know about Apache API 6. It's an Apache project. So basically, again, like good for maintenance. Everything will be there with a license that will never change. It's based on the very successful Nginx reverse proxy. Then you've got like a Lua JIT additional open REST layer on top, which allow you to do scripting in Lua over the Nginx. And then you've got out-of-the-box plugins. So to configure it, there is this general configuration. As I mentioned, they're like Apache API 6 as a plugin architecture. So here I say, hey, I will be using OpenTelemetry. It's an out-of-the-box plugin. You don't need to write any code. And then you can tell, hey, this is the name by which I want to be known in the data of OpenTelemetry. And this is where I will send the data. So I will be using Docker Compose. And so I have a dedicated Jaeger component. Then for each route, so here I have a single one, but you can have different configuration depending on which route. You will say, okay, how much sample do I want? Normally, and depending on your volume, you probably don't want 100% because it will overflow your stuff. You want a sample. Here, this is a demo. I will say I want to sample everything. Again, probably not what you want to do. And then you can log additional attributes. So here, for example, I decided for no reason, but for demo purpose, to have the root ID, the request method, and an additional header. So if I can pass through the client some headers, and they will be like traced along the span. The next step is the JVM level. As I mentioned, JVM is a runtime, so I can easily use auto instrumentation. And on the JVM, auto instrumentation is through a Java agent. So this is quite easy, actually. I just need to pass the Java agent when I start the application, and I don't need to write anything. So your developers, they are completely isolated from this tracing concern. They can write their code, and everything will work as expected. This is regardless of the language and the framework because it's JVM. So here, this is how it works. Here is my Docker file to build my Docker container. This is a multi-stage Docker file. First, I will compile everything through a JDK, and afterwards, I will run it through a GRE because I don't need a JDK, and it's actually bigger and less secure. So the first thing I do is like normal standard builds. And then afterwards, I get the jar that I just built and I add the Java agent through GitHub. And when I run it, actually, I run it through the Java agent. And this is as simple as it gets. You cannot be simpler. Afterwards, you can do more precise, more fine-grained calls through manual instrumentation. It needs an explicit dependency in the application. This time, your developers need to be aware of it. And then there are two ways to do that, either through a regular explicit API call or through annotation. I'm benefiting from SpringBoot, so basically I will use annotation. I will issue the code just afterwards. Okay, now it's time to delve into the codes. I will just focus on the Kotlin SpringBoot ports. Everything is on GitHub, so in case you need to check, you can check the Python part, you can check the Rust ports. Here I will focus on the Java stuff. I've created my application on SpringBoot start.spring.io. So here I'm using the latest version of SpringBoot. I'm using the latest LTS version of Java, which is required by the latest version of Spring Boot. I'm using also the latest version of Kotlin. And then it's a reactive application. So I will be fetching data using R2DBC. Otherwise, I'm using Webflux. So again, to be reactive. And the rest is just standard Kotlin stuff. I didn't want to bother myself with a regular database, so I'm using H2, using the R2DBC H2 reactive driver. On the code side itself, here I'm using Kotlin, so I want to use coroutines because, well, that's how you can do easily reactive code stuff. So I'm using the coroutine CRUD repository. This is my R2DBC repository. Here I have a handler. And you can see that I have suspend function. Suspend function are for coroutines in Kotlin. Then I have one endpoint and the other endpoint. This one endpoint is for all products. This one endpoint is for a single product. Let's see the first one, okay? And then the rest will be exactly the same. So I will fetch all product. I will find all of them into the repository, which in turn will look into the H2 database. And for every one of them, which probably what you shouldn't do in real life, I will fetch the product details. So whether, not whether, but their price and their availability in the stock. So here I can see how it works. Again, I will have two different calls, protected under an async block, which means that here, because I'm using dispatcher.io, they will make the calls in parallel. And we can check that it works like this in the traces. So I will get the price, I will get the stocks. Then I will merge everything. And here is how I merge everything. So I transform data into the expected data. And at the end, I create a product with details, including the products from the database in the catalog, plus the price, plus the stocks that I have changed a bit. For example, I don't want to return to the client any warehouse where the quantity is 0 or less, because, well, not 0 or less, just 0 doesn't make sense. So I just filter them out. And at the end, I'm using the beans DSL from Kotlin and the router DSL, or here the co-router DSL, to assemble everything. And I start my application with this beans method. So even if you are not familiar with Kotlin, if you are a Java developer, I think it should talk to you. And here you can see my two endpoints, /products for products and /products /ID for my product. Now I assemble everything through Docker Compose. So this is the Docker Compose file. I'm using Jaeger. Jaeger is available in multiple flavors. You can have different containers. For example, here I'm using the all-in-one. So I'm using the batteries included package, Docker image in this case. So I can already have the OpenTelemetry collector provided by Jaeger. So it's not the OpenTelemetry collector, it's the Jaeger collector that allows an OpenTelemetry interface. So here I don't need to think about the architecture of Jaeger. I'm just using the Docker image that does everything. Then I'm using API 6 because I want to protect my services. Then I have the catalog, which is the Spring Boot Kotlin application that I've just shown. And here I need to tell several configuration parameters. The first one is, where does the Java agent need to send the data? Well, to Jaeger on this port. How will it flag this component? Here it will be called orders, which is wrong. It should be catalog. Then here, does I want to export metrics? Here I said, no, I don't want. Of course, depending what you want to do, you can also export metrics and logs the same. And now pricing, I do the same for the Python application, but again, this is not relevant for this talk. So here, pricing, same stuff for the Python application, not relevant for this talk. Stock, same thing for the Rust application, not relevant for this talk. Let's start this architecture. So it might take a bit of time, especially with the JVM to start. I will just like speed the time and let's go very fast. Okay, the logs tell us that it has started. We can check with Docker PS. Docker PS. So here it seems that everything has started. We've got the catalog, the pricing, the stock, and Jaeger. Now we can issue our first curl. So curl, I will be using the header that I have configured Apache API 6.4. So if I remember, it's hotel key. And then I can say, let's say, hello world, because I have no imagination. And I'm on localhost 9080, which is Apache API 6 default port, and we'll say products. So it takes a bit of time because it will go through all our systems. So here you can already see that the catalog has taken, then none of the stocks, the pricing, and Apache API 6 as well. So we've got the response, which is not very interesting as it is, but it still gives you the data you ask. And now the idea is to check the traces. So I'm now on like the Jaeger web UI, and I can check, and I will go exactly here, and here we can see all the services. So there are some traces. Here I need to refresh because here I need to find the traces. And here we have single request because we sampled everything. Here we have it, and we can see already with only auto instrumentation a lot of interesting data. So we can see that we have our API 6, which is the entry point. And here we have the orders, which I misnamed. It should be called catalog, but here it's orders. And here we have the product. Here we have the first auto instrumentation inside of product because we are using SpringBoot. We have lots of proxies inside, you know how SpringBoot works. And here decided, hey, here I will make a call for a proxy. I will trace it. Here we have the final. Why? Because it's an interface provided by SpringBoot. We didn't provide the implementation. So basically, again, it's a proxy. So it's automatically traced. We can see here that there is a call to the other components called stock. So it's traced as well, which is good. And here we've got the second one. So here there is one for stock and one for pricing. And here we see that in one case, I went directly to the component and the other one went through the API gateway. Both are completely possible. This is how I configured it inside my architecture. Basically, in one case, you can say, I want to protect everything that I always need to get back to the API gateway to do some authentication, authorization, whatever you want. And the other side, you say, oh, I'm pretty secure. I can directly go through it. But it gives you insight into your architecture as well. In case you misconfigure something, you can check it through the traces. Something interesting as well, we can see that the get calls through to the stock and the pricing, they are made in parallel because we use coroutine. So this is also a good way to check that you actually coded your stuff correctly. If you see one going after the other, then probably your code was not right. Though tracing is not made to do that, you can also validate some of the code. And then, as I mentioned, it's not good to do that, but here, for each of them, I go to the stock and the pricing, stock and pricing, stock and pricing. And we can check, for example, that on Apache API 6, I actually have the additional stuff that I sent. So basically the routes and the get. And here I'm missing the hotel stuff. So probably I didn't use the right one, but believe me, it should work. Now that already give us some information about our flow, but we might want to better. We might want, for example, on the get to say like which internal method did we call which parameter. So let's do it. So now I want manual instrumentation. It means I need to explicitly couple myself to the library. So here, because I'm using Spring, as I said, I want annotations. I don't want to have API calls. Actually, if you check the documentation of the OpenTelemetry in Java, to get an exporter is not that fun, requires a lot of API calls. And well, I have annotations. SpringBoot is compatible with OpenTelemetry, so let's use it. So I've added this like additional dependency in my code. Now we can check the application itself, code itself. And we can go here. And here we can see that I've added like here, this with span. So this with span means that it will be instrumented and you will find it in the trace. So I should have this product handler products. If I'm calling one single product, I will have this one. But it's also possible to use additional details. So for example, here I will have this product handler fetch, but I also say, hey, here, not only capture this call, capture this ID. So which product ID will I fetch? Which means that here it's interesting because normally I shouldn't need it. Here you see that the ID parameter is not used because I already have the product. But because I want to capture the ID, I need to separate this parameter. So I wouldn't be able to capture the span attribute product because then I would have not the ID, but the whole memory reference unless I create a toString, whatever, which is not a great idea. So here I change my method signature a bit to explicitly pass the ID, and then, well, I don't use it. But then it means that this will be captured by the tracing, by SpringBoot, and I will find it, which might be super useful, especially if it fails. So normally now everything should have started, and we can try again with this configuration. So here it's the same request. I have to change the header because I missed the previous header. It was not hotel, it was OT. So let's run this. Again, we can check that everything works on the logging side. So here I'm in the catalog, then I'm in the stock, the pricing, whatever. I've got the response, and we can check back on the Jaeger UI how it looks like. We expect more details. So first, we can already see that we have more spans than before. Just to check on the Apache API 6 side, we can see that now my OT key, this header, has been logged, which is good. And then we can see that I have the products here. I have the fetch here. So basically, we added additional data. So inside the components, we added a couple more spans to understand how the flow of the code went inside the components, not only throughout across components. You can also see that I did the same in Python. So if you are interested, you can check the code. So here I'm logging the query, like manually, unfortunately, but I'm logging the query so you can have additional information what you are doing. So thanks for your attention. I hope you learned something. I showed you how you could use OpenTelemetry how you could use auto instrumentation, how you could use manual instrumentation, and I believe now you can start your journey. You can follow me on Twitter. You can follow me on Mastodon if you're on Mastodon. I previously wrote a blog post about OpenTelemetry. It's much more narrow focused. I've improved the demo code a lot, but perhaps you can read the blog post. It might give you some insights. If you're interested about everything, so the Python, the raw stuff, everything is on GitHub. I will be very happy if you check it and if you store it. Just to check, there is a bit.ly URL. So basically, I can see how many people were interested in the code. And though the talk was not about Apache API 6, if I got you interested in Apache API 6, then you're welcome to greet us and have a look. So thanks again for your attention, and I wish you a great end of the day.
Chris, can you hear me? You're on mute. You shouldn't mute.
Oh, I'm muted. There you go. Oh, beautiful. I'm so good. Not. All right. Once again, thank you very much, Nicolas. That was great. I certainly have a few questions. In case we don't have any other ones, I do have them. So next up is Thomas Segismont. He's with Red Hat for quite a while already. I think over 12 years or so, or maybe 15 years. I don't remember. And he was with the JBoss team for a long time, and for a while now he's with the Vertex team, and he's bringing us through a lot of different things on how to do reactive database access with Vertex, and what you have to do with JDBC, and how you can do all of that magic. So Thomas, take it away.
My topic for today is reactive database access. I am Thomas Segismont, a principal software engineer at Red Hat. I am a member of the Eclipse Vertex core team. Eclipse Vertex is a library to build reactive applications on the JVM. I am also a contributor to the Quarkus Cloud Native Development Framework. In this presentation, which is split in 3 parts, we are going to talk about modern application design, and in particular, why new requirements have led us to develop reactive programming models. In the second part, we will see how we can, in this model, communicate with relational databases. And in the last part, I will try to give you a taste of the Hibernate Reactive Library, which is an object relational mapper built on top of the Vertex SQL clients. So first, let's see how the IT landscape has changed over, let's say, the last 15 years. They have changed, in my mind, in 3 different aspects. The first aspect is the evolution of the use cases. In the beginning, we were building applications for back office user, maybe a few dozens of them. And basically, the work needed was to take some form data and storing it to the database and build reports for the users. Nowadays, it's very common to have user-facing apps with quite often maybe thousands of users active at the same time. And the requirements of those users, which access the application through mobile devices, tablets, a lot of different means, are very different because they want live dashboards. And so we have to implement streaming data on top of WebSocket or server-sent events. So for our applications, it means a lot of network interactions with the users. Also, as our feature set has grown a lot, we have transitioned from monolith design to microservices. So this process has given us the ability to cut the feature set into smaller scopes, and each scope is assigned a different team. And the team being smaller, it means we can easily manage them and deliver software faster. And we can scale only the necessary parts. But again, as a consequence, to deploy to production a system, we are going to deploy a lot more individual applications, which will make a lot of network interactions. The last aspect of the transition is how we deploy the applications. So at the beginning, we had bare metal servers, very powerful, very expensive. And then gradually we have moved to virtual machines running on commodity hardware, much cheaper, so that when a commodity server fails, we can easily switch to another one for running the virtual machine. And now we more and more deploy applications to containers for various reasons, but two of them are important in my mind. The first one is to be able to support the agility that we aim for building microservices, and the other one is to maximize the density of our applications on the servers, because the resources are not infinite, and we try to make the most of them. So the new normal for our applications is to be co-located together on servers, sharing virtual resources, very often a couple of virtual CPUs and a relatively small heap. For a Java application, usually we get 512 megabytes. And because our requirements and use cases are very different, we no longer communicate only with a relational database, but also with caches or with alternative storage system like NoSQL databases, or making requests to external services over HTTP or gRPC inside the data center or in the cloud. So we've seen that our applications live in a new era where to build a system, we have a lot of them. We also have to handle many different connections from the users and various connections to backend system, etc. And so this new environment calls for a new paradigm for programming. And let's see why. Traditionally, in Java application servers or framework like SpringBoot, we have a thread pool, and each time a user request comes to the server, one thread is taken from the pool, and then we interact with blocking Java APIs like we are used to, like JPA or Hibernate classic APIs, or an HTTP client from the JDK or from the Apache Foundation. And when we are using blocking IO to do that, then our thread is blocked during the time of the network interaction. And when this happens, of course, the CPU does not stay idle, so the operating system schedules another thread, and then this other thread can do something else for another user. But our first thread is unavailable to serve any user for this time. So you can imagine that if you have many interactions with different backends and many users to serve, then you are going to need a lot of those threads. And they are not cheap, because each thread requires at least one megabyte of stack. And also the fact that the operating system has to switch constantly comes with a cost. Another way of managing your I/O is to do it with event loop threads. In this case, instead of using blocking APIs, you use non-blocking APIs, asynchronous APIs, and when a request comes in, instead of assigning a thread for the lifetime of just one request, then the same frame is going to handle concurrently different requests from different users. So when you are calling, let's say, an HTTP server or whatever with a non-blocking API, then your event loop is able to do something else while the backend server is processing your request. And when the results are available, it can come back to your code and process the notification. how do you combine the data in such an environment? Then you can use different things. You can use callbacks, you can use futures or coroutines in Kotlin language, or you can use the reactive streams family of libraries like Mutiny, RxJava, or Reactor. The benefit that you get from going with non-blocking APIs and few event loops threads is that you are more efficient with the resource that you are given, because you can keep the number of threads to a minimum and keep them busy all the time. And another benefit is that you are more resilient to failures, because when something goes wrong in a backend system, instead of having your threads blocked and waiting for a long time for a reply to come, then you can react by a timeout and then say to your user that the system is not available immediately and that he should or she should come back later. So let's say for a second that you are building a new application in this new era. Perhaps you need to wonder if using a relational database is a good fit for your microservice or your new application. Because indeed, there are many alternative storage systems nowadays, and they have been born in that new era. And so they already provide non-blocking clients and protocols that can do streaming and multiplexing. So perhaps it's a better idea to go with document-oriented storage or key value or column-oriented storage. But the reality is that the databases are still very efficient, very high-performing. We also used to say often that they were lacking some features, but nowadays they all have these features like JSON, geospatial data, key value for some of them. And another important aspect is that either in the development teams or the operation teams, we have a lot of people who are very competent with relational databases, which is not necessarily the case with new storage systems. And last but not least, even if you create a new application, sometimes you have to make requests to an existing database which is not going away. And in this case, you just have no choice. You have to be able to communicate with it. So as Java developers, our options historically have been very limited. We all know the JDBC API, which is the spec that is made by and provided as an API in the JDK. It is very low level and a blocking API. So for the reactive model, it is not very well suited. In the Vertex stack, we used to support a library called Postgres Async. And this is different from JDBC because it does not rely on a driver. It implements the protocol of the database. But the thing is, it is built with Scala. And so for a lot of our users, it was not possible to pay the cost of having a complete alternative language stack. And so this is why we started the Vertex SQL clients, which are for the native clients complete implementation of the database protocol in a non-blocking manner. So let's see what are the Vertex SQL clients in a nutshell. In a nutshell, it's a set of high-level APIs. So the usual objects that you are used to interact with the database, a connection, a pull, a transaction, that is very common. And these different APIs have different implementation. What I call native is not the fact that it's built with a code to native library through GNI. No, it means that if we implement in Java a non-blocking communication on top of the TCP connection to Postgres, MySQL, SQL Server from Microsoft, and IBM DB2. And in many companies, there are alternative database systems, and sometimes you don't have the choice. So we also provide a fallback to a JDBC wrapper in case you cannot use one of these native clients that we have. And we also have a specific implementation for Oracle built on top of the JDBC reactive extensions. The last part of the Vertex SQL client, which is very nice, is the SQL client templates, which purpose is to be able to map your parameters in your queries from your Java objects. And at the opposite side, when you execute your queries and you get results from your database, you can map the rows to Java objects. So that sounds probably to you much like an object relational mapper, but actually it's much simpler. An object relational mapper is much more feature rich. Here it's really simple mapping of your result sets and params. So let's start with the Vertex JDBC wrapper, which is the most basic one. What happens, because it's a wrapper of a JDBC driver which has blocking APIs, is we are going to offload the blocking parts to a worker thread. And so when the results are ready, and we have executed the blocking call on a worker thread to the JDBC API, then we will send a message to the event loop that it can pick up the results and go back to the reactive world. We are going to need at least as much worker threads at connection of pool, of course, so you need to be careful with provisioning. Let's see a demo with the Postgres client, with the JDBC wrapper for the Postgres database. I have built a simple application, which is just a REST API which communicates with the database, and it is able to store product items in a database table. So here it's a Vertex application, which is not complicated. You have to extend abstract vertical class and implement a start method. In this method, we get the configuration for the database, and then we immediately initialize a pool. To initialize a pool, what we have to do is to create JDBC connect options in this case, because we're wrapping a JDBC driver. For JDBC, you have to provide a JDBC URL and at least user and password. And then we configure the pool to have 5 connections. If you remember correctly, I said that JDBC didn't come with any pool. So here in this project, I had to add in the class path the agrol pool object that is developed at Red Hat. When we have that, we can create a JDBC pool, and that's it. Now to define my REST API, in Vertex, we have an object which is called a router. So when I get a GET request to the products path, I will list the products. For a GET request to a specific product ID, I will fetch a single product from the database. And for a POST request to the products path, I will create a product from a JSON body. So let's see how this is implemented. First, list products. We take the JDBC pool object and define a query, a simple query. And when we execute it, it is an asynchronous process. And we map the asynchronous result, which is a row set, to a list of product. And what we have here in the raw API object of the SQL client is that we can convert it directly to a JSON object. And then when we have accumulated all these objects in an array list, we can transform that to JSON array. In Vertex, it's easy to manipulate JSON objects and arrays with those 2 objects, which avoid you to do unnecessary object to JSON mapping. Now let's see, to create a product, we get the product object from the request body. Then we validate manually the product in case something is missing, like the price or the name. And then when it's ready, we can prepare a query with the 2 question marks as placeholders, which are common in JDBC. And then we can execute with a simple tuple, which is a Vertex SQL Client API, to be able to group some values. And finally, to get a single product, here is an example of the SQL template API. We call from SQL template and the JDBC pool a query where we map the ID parameter, and we take it from a simple match which has an ID key and an ID value. And to the SQL template, we say map this, all the rows retrieved from this SQL query as a product object. And at the end, what we can do is simply iterate over the results, and we should have one if our database schema has been defined correctly, because obviously there is just one row for the primary key. So let's see how that behaves. I can start my application here. For GDBC, it will be this command. So what I have done in my application to avoid starting a separate database is I use test containers, which runs a test Postgres database in Docker. Of course, you wouldn't do that in production, but here it's very convenient. It starts one with my Vertex application. When it's ready, you see here I'm on the event loop thread, and what I will do now is to create a product. Let's say product, and I create soda with price 110. When I do that, I see that the application replies with the soda object. And what you can see is that everything which happened on the JDBC connection that we have wrapped happened on the worker thread. And that's what I wanted to show you for the JDBC wrapper. So things you have to keep in mind when you're wrapping a JDBC client, it works with any JDBC driver, so you can use any database that provides one. You have the exact same SQL client APIs, so you can use collector queries, but we don't have the time to show an example today. You can use the SQL client templates, but you have to keep in mind that it will increase the number of threads because you have to offload blocking calls to worker threads. And so because you do that, you are going to increase the context switching, and you need to be careful with provisioning because you need at least as many threads as you have connections in your pool. Now let's look at a native client like the PG client. This time it's completely different. We will use event loops to manage the connections to the database. So it means the database protocol codec is invoked on event loops. We create a TCP connection with the Vertex Net client, and then we send requests on this channel to the database. Each database connection is assigned a single event loop, so every interaction that happens on this connection uses that same event loop. So if your, let's say your HTTP request is handled by an event loop 1, when you need results from the database, it will send a message to the other event loop, which will make the query. And when it gets the results, it will send another message back to the first event loop that manages your HTTP requests, and so on and so forth. Here we don't have content switching. Instead, we have message passing. A benefit of this approach is that we can do things we can't do with JDBC drivers, like pipelining. So pipelining in SQL clients is the same thing as with HTTP. It means that you can send several requests in a row to the database, and you are not forced to wait for the results of the first one before you can send the second one. Of course, the results will come in order as you sent, but then you can use the result whenever they are ready. Another thing you can do if you manage the TCP the connection yourself is that you can use Unix domain socket. And that can be useful if, for example, you want to have end-to-end encryption, and it's always been a bit complex in Java to manage such a setup. So your operation teams could set up a Unix domain socket for you, And if you connect the client to the Unix domain socket, then it proxies the connection directly in a secured way, and you don't have to bother with anything inside your application. Let's see how the code looks. Surprisingly, the code doesn't look very different. You still have a router for your web API, and if you go to init pool, this time we don't depend on a JDBC driver or an external connection pool. This is all provided by the Vertex SQL client. But we still have to provide the same usual stuff, the database name, the user, the password. And when we create the pool, it's still connect options and pool options. Here, a small difference that we have, when I call the list product method, I can use easily the JSON support from Postgres, and instead of creating the JSON array inside my application, I can ask Postgres to do that for me. And the rest of the application is very similar. We still have the SQL template, etc. So let's see what it looks like in practice. Again, my database container is starting before my application. It's just more convenient. And if I create a product and then another one like bread for €2, then I can list my products if I want, and I will get an array with the soda and the bread. And this time you see I don't have anymore all the JDBC interactions. It's just my methods which are called on the event loop. All right. Now let's recap a bit on the native clients. So first, you have all the same client API, no context switching. You can do pipelining with some databases like Postgres and MySQL, and you can do advanced stuff like domain socket support. On the downside, the feature set depends on the client. Some are more mature than others. And the number of databases, of course, is not extensive. But it covers already a lot of them. Now, a lot of people in the Java community are used to object relational mapping and the way of creating applications with annotations. So what the Hibernate team has done at Red Hat, they have built with Hibernate Core on top of the Vertex SQL client, an Hibernate reactive library. So let's see what it looks like. This time, what we create is still a router, but then when we don't create the pool ourselves, we will initiate an entity manager factory like we do in Hibernate Classic usually. Don't be fooled by the fact that the configuration requires a JDBC URL. It's just because the Hibernate core is shared with Hibernate Classic, and it is expecting an URL with this scheme, so we have to keep it. But then when it's ready, what we can do is pretty much like what we do with Hibernate Classic. So we use Hibernate query language, and we can map our results with, for example, a product entity, which is annotated with the same annotations we're used to, entity, ID, generated value. And cherry on cake, we can also use the Hibernate validators annotations to validate our objects. So when we create a product, instead of validating manually, we can now validate the product entity with Hibernate Validator. So let's see what it looks like. This time I'm going to start this application. And when it's ready, I'll be able to create a product. And you can see that here, Hibernate has executed my request on an event loop thread. Takeaways: you can do reactive database interaction with an object relational mapper, It's the same ecosystem that you are used to. But still, on the things to keep in mind, it's not an excuse not to learn SQL. It's like Hibernate Classic, actually. This is not specific to reactive. And this is not for every use case. It's for some kind of interactions which do not require necessarily advanced SQL features. What's the future? Well, we had several years before we got from HTTP 1 to HTTP 2. We could expect that someday the protocol for the databases and the clients can leverage multiplexing, etc. We will see if the future provides us with that. And to conclude, we can say that relational databases are still relevant in 2022 and in 2023, actually. What you have to keep in mind is that reactive access is all about efficient resource usage. It's not necessarily about performance. Performance is a side effect of efficient resource usage. The Vertex SQL client bring high-level APIs like pool, templates, etc. And you can still fall back to JDBC wrapping if your database is not supported. And if your team is used to work with the annotated Java ecosystem, then you can leverage the Hibernate Reactive project. Thank you very much.
All right, thank you, Thomas. Looking forward to talk to you and actually have a lot of questions again. I see a pattern here. The last slot, the last speaker for my slot today, before we come to the Q&A, is actually Timothy Spann. He's about a decade into engineering and specifically all kinds of data management, IoT data, all that kind of stuff. He's a developer advocate at Stream Native, and he's going to talk about how to implement data pipeline, or how to write data, store data, and how to analyze data with SpringBoot and I guess a lot of small different microservices. So we're going to figure it out. And with that, Timothy, take it away. Thank you very much.
Hi, Tim Spann here, developer advocate. My talk today is entitled Living the Stream Dream with Pulsar and SpringBoot. Big title. I have been doing streaming for a number of years at different companies like Cloudera and Hortonworks, Stream Native, Ernst & Young, Pivotal, HP. And it's been everything from Pulsar, Flink, Kafka, Spark, NiFi, Spring, Java, Big Data, Cloud. There's so much technology out there in the last 10, 15 years. I've been focusing on a combination of technologies around Flink, Pulsar, and NiFi that let you get done as easy as possible these really complex things. Here's the thing about my talk, a little bit on SpringBoot and some of the things we're going to show, the links to the current documentation, and a quick podcast I did with Josh Long recently. That was a lot of fun. So Spring is out for Pulsar before the spring, which is nice. And Apache Pulsar is everywhere, and you'll see why. So could go in introduction. What is this Pulsar thing? Some Spring apps, some different protocols, some demos. As much as I can get done in 30 minutes, goes quick. Pulsar is growing, huge amount of people involved. Over 500 contributors, 7,000 people in our Slack, 10,000 commits to GitHub, 1,000 organizations using it, and there's a couple reasons why. There's a good Spring interface out there, but you could use different protocols. So I could use Pulsar's own, or I could use Kafka's, or AMQP, which is RabbitMQ, or MQTT, or WebSockets, or REST. And there's libraries for almost every language you can imagine. Also, besides easy to get data in and out, I can use data different ways depending on what I feel like. So every different app, every different consumer who wants it, they set up their own subscription and they decide, do I want to do streaming? Okay, let me do key shared. I'll set my subscription to that type. And then for every key, exactly once in order for that consumer. This is great for CDC, lots of other use cases. Now, I can also have a failover type where I have a dedicated consumer, gets it exactly once in order, But if he's not functioning, let someone else take over. Never stop processing the data. Great thing. Exclusive, like failover. But if you stop consuming, you got to wait till you start again. Not a big deal. Shared, work queue, old style messaging, JMS. As many messages pushed through the system as possible. Have 10,000 consumers running. Everyone gets one. There's no order, but I process things real quick. Great for jobs, work queues, that sort of thing. When we talk about data going through Pulsar, it's a message. That's what we're going to call it. The main body of it is a value. This is your payload. This is raw bytes, binary data, but we can add schemas on it. You'll see that later. Key, you don't have to put one, but it makes your life a lot better, improves performance, so we can compact the topic. We can partition data for more performance if we need it. Also, it's good for your own use to try to find it. We also use this in the table view if you want to use that, which gives you a key value to the most recent key of that data. Properties, key value map, or whatever you want to add. This is so you don't change that raw payload. You want to add some metadata, some enrichment, keep it outside there. We do that in Apache NiFi too. It's a nice thing. Producer name. If you don't come up with one, we will generate a boring one. So give it a real name. So if you want to audit, track some things, if something's going wrong, debugging, you know who produced it when, helpful thing to have. I tend to put in like Java, SpringBoot, this server, this app, so it could really be sure right away, go, oh, recent app broke. Sequence ID, you don't have any control of that. We use that so we know your messages are in order, which you might like. So we do messaging, which again is a lot of people get the message, comes in, you use it. It's great. It's like a bulk mail. Everyone process it. Everyone get one, get the next one, get the next one. You know, assembly line, get as much done as possible. Streaming. These are the use cases you see with Kafka and Kinesis. Exactly once, in order, consume it, maybe consume per partition, consume per key. I get it and I consume it only. It's a great way to move data around. We mentioned a couple different subscription types here. You'll get these slides. Now you could do a lot with Pulsar. There's a huge ecosystem of related things here. We do lots of different protocols, like we mentioned, libraries for so many languages, and there's a ton of others we didn't mention because people just wrote them on their own. These are the main ones that we support. Connectors. So if you don't want to write code or don't want to write too much code, you set up a connector with some YAML, put its binary there, and what'll happen is when something hits the topics that are relevant to that syncs, it perhaps it'll send that data right there. So you have put something into an air quality topic, it'll stream right to Iceberg. On the other side, you want to pull data from somewhere, you set up a source, say it's from ActiveMQ or Debezium or Delta Lake, whatever it is, streams into a topic and you can use it for whatever you want. Now, when we show you an example today of a function, these are in Java, Python, or Go. These run inside the environment or inside Kubernetes, and they process things real easy. You don't have to know how consumers work or producers. You just map in with some metadata what topics come in, what topics go out. Inside there, write your code. Could be ML, could be things like change the schema, add a field, enrich, do some math, make everything uppercase, make everything lowercase. Just a little bit of functionality, not a huge app. Huge apps I put in a processing engine like Flink, Flink SQL, Spark, Spark SQL, Presto, Trino, Lambda. Now for Trino and Presto, they access the data via SQL and they do it at a point in time. So I run a query, select star from air quality topic. Gives me all the data that's currently there. Now, if I do that in Flink SQL, gives me everything that's currently there and maybe older if I want. And then every time a new row comes up, my query adds that. So I get it real time as it comes in. You can imagine what kind of apps you can run there. Pretty cool. I'll show you a quick example if we got time. Data offloaders are how we do tiered storage. You plug these in and based on your own criteria, maybe the data gets too big, maybe the data is too old, or maybe every 10 minutes you just want to send the data offloaded to S3. It doesn't matter to the rest of the system. If I try to consume it, like I do a query from Trino, it's still there. It automatically finds it, makes it really nice. You don't have to do any extra work. It's just an extension of the messaging system. Lots of protocols, like I said, they are first class native protocol handlers. This is not a sidecar. This is not an add-on. This is not some weird translation layer. This takes the protocol just like the native system, supports all the libraries. So for this one, all the Kafka libraries and apps out there communicate right into and out of Pulsar as if it was a Kafka cluster. What's nice though is message gets produced by some Kafka app, could be a SpringBoot app, gets into Pulsar. It is Pulsar data now. So if I want to consume it with Pulsar or with MQTT, AMQP, any of those things you saw on the last page, I can do it, or I can consume it with Kafka. Same thing for MQTT, which is great for all these little IoT apps in the world. Have them send out their MQTT that they love sending, and it just comes into Pulsar. I don't need a gateway, don't need multiple servers. I have one messaging cluster for everything, including your old Rabbit apps. Don't have to change anything, just keep using them. And now everyone uses one messaging system. So I can join different streams of data from different messaging systems in real time with something like Flink. Pretty awesome. And to make sure that your data is the data, you got a basic data contract and cleanliness there. Got a built-in schema registry. Don't have to run somewhere else, some other thing. Supports Avro, Protobuf, JSON, and some other string and some other things. And it's extensible, open source. Add more if you need to. And this happens automatically. I'll show you in the code. You could set up a schema manually and push it via DevOps or REST. But the easiest way is set up an object in Spring. Push your first message to the topic. Now you got a schema. Change it. Now you got a version of that schema. On the other side, they consume it. They get the schema. Very easy. Great way to do this. Now, if I'm building real-time apps, I'm probably just not doing Spring. Probably not just doing Spring and Pulsar. Maybe I have Flink in there for some analytics, Scylla for some lookups, Delta Lake for all my lakehouse storage, Spark for some ML. Now, if I had to pull in some other sources, all of it around this central messaging hub of Pulsar. Great way to build apps. Pulsar and Spring. Spring is Batman. We're the new kid, but we're helping out. Together, we do some pretty cool applications. The code is really simple. You get a Pulsar template. You put your Java class in there. You set your schema. You see here, I'm doing the JSON one. If you did schema.avro or schema.protobuf, you'd get that version. Once you set a schema type for that topic, can't change it really easily. Create a new topic. Pulsar, you can have 1 million+ topics in your cluster because we support multi-tenancy. So you set up a tenant, namespace, and topics. You can see that over here. Public is my tenant. Default is my namespace. AQPM25 is the topic. Persistent tells me to store it and never lose this data and expire it when everyone's acknowledged it. And you set a timeout or a time, size limit. Say, hey, delete everything if it's over a year, or if it's over a petabyte, or just send it to tiered storage. Then up to you. If you send non-persistent, it's just going to go away within a certain period of time, just in memory. That's if you really need to move stuff fast. I tend to do that with something that's a little device that's peeping out the same data 1,000 times a second. I just need to sample it. I don't really need to keep it. That's a smaller use case. So the API here is really simple. Take that template that's been auto-wired, create a new message with your instance of that data. I'm getting it from REST, and I'll show you in the code. Add a key to it, send it away, get a message ID back. This is a unique message ID. I can log this to a system if I want to audit or track that later, or do confirmation. Some people like to confirm every message. That's up to you. You could also send this asynchronously, and then it'll come back. It'll call you back. I like to do the send synchronously. They happen so fast. It's really up to your application style, what type of app. You got both options there. We also have a reactive one. You can take a look at that in a little bit. Now to get data into your app, which you don't have to do both in an app. I just do this because I'm lazy. So we put a listener on, give it a subscription name. With this subscription, this means this is just mine. I could share this with someone, but this one is going to be a shared subscription and for this topic, and I'm going to get it. If I made it exclusively, only I would get it. But if I want to get a copy of that data, just get my own subscription. And here we're just outputting it. But we'll show you that. Configuration is easy. We do it with YAML or JSON or in the code, whatever you're comfortable with. And you can set some environment variables too, all that sort of stuff. Pretty easy. This one is SSL with OAuth. If you're running it in Docker, maybe you have no security on. Depends how you like to develop, Kubernetes, wherever you're running it. Lots of security options, pretty straightforward. I set a couple of parameters here. Remember, there's that producer name. There's the topic name. I could change them pretty easy. If I turn batching on, it'll batch into a certain size, and I could set that size. If I don't want to send one message at a time, depends what your data looks like. Maybe I want to batch up 1,000 before I send them. You know your network, you know the different apps. There's a lot of things you could tweak in the configuration as much as you want. Now we can also send messages from Spring to Pulsar via Kafka. So we'll use the standard Spring Kafka library, use that Kafka template. String here is the key. Observation is that class we talked about. That's how we get our schema. So I produce a record, put in some data, put in the topic, and we send. Pretty easy. There's some good examples out there. Standard Kafka library. Don't have to change it for Pulsar. I'm just pointing to Pulsar now. Do the same thing with MQTT. Straightforward. Set up an MQTT client in Pulsar. Point to your Pulsar host and port. We could use the generic MQTT ports or change it. Up to you. You could also use MQTT with SSL. You have that set up. Create your message. Set a payload of the data. We're just going to serialize some JSON. Set quality of service. Say you retain it. Publish to the topic. Bam. Lots of examples. This is just a generic Spring MQTT library. Pretty straightforward. Same thing with AMQP. Set up a connection to the server. Again, this is the Pulsar server. Use the Rabbit template to convert and send this data off to the topic. Pretty easy. Now we could also use the reactive library for Spring. This one is pretty cool. This has been around for a little while, but just got moved into the mainstream. This reactive template, pretty cool. If you're doing reactive coding, definitely take a look at this. Pretty easy to use. It's going to look pretty similar to other reactive ones. Here, when we're doing our listener, it's a little different. We're using the flux on the message results, and we can output it. One important thing you'll notice here is we're manually acknowledging it. So every time we get a message, I agree that I got it successfully. I can negatively acknowledge it and say, I didn't get it. You know, maybe I just wanted to look at it and go, ooh, I'm not ready for this. Well, that's okay. I can go to the next message and acknowledge it or not acknowledge it. What's nice is for my subscription, everything is stored on the server, so you can come back at any time and fill in those gaps or let them expire if you really wanted to. That's up to you. A lot of power there. You don't have to worry about acknowledging every message if you don't want to. But if you acknowledge them, it's not going to show up in the listening unless you do a reader and go back to the beginning and go in order, or use something like Trino or Presto, or go back to the beginning and Flink. Up to you. The little app I'm showing you, SpringBoot app, reads some REST data, pushes it into an air quality topic. I also have versions of the app all in GitHub to do that via Kafka, MQTT, and AMQP, whatever protocol you like. Send that into Pulsar. Once it's in that topic, it triggers a Java function. I'll show you that. It splits the data off into 3 topics based on their sensor type, and then it's available for Flink and Spark. We might do some Flink. I won't show you the NiFi one. It's just pushing into Pulsar cluster. Very easy. I have a weekly newsletter. Check it out. It's available at flipstackweekly.com. I put it out in LinkedIn, a bunch of blogs, GitHub, lots of different ways. I do videos, podcasts, articles, code, cool tools I find, news, anything going on in open source and streaming, Flink, Pulsar, Kafka, NiFi, Spark, Iceberg, all the cool stuff out there, Spring, Java, Python, ML, chat GPTs in there, whatever is cool that week, I put it in there every week. Sometimes it's a little hard. I've got a demo coming up showing you the super friends of Spring and Pulsar together. Here's a couple of resources. You're getting these slides, and don't worry, try to take a screen print. You don't have to. Here's some of the Spring libraries I use. There's so many great ones out there, but it makes it very easy to work with. We've got a free book on Pulsar. It's a full PDF, like 700 pages, covers everything you want to know, probably more, goes really deep on every topic. It's very cool. David did a great job. Definitely check that out. I'm Tim Spann. If you like the code I'm about to show you, contact me on LinkedIn or Twitter if it's still around, or GitHub, or scan here and go to a page that's got some cool resources. If you didn't like the talk, my name is Bob and you cannot contact me. Thank you. So let's look at some code. Now I've got some GitHubs up here for the Spring Pulsar air quality, my reactive example, that function. And let me connect to my server. I probably timed out because I've been talking a while. I tend to do that. That's kind of not what I'm supposed to do, but you know. Okay, so we find air quality is where I'm going to send the data. So we could take a look at this. We talked about some of the features of Pulsar. This kind of shows them in detail. This is also a SpringBoot app out there in the open source community. This tells me all the subscriptions out there. You could see the different types. You could also see how many messages are backlogged because each subscription is tracked by the server. So it knows what you haven't read yet, what you haven't acknowledged, so you can go through it and read it. Now, if we wanted to get rid of one, I can unsubscribe it, clear it, whatever. We could also take a look at the storage from Bookkeeper, and you see all the different ledgers where we store the information. It's not just in some flat file. You'd also see the cursors that point to where people are in reading this. And you can see that's your subscription that tells you, oh, here you are, boop, 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 boop. And it'll figure out where you are, how many messages you have to read, how many partitions we have. For this one, I didn't pick a partition, so we just have one, partition 0. When you get different types of streaming, you might want to add more partitions. It's not as required as Kafka, something you could do. All the Spring documentation is here. Great people at VMware, DataStax, and Stream Native have worked on this. Thank you, guys. It's a pretty awesome library. Get your Java 17 on for Pulsar 2.10, SpringBoot 3, Framework 6, and up. Works really easy. Gradle by default. I'm using Maven because I'm lazy. But let's go to the code. We'll show you a little code here. This is an example consumer. Calls Pulsar, standard SpringBoot app. Sets up that rabbit connection. Points to the cluster, sets up the template. And then here, this is all I have to do to consume it. Set up a listener for the topic that I've got defined in my properties. Pretty straightforward. If I set up a topic without a tenant or namespace, it's going to default to public and default. And we're just going to consume that. Pretty straightforward. Not the most difficult thing in the world to do here. And we've got just outputting the name. That's a simple one. I also have one for Kafka. Kafka's a little more work there, but the listener just listening to topics sets up a group. There's our template. Pretty easy to do for Kafka as well. Again, that's standard Spring code. Same with MQTT. Set up my client, get my connection, and then my service consumes it. The consuming here is a little weird. We've got a count latch down, do our subscribe, and then just waits, and then it sends it back to us, which is fine. Again, we got a model where we can put all the data into it. We got something to configure everything. Simple code. show you something a little more interesting. This is that Java function. What's cool about this is it supports some really good integration tests. So you set up a test for your function here, and by default, you can run it. You could run just a regular tests, pretty straightforward. You know, just here, just a basic one where I'm doing a mock, just running the function itself, just to make sure things process the way I want. But you've got a full integration test here, which is a feature of Pulsar. You can also work with test containers, which are awesome, but we're not doing that right now. Here is I set the topics that are coming in, set up the configuration to deploy this function temporarily in this environment. I point to my Pulsar cluster and I start it, and it will actually work. So if I send messages in, the local function will run and process them. If you've already got it deployed, don't point to a remote cluster. Maybe run your own local in Docker or whatever, or in test containers, because otherwise you get a function clash. But really easy to do. The function is pretty basic. Process is the method you have. I'm not returning anything. By default, you could have it return the message to a topic you set up. But what I'm going to do is a little different. I get my data in as the raw bytes. I get a context from Pulsar that lets me get access to things like the topics and a logger. And this will log to a Pulsar topic, which is nice. And I could also log to command line if I want. Here, I'm just looking at the messaging system. I set up a service. I deserialize that because I just have bytes. I didn't have I didn't want a schema on this one. And then here, output it if it's enabled. And I'm going to look at one of the fields here. This field is the parameter name. If it's 2.5, then I'm going to send it to the PM25 topic. What's nice here for this routing, if that topic doesn't exist, it can be created based on your security. So I send that data to this new topic of this schema, set an ID, set one of those properties. I can add as many of these as I want, set the value to be the instance of that data, and send it. And I'm doing the same for PM10 and Ozone. And if it's not one of those, throw it away. I don't care about it. And then I could put the errors over there. Pretty straightforward. You got your tester there. Pretty easy way to process data as it comes into a topic. Now, how's that data getting there? I've got a SpringBoot app, simple SpringBoot app. I've got scheduling on because I want to keep running it. So I got that template for that particular object. Here's my object. Only thing a little different is I'm adding the JSON properties, so I get the name there and ignore any other junk. So I know this is what I want the table to look like, so I labeled it that way. Get the data in. Every second I run it, set my template, get some REST data for the air quality, loop through it, set a unique key, send a new message with that key, get my message ID back, and pretty straightforward there. One thing I added though is I have one of the cool features for SpringBoot plus Pulsar. I've got a producer interceptor, and I'm using this for logging and auditing. So when I get the acknowledgement that a send happened, I get the producer, the message, the ID, and any exceptions. Pretty awesome. Here I'm grabbing the schema, and I could grab the whole text of the schema if I wanted to for auditing or debugging. Here I'm just putting the name, producer name, message ID, key, and the data. We'll see that in the command line. The other thing we have here is, remember I said the listeners, got listeners for all those three topics. Pretty straightforward. Let's run this. I'm going to run it from the command line. It's not yet Spring native. That I'll do in the next iteration of this code when I get the next version of Spring. And here it's connected to Pulsar. And you see here we've got some things going. This is the reactive one. Over here, I'll run the one we were just looking at. I didn't show you the reactive one yet, but you saw some of that code. Getting a little low on time. This one's a little more interesting. So I started up my Spring Boot app, and as you can see, I'm sending messages every second. If we look at what I'm sending, you can see here, there's the message ID. That's the type I'm sending. There's that interceptor that's telling me some of that information. Who is the producer, message ID, what was the schema, what was the data, all that kind of fun stuff. And we also have some listeners going. Here's an example listener. It's getting back the message. I just do a 2-string on it, and plus all the headers, so you get all that metadata. So pretty easy. And when I'm done, I could just stop it. Obviously, I could deploy this to any Kubernetes or just a bare metal environment. Pretty easy. Now I can also, this was that reactive one I didn't show you. I can also query that air quality topic with Flink. And I just deployed that Flink app. We look over here, you can see that it's running, and it's doing, grabbing it from that topic, doing some aggregations, and I could see we've got over 900 records showing up. So if I go to that query, I could see here the query's doing a max and a min and an average, how many rows they have for different reporting areas and different types of air quality. And if we look, we could page through this, different values here. That's pretty cool. And as new data comes in, so if I continue to run this, more data is going to show up in my query. Or I could do a more straightforward query than the min max. I could just do a select star from air quality if I just want to see all the data. And if we come into here, it's going to put out a new job. This is a new job here that's just doing a standard select. And within a few seconds, it's deployed and running in my Flink cluster that I got on my laptop. And as you can see, new data is coming into the system. We can see all the fields in there. And just as new messages come in, they just show up here. Pretty straightforward. You can see there's a lot of fields, lat long, so I can put this on a map. New data just continuously comes in because, as you can see, we produce more. Pretty straightforward, but it's a pretty fun way to get your data. I've been Tim Spann. Thanks for coming to my talk. Hope you enjoyed it. Enjoy your next talk.
All right, thank you, Timothy. Yeah, we're coming to the Q&A section. So I'm really happy to have all three around. So first of all, let's say hi to Nicolas. We have Thomas, and we have Timothy. Where is he? There he is. Perfect. Thank you very much. Beautiful to have you guys all here. It's awesome. All the sessions were great. I added a lot of questions to the question roster. So first of all, what do you guys think so far about the conference?
Very cool. A lot of content, a lot of things I did not even have a clue about. Like, I'm surprised on the improvements, a lot of frameworks out there. Very impressive.
All right. Let me just need to quickly let the back end crew know that I can't unmute Nicolas for some reason.
I can unmute myself.
There you go. You guys can be unmuted. We're just going through a couple of questions here, so feel free. Let me see what do we have. Timothy, let's go with you. As you've been the last, so you're gonna go first now. So what is the main purpose of Pulsar when you in your examples, right? You could basically do this with just RabbitMQ or a Kafka or anything like that. There were a couple of people asking for that, basically.
Sure. Yeah, there's definitely a lot of options in messaging and streaming. There's a couple of advantages for Pulsar. One of them is support for all those protocols. So you don't have to run 3, 4, 5 different messaging systems and then try to figure out how do I get messages between them. that makes it kind of a universal messaging hub. Second is support for multi-tenancy. So I could set up one cluster and have different companies, different apps, lots of things going on with one system, supports all those different messaging protocols. So a Kafka message could be shared with a Rabbit user. You don't have to rewrite your Java applications. Gives you a lot of flexibility there. And then support for millions of topics. So if you have to have a lot of things, because again, if you're moving 6 or 7 systems into one messaging hub, you may need a lot of topics there.
All right. Yeah, that makes sense. So let's see. Next up, I think is Nicolas, and I have the question of all questions when it comes to logging. How much logging is enough, and how much is too much?
So it's a good question, but my talk was about tracing. So
I know it's your
answer,
fault,
but it's a bit different, right? I hope I made it clear. If it's not clear, well, I should definitely change my talk. Enough, it depends a lot on the context. If in any case, if you doubt it, then probably you should log as much as possible. You should think about either your colleagues who will need to debug your stuff or your future self. If you lack empathy, then think about your future self. If you have empathy, think about your colleagues. But when they will need to find a bug, they will need as much clues as possible. And so in this case, it's better to have more logs. Of course, you should have different logging levels. So what is very important, what is less important? Again, in case of doubt, just increase the level. So it's better to have more than not enough. And in general, too much is when your manager or your FinOps manager comes to you and say, hey, we are spending that many thousand per month because of logging. Perhaps you can like tune it down a bit. So start with probably too much and then go down until you are pretty happy with the balance between, okay, we have enough information to debug if something happens and we don't spend too much. It's very context dependent, obviously.
Yeah, along the line, since you said your talk was about tracing, which is true. I guess tracing is a little bit different, right? Sorry, the question is not in the roster, so I'm just making it up on the fly. But for tracing, I think you don't want to go overboard, right? You don't want to have too many spans.
Yeah. Again, it depends a lot on your architecture. Like if you are doing microservices, and everybody is doing microservices nowadays, no, I'm joking, probably you shouldn't, but at least you are doing distributed systems. Again, it's better to have an understanding of your system. I don't know if you have seen it, but in my application, I had the diagram where I showed, hey, this is the product, it calls the pricing, it called the stocks. But there was, in the runtime, one of the microservice went back to the API gateway to do the call. And in that case, perhaps you missed it. Perhaps it was not on purpose. Perhaps it was. I have no clue. So that's also something that can get you some insight. So again, it's like for logging. It's better at the beginning when you deploy your application or your system in production for the first time to have a bit more information than necessary, and then turn it down if it's not necessary anymore. I mean, in general, the bugs, they happen after you deploy something new. And well, after it has stabilized, you can turn it down.
Right. Okay. So Thomas, let's come to you. Does Vertex support OpenTelemetry?
Yes, it does. It does. We have different components in the Vertex stack. We have HTTP client, reactive SQL clients. We have the Vertex HTTP server, and in the implementation, we have an SPI that opens the door to different tracing implementation. Actually, we have one for Zipkin, one for Open Tracing, and one for OpenTelemetry.
All right, because that
So-
was such a condensed answer, and because I kind of expected it to be. let me find the other one. There you
For the
go.
record, Open Tracing has been merged in OpenTelemetry, so
Yeah.
normally it shouldn't be. Well, it shouldn't. No, I mean, it can be deprecated, obviously, after some time.
Right.
Yes.
The
Absolutely.
the other thing that I found really interesting looking at the code example, you had the JDBC call, and then you had the mapping, basically the row set mapping. Could you actually run a second JDBC call or a reactive call inside of that mapping function to enrich objects even further, or would that not be easily supported?
Yes, you can definitely do that. What I show in the example code, which is on GitHub, and you have the links in the slides. By the way, I guess they will be online later. After the query is executed, we use an operator on the future object, which is a map, which just transform synchronously when the object is available. Something which is made available by the future to the next future object. So in this case, with a map operator, you can't do that, but nothing prevents you from using other operators, which lets you do future composition. And so you could say, I want to execute 2 queries concurrently and merge the results, or execute one query, and when the result is available, execute another, etc., and build some sort of data pipeline, so to speak. Yeah, it's definitely possible. The short answer is yes.
The short answer is it depends. Timothy, coming back to you. The persistent topics, are they actually stored on the Pulsar nodes, or are they stored in a database, or how does that work?
Sure, that is a good question. They are actually stored outside of Pulsar in a third part of the architecture, which is a separate project called Apache Bookkeeper, which is, bookies. They are different type of node. It's a different system. They're pretty much a database. It's a ledgered storage system, which is nice, makes it easy to scale storage separately from the computing, separate from the messaging. So if I add a lot more people who are consuming messages, doesn't affect the nodes that are doing storage, which is nice because those storage nodes can be pretty pricey. You get SSDs and big disks. We can auto tier data out to S3 and other object storage, but then you add an extra slight slowdown when you have to retrieve those, but it's not very noticeable to people and it's transparent. You don't have to change your code.
Right. Maybe a quick one from the community or the people watching. Do you know if there's any good reason why there's not yet an official Pulsar image for M1, M2 Apple Silicon?
Yeah, they are testing that. The way around that is to just add the workaround that we've used for 1,000 things, is to put platform equals ARM64 in there, which I think everyone's been doing for 10,000 things. Yeah, I don't know why it's such a problem with the Apple Silicon stuff. I mean, half of us are running those laptops already. So I'll ping people and see why we haven't at least just put that one line of code there, or just built an image. I mean, it's very easy. I mean, it's just a Java image for Pulsar, so shouldn't take more than an hour. So maybe I'll run that build myself and see if I can get that put up there. Good question, though.
All right, let's see. Which one do we have now? Nicolas, coming back to you. Does the automatic instrumentation for OpenTelemetry work for all JVM languages, or is there any magic language like Clojure that is not working?
No, it's working for all. Of course, the closer you are to the bytecode, which is Java, the better it works. I don't know if you've seen it, but in the Kotlin stuff, there was one auto-generated method that got instrumented by default. So it doesn't look that nice. You have the $. With Scala, it could be even worse. But yeah, it works everywhere. Afterwards, if you want to make it look nicer, you can add annotations as I have shown you. Then you can change the way it looks. But like for the Lambda, for example, it will be hard or impossible to add the annotation, so you will stuck with the $. Stuff. Still, I believe regarding the cost-benefit ratio, it's pretty high anyway. So
right.
So
yeah,
I don't think there's a real problem. The short answer is yes, it works for all JVM languages, but there might be more noise depending on the language.
That makes sense. All right. So basically, every time a language has some magic going on in the background, that can be an issue.
It's not an issue per se, but you will get more stuff, like you will have additional methods that are created behind the scene in the bytecode, and so you might have additional instrumentation that show up on your dashboard.
Oh, okay. Yeah, okay, makes sense. All right, let's see. Coming back to Tom. What is your feeling towards Hibernate or general ORMs, and when do you think you should use them, and probably why not? Like, you in your code examples, you showed the reactive queries, like the plain queries, basically, but you also use the Hibernate reactive. When do you think you should use either or?
There are different use cases, but my experience talking with developers is that usually this decision is driven by what they are used to work with, rather than is this a good use case for this tool. That's just a funny note. Let's say the Vertex SQL clients, they can be used either directly inside Vertex or embedded in other applications. It works well, for example, in Quarkus. And Vertex and Quarkus communities are really two different kinds. So the Vertex community users, usually they prefer to keep the application as simple as possible. And for them, usually, executing the queries, making a transformation with the SQL templates is just enough. Now, if you talk to Quarkus user, or maybe Spring users who are more used to creating applications with annotations, then going with an ORM is generally a natural move, so to speak. So it's not to say that developers are afraid of SQL. I think it's one of the most common abilities that developers have in different communities. But experience has shown that if it can be avoided, they try to avoid it if possible. Now, the good use cases, I think, for ORM is if you're implementing some kind of interactions via forms in your applications and storing to the database, and then making interactions like a wizard in your application. Then having managed entities is something really cool and powerful. But if your intent is just to, in the middle of different interactions, like an HTTP backend call, or returning messages from Pulsar, whatever, and you just need one or two rows, data from one or two rows in your database, then maybe just going straight with SQL is just enough. And the two ways are not exclusive. You could do ORM for some parts of your applications, and then in some parts you could use native queries and use the ORM just to map the results. It's a combination between what you're used to, what you're familiar with in general. That's what I've witnessed.
All right, thank you very much. I think we have time for one very quick last question. What is the best way to deploy Pulsar?
There's a lot of options. What's the easiest? Easiest is use one of the pre-built cloud providers like Stream Native or DataStax. Then it's just push a button. The Docker, other than the M1 image that requires that extra line, very simple. It does it all for you. There's some Docker Compose out there. The Kubernetes Helm chart's pretty easy. If you just want to do it for learning, you could easily run the standalone on your laptop. It doesn't run any of the extra side things. It just runs Pulsar, stores the stuff in RocksDB, and you're set to go, good for development. Or you could just run it in your IDE, test containers. All those are pretty straightforward.
All right, cool. Yeah, folks, thank you very much for joining. I really enjoyed all your free talks. And for the rest of the audience, we're going straight into the next part. There is 10-minute break, and then my colleague will take over. Thank you very much.
Thanks a lot.
Thanks. See you.
Thank you. Bye.
What an awesome day to be together here at Global Summit for Java Devs. We want to say thank you to our sponsors from Microsoft. Thank you for joining us. And just a quick shout out to their Azure team, to their amazing products. So Azure is a cloud computing platform that enables you to build, deploy, and manage your applications across multiple clouds, whether it's on-premise or at the edge. So basically, Azure allows you to develop in the cloud and access a range of services that can help you to streamline your workflow and accelerate your time to market. And today, we will have a special link in the chat that you can use to get yourself a free account at Azure. So definitely give it a try, and we hope this community will build lots of cool projects using Azure. Thank you, Microsoft, once again for supporting this event and this community.
The Microsoft Cloud runs in data centers which must be operational 24 hours a day, 7 days a week, all year, every year. This requires continuous monitoring of the data center's critical infrastructure, including power, cooling, network, cybersecurity, and more. It's all overseen by a Facility Operations Center. The Facility Operations Center checks hundreds of thousands of data points per day, each measuring the data center's operational metrics. Highly trained technicians inspect automated trends, resolving any issues as they arise. And beyond the data centers themselves, Azure AI uses machine learning to review those same data points. AI Ops is moving from reactive to predictive monitoring, so it can better prevent future issues. We also have teams of software engineers around the globe always monitoring our services, and thousands of cybersecurity experts analyzing trillions of threat signals daily. It's important to have constant availability and resiliency for our global infrastructure and cloud services. We continue to invest in and innovate on ever more precise monitoring and a more predictive approach to always be prepared for whatever's next.
Hello guys, good evening, good afternoon, good morning everyone. I hope everyone enjoying the event so far so good. This is the last block of the event we are going through. So by the way, myself Shahil Choksi, I'm from India, Ahmedabad. I'm a CEO of Bhide Technology, a software testing company in India. So now we are in the end of the block of the today's session. So the next speaker we have got is Andres Sacco. He's a technical leader at TravelX. So the topic he's going to cover is using a martial arts to do the test. So we have got the video recording for him. So if anyone has any questions or any doubts or any social media connections needed in the during the chat, just please type it in the chat box. We are having a dedicated Q&A sessions after three speakers after the end of the whole block. So please don't shy and ask the questions whatever you feel. And so now we are handing over to the recording sessions of the Andres Sacco. Thank you very much. Enjoy.
And welcome to this conference, and in particular to this talk about karate using a martial art to a test, which is so strange that we use martial art to do a test. Let me introduce me. My name is Andres Sacco. I work as developer since many years using different languages like Kotlin, Java, Scala, Node.js, Python, and many more. I participate as technical review on some editorials and publish some book and courses which appear at the top of the screen. And I participate as speaker on many conferences on Latin America. If you have any doubts at the end of this talk and you don't have time to do the correct question, please send me an email or contact with on my LinkedIn. I try to help you as soon as possible. So let me give more about the context of the situation. You need to find a way to create an end-to-end and an integration test, which you need to cover some specific things, not depend of one particular framework, because in the case that you use, for example, Quarkus, and for some reason the company decide move from SpringBoot, you need to rewrite all the integration test again, and you don't have any way to check if the changes of the framework continue working or not. So you spend a lot of time to check if everything looks fine or not. And that need to be used for other purposes, not just for integration. Could we use it as end-to-end, or also to run some performance test. Have a simple syntax that anyone can understand without any problems, and need to be simple to implement, because the main problem here is not need a lot of configuration, so strange or very, very complicated syntax. So the best approach to do is use BDD. BDD is a behavior-oriented strategy where put the focus on check the behavior of our feature or our class or something that we need to check, and provide more interaction between different people, business analysts, QA, developers, because you put the focus on the idea of the feature need to do or execute. It's a simple way to document and test. As I mentioned, if you write as a sentence the test, and that anyone can understand the meaning, it's simple that you can share with multiple people with different skills and different knowledge, and everyone understand the idea. It's not connected directly with the language. This is not connected with Java, with Spring, or with Kotlin. It's agnostic. It's a concept. And use some keywords like given, when, then. Which libraries implement this approach? JBehavior is one. Cucumber, which behind the scenes use Gherkin. Karate, which is like a brother of Cucumber, because both use Gherkin behind the scenes, code test, and Spock, which is possible to use on Scala, Java, and Kotlin. Why I need to use, or why I use Karate is agnostic to the framework and the language. In the case that you want to create an end-to-end test, it's not connected directly with Java. You can create some end-to-end in an application that use behind the scenes, Rust, Golang, Python, every that you want. And is not connected also with SpringBoot in any way. Allow to create a black box text. This is a concept where you can modify the internal behavior of the application. Is when, for example, when you create a JUnit test and you use Mockito or PowerMock or some kind of library that mock the interaction between the classes, you can modify the behavior and return something that you want. In this case, if you use Karate and in a correct way, it's like an agnostic. So I send a request and only check the response. I can modify nothing inside my API. And it's have a simple syntax and can be used for different types of tests. How is the syntax? It's not a joke, and really is the syntax. There are some keywords like the scenario, which represent more or less like a test, a method that checks something. And these are more or less the steps that you execute. This is the name of the scenario. And there are some keywords like given, this URL, and this request with this payload, do a post and check the results that return 201, and the response need to match with this. This is one part of the test, because as you see, there are more instruction. It's ideal when you want to check if the entire, for example, if the entire code works fine as a flow. You can create something, retrieve the information, delete or update, and check and everything works fine or not. As a suggestion, try to create different scenarios, each of them create a particular endpoint. But if you want create a complex scenario or reuse the output of some endpoint as an input for another one, this is the best approach. Let's see an example. I have a repository here, which contains more or less all the source code that you will see during this conference. Here is my IntelliJ. And the idea is I explain more or less the requirements and the version of Java, Maven, Docker, some documentation. And there are another things related with the tools and many other things, like future readings. And you have a Docker Compose file, which run an API, which need a database. The way to run this is Docker Compose app, which in my case I running here. So I go to my browser and I write the URL, which is localhost 67 Apple Flights catalog. All the URL is in the README file. Here is more or less my catalog. I have an endpoint, three different endpoints. One of them give me the information about a city. I send a code and give me all the information about this city, like the name of the city, which is the time zone, here, and the name, the continent, and many other details. And if you put some strange code which not exists, return an error, entity not found. And in the case that you want more information about this error, There are another endpoint errors which give the detail of this error. In this case, the city not exist on the catalog. And this application use behind the scenes SpringBoot. So you have the info endpoint and the health endpoint, which are part of the actuator. So the next step is to create a project which behind the scenes use Karate. In my case, let me show you in detail. I will use an archetype of Karate with this particular version, and I put the group ID and the artifact ID. This is like, okay, I will run, and this use behind the scenes Groovy. I will say everything is okay, just for the purpose of that work. And let me see, to explain everything more in a simple way, I will enter on the Karate application. So let me show you the POM file, because this is a Java application. And this particular used the Java version 8. You can upload this to 11 or 70. There is not restriction. And this is the particular version of Karate. And the unique dependencies that you need to use is the Karate JUnit file, because behind the scenes, Karate use or have compatibility with JUnit. And the other parts of the POM file are the same. This is the way to create an end-to-end test. You can reuse all the things that you will see and put on your inside on an API and create an integration test. There is not a restriction. You need to do some little modification, and you will find all the documentation about how you can do this on the official website of Karate. So here you have a loadback test file. There is nothing new. And here are, sorry, I will close everything. And here we have file which have the configuration. And there are some things that are relevant for us. Like here are all the configuration about the environment, which is the environment that I will use to run my test. In this case, there are two of them, dep and end-to-end. And here are another variables that you can use in many places of the test, and nothing more. And here you have a directory, which is the name of example. And let me show you everything. Let's start from here. Here are more or less the things that I mentioned in the presentation. And the way to define each particular test is like using the word key feature, where imply that all the tests that you declare in this file, in this user, that feature, are different scenarios or different tests of the same feature that I want to test. These are the background things that you will use at the beginning of the application or the execution of the test. This part are low on memory, and all the things that you will use on the different scenarios will reuse these variables. In this case, the path will concatenate this URL with this path and do a request to a GET request and return at 100. This is more or less the same image. And here are more or less the magic. So in this case, I have a class which say, okay, run or execute all the tests, all the features that exist in this particular folder. So if you have a lot of features, a lot of tests, you need to put inside of this folder, and this runner will detect everything here and execute all the tests. Of course, you can exclude or include one particular test. And after that, on one layer and another layer, there are an example test which say, okay, you need to execute all the runners that exist in this folder, call it examples. It's like you need to have two levels of execution. First one, the text execution, which iterate all the folders, find runners, and after that, each runner, in this case, the user runner, iterate or find all the features that exist in the user folder. This is not the best alternative when you have a lot of things, but okay. And the way to run this thing is simple, like an NVN test, which run our test. And in my case, I have one feature. And when everything is finished, at the end appear an HTML report, which if you do a click, you will see that, okay, I execute two different tests. Sorry, let me zoom in. Two different tests and take these times. And if you want to enter and check the instruction of each scenario, you can see the details and how many milliseconds takes to execute each instruction on this part. And you have a timeline, which takes some time to understand which of the scenario takes more time than another one. So everything looks fine in this level because our example. And the next thing is, okay, let's start to modify some little details. In my case, I will replace all this configuration. In my case, I replace and create a variable which have, or call it app in the URL of the base URL of the API, and which is the port and the URL or the host that my API is running. So this conf path concatenate this host with this path. And after that, I will create some directories. In my case, I will create first one, a directory that represents all the tests. Second, I will create a folder to enter for each particular thing that I want to check. In my case, I will check first one, the actuator, and after that, the feature of the city. And a good practice that I always recommend is create a particular folder for the request and another one for the response. Okay. Now, before to start to create my test, I need to create a class that iterates everything inside of my directory at this level. So I will create a class with the name API test. I don't want to include it. And I will put this part. So I say, okay, iterate all the directories that exist in the root inside and check and execute all the tests of karate, but just ignore or don't take in consideration the tests that have this annotation. The rest, you need to execute it. So let's do something simple. We have an actuator. The actuator always return the feature. Return always the information about if the application is held or not. I will start to create my feature with the held SpringBoot. And after that, this parameter is the parameter that I define here in the karate configuration, this one. And after that, okay, I will define a scenario which run a request with the held and nothing more. It's like check that return and 200. So to clean test, I will clean my previous test because perhaps show me some details of the previous execution, which is not the best alternative. So now I have the feature. Here are the instructions, and when execute this this method, the return is this body, which makes sense because the application is held. Now, let me show you a possible problem and why I create this request and response folder. There are two alternatives to check something. In my case, response, I will check the response is more or less, sorry, this one. And when I run this, everything looks fine because this is the correct answer. But imagine that you have a big JSON file which have a lot of things. This scenario is not the best alternative to. So, to clean this file or maintain clean in a simple way, you can export this part of the JSON to a file outside of this one. And I done that. This. There is a new file with the response. And after that, you can define a variable here on the background, which read the file because Karate offers some functions that solve some problems like read, write, and other things. And you can do this one and say, okay, the result of read the file and put on this variable, I will use to check. And to do this more interesting, I will do the same. No, show me again. Cancel. Sorry. I will do the same with my info. So let me run again, and then at the same time, I will show you something. The info endpoint have some content or part of the JSON which is dynamic because you have the information of the group ID, the artifact ID, and the version. The version is dynamic change at the same time that you change something on the POM file. So it's not a good alternative that you put you put a specific value like let me show you. Once that. At this point, if the version change, and this test will fail. So a good alternative is there are some specific annotation that you can include on Karate, like not null, is numeric, is alphanumeric, and whatever that you want. And you can create another ones. And in this case, this works like a wildcard. So I will check everything in this JSON, but when I detect this, I only check that the annotation say, okay, I will check that in this part exists a not null value. I'm not interested in check the real result. So I execute my test, and as you can see, okay, and I check with the variables. And the same with the info. Okay, there is nothing strange, everything works fine. Let's create more or less the same to the city. Okay, I put do more or less the same. I have the results. Sorry, package request. Here I have some files, the things that you check it. And when I show the Swagger. And after that, as a recommendation, I create two different scenarios. One to check if the city exists or not. So I pass a correct code and return a correct answer. And in the case of error, I put in another file. As a recommendation or suggestion, try to separate on different folders or different files all the different scenarios. the success scenarios in one file and the error in another one. It is a good way to organize the things, and you don't lose your mind trying to find the possible problems or where which test failed. I will execute again and everything. It's okay. So let me introduce quickly. Okay, you have all the cities, all the scenarios. Okay, let's do something more. This is the last thing. Imagine that you want to create some specific performance test. In the all times, you need to create some scenarios using JMeter or Kotlin, and you need to update every change that you do in your API inside of this scenario. So you need to have some kind of communication between the team that are in charge of the API and the team that create this scenario. And the same happened with the end-to-end. What happens if I say that there is a way to do it using Karate and Kotlin? I include Kotlin, the dependencies here. I also split on 2 different profiles my Karate scenarios in one profile, and I have another one which run the performance test. I need this dependency of Kotlin to use the same feature that exists in Karate, and many other things that appear on the official documentation to execute the scenarios using Scala, because Kotlin is created using behind the scenes Scala. So let me show one last thing to create something. I will create a file, which is a city simulation and Scala. Sorry, I forgot this, which is so important. And here, sorry. And after that, I will put all this code. And the city simulation extends, or all the simulation extends from simulation. I define which is the URL pattern that I will use or execute in my performance test, and which is the pattern that this tool needs to check to intercept all the traffic, all the requests, which is the name of the environment that Karate will use. Remember that in this Karate configuration, you define 2 different environments, one dev and another one end-to-end. Here is the scenario, or the name of the scenario that I want to check all the information about one city exists, and all the condition that I will execute, and there is in this feature in particular. So only say, okay, I want to execute a performance test using this feature. And what are the conditions? Okay, I will run this test using 10 different users during 20 seconds. So I will execute at least 10 times this scenario and check the results. Here are my assertions. I will check that more or less the 50% of my requests need to have a response time lower than 1 second. All these percentile that you can override using the different annotation that exists in the official documentation of the Kotlin. And to run this is the way to execute it is, okay, verify -p is Kotlin, sorry, because I override and create 2 different profiles, one for Kotlin and another one for the Karate scenarios. So if you have a pipeline, you can have 2 different steps, one to run the end-to-end test and another one to execute the performance test. This will take some more or less 20 seconds to execute everything here. And after that everything finished, you will have more or less a lot of information. This is finished, and more or less all my results about the execution of this performance test. Everything worked fine, more or less the distribution, and here are my assertions. You can include this information using another tools in a pipeline. There are plugins that you can use to put all these results in a human readable way with Jenkins. And there is all for the example. And let me show you quickly the last part, the best practices. Try to use wildcard to random values, not include JSON on the feature inside each of the tests. Have different profile to end-to-end and the performance. Define a structure for each test. Reuse the scenarios. You can include different dot features in another one. It's at the same way that you run read the JSON. Create function like read to do something in particular. Here are some additional books related with BDD or test and some other blocks. And this is all for me. If you have any question, please, I will show you or answer all your questions on the QA at the end of all the talks.
Thank you very much, Andres. I think it was a marvelous talk. I hope everyone enjoy it. So please, if anyone has any questions, please type it in the Q&A box right now. And we are having the Q&A sessions at the end of the another two speakers. So thank you very much, Andres. I hope everyone enjoyed and you did the great job in explaining the presentation and the demonstration. Thank you very much. The next speaker we have got is James Ward. He's a Kotlin product manager at Google. The topic he is going to cover is Spring plus Kotlin equal modern plus reactive plus productive. So just a second. We have got the recording for him as well. So let's get started. Thank you.
James Ward, a Kotlin product manager at Google. This talk is on Spring plus Kotlin equals modern plus reactive plus productive. And I'm going to be walking through how to combine these technologies, and we'll throw in some test containers as well. So let's just dive in. I'm going to go to start.spring.io and create a new project. We're going to use Gradle Kotlin build and the Kotlin language. And then I need to add some dependencies. So we're going to be using reactive stuff. So I'm going to add the Spring Reactive Web. And then let's also add in the Spring Data R2DBC for reactive database access. I'm going to be using Postgres as my database. So we'll add in the drivers for that. And then test containers. So let's generate our project and we get my zip file. Let's go open that thing up in IntelliJ. So here I'll extract that zip file out and then go open this thing up. Okay, so this is going to take a second to import into IntelliJ, but let's go take a look at some dependencies here. So obviously we have Spring as a dependency, we have Kotlin pulled in, and then we've got our dependencies on the SpringBoot R2DBC. So that's going to be how we reactively access our database. We've got the SpringBoot WebFlux for reactive web, and then we've got some Kotlin stuff in here for being able to use Kotlin and coroutines efficiently. We'll get into that in a minute. And then our test containers, Postgres. So there we go. There's our dependencies that we need set up. Let's go actually start writing some code. So here in our source, we've got our demo application. And for this particular application, let's start with the database access piece. To be able to talk to the database, we need to set up a few things here. So first, let's go over to our application properties and set up a few things in here. So I'm going to say that our Spring SQL.init, and then the mode, we're going to say always. So we're always going to initialize our database schema there. And then let's set up some connection information. So I'm going to do this with Spring and then my R2DBC. And there's a few things we need to set up on here on the R2DBC. So one is the URL. For the URL, I'm going to say that this is going to be R2DBC. and then it's going to use this :tc. That's going to use test containers. We'll talk about that in a minute. Then PostgreSQL. And then I'm going to say, let's connect to a database called customers. And then I need to put a special thing in here to tell it which version of the Postgres Docker container to use. So I'm going to say tc image tag, and then this is the tag that I want to point to in my Docker container, in the Postgres Docker container. So I'm going to use the 9.6.8 version of that. Okay, then we need to do a couple more settings here. So the next one is going to be what is my password. I'm going to leave that blank, and then we're also going to set the username to be blank as well. Okay, and that'll just get everything all connected. So there we go, we've got our application properties. Now let's go and create some, let's go write some code that we're going to use for persistence. So first thing, when I'm going to do persistence, I need something to persist into my database. And in Kotlin, I'm going to use something called a data class. So my data class is like a POJO. It allows me to define something. It's going to be a customer. And then I can set some properties here on this data class. So I'm going to have an ID that's going to be an int, but my ID, we are going to take advantage of a nice feature in Kotlin, which is explicit nullability, where before we actually save a customer into the database, the ID is null, and so we put a question mark after the type. Okay, now a few other things in our data class. One, we need to make this a val. The val is an immutable property, so we get immutability on the data class there. And then I'm going to annotate this thing with being @id to tell Spring that this is the primary key. Okay, and then for my next property here in my data class customer, I'm going to do another val, and it's going to be a name, so the name of the customer, and that's going to be a string, but this one is going to be non-nullable. And so then let's say we wanted to create an instance of our customer. We could just say customer, and then this first property, we could give it a value, and then the name, we could give another value, but the first property could also be null, so we could say null there, but we can't say null on my name property because that one is non-nullable, so that would be a compiler. So that's how we could use that customer class directly. Okay, so now that we have our customer data class to work with, we need to be able to talk to our database. To do this, I'm going to define an interface that is going to be called my customer repo. And this customer repo is going to extend something that's built into Spring and RTDBC support there, which is going to be the coroutine CRUD repository. And the coroutine CRUD repository is going to use Kotlin coroutines to be able to talk to the database. And we need to give it some type parameters here. So my first type parameter is going to be the type that I want to persist. And then the second parameter is going to be my primary key type, which is my int. Okay, so now I've got my customer repo, and that's all I need to define on that. That provides my database access. And then now that we've got our customer data class defined, we've got our repo, we do need to define the table, how to create the table here. So I'm going to come in to my resources directory, and I'm going to create a new file that's going to be schema.sql, and this is just a SQL file. So let's create a table called customer, and customer is going to have an ID, which is going to be serial, so sequentially increasing, and then this is going to be my primary key. And then I'm also going to have my property name, and we'll make this of type text, and we're going to say it's not null. Okay, so there we go. We've got our customer table ready to store our data. So, okay, we've got all the pieces in place now for our reactive database access. I think that probably the best thing to do for this is to write a test so that we can verify that this all works. So I'm going to come in here to our Spring Boot test, and I need to be able to inject into my test class my repository. So let's come in here and we're going to say, all right, we're going to auto wire in a val, which is going to be my customer repository. And now I can just say customer repo there. And now I'll be able to use my customer repo. Now let's name our test something a little better here. We'll just say CR works. And then I'm going to define my my actual test. So for my test, let's just do some really basic database access here, where I'm going to use my customer repository, and I'm going to save a new customer. And remember how we could set that ID to null, since it's not going, when we first create it, before it gets persisted, it's not going to have an ID, but let's save that. And now we're starting to see some coroutine stuff come out. So coroutines are a way to do async structured concurrency in Kotlin. And when I try to call cr.save, it's saying, hey, you know what? You are trying to do something that is in this async coroutine land, and I need it needs to know kind of a context for being able to do this coroutine stuff. Because I'm in a test here, I actually want my test to be blocking. So I want, it wouldn't make sense for a test to be non-blocking. There's, so I need to do something. I'm going to say, all right, my function here, CR works. It's going to be in this run blocking scope. And this defines kind of the context for that my coroutines are going to execute in. So now when I call cr.save, I could, if I want to, assign this. So I could get my customer out from the save call. This save call is a non-blocking call, but by the time that we get this value C set, we will have gone off to the database, made my save, and used non-blocking IO, and then the execution of this particular method will be relinquished, won't be, it's a coroutine, so it'll be async. And then when we actually set this value, we will have kind of resumed operation here. So Kotlin's doing a bunch of stuff under the covers with R2DBC in this case to be non-blocking. But because we're in a test in this case, we're actually wrapping this all into a particular blocking context. Okay, so I now have my customer, and it should be saved into the database. Now let's do some assertions on this thing. So let's go to our assertions library here, and let's do an assert. Let's see, let's do an assert true, and I'm going to say that c .id is not equal to null. Okay. And I think there's actually an assert not null might be a better way to do that. So let's assert that our ID is in fact not null. Okay, let's just run this test and see if this is all actually going to work here. So let's run it. And when I'm running this, we remember in our application properties, we set the connection URL here to use test containers. So what's actually happening underneath the covers when we run our test is that when we try to connect to this database through that connection string, test containers is going to say, oh, I need to go spin up a Docker container with the Postgres database and provide that connection information to that Postgres database to Spring, and so that Spring knows where to connect to. And that all happens underneath the covers for us through test containers. But one of the cool things that I'm taking advantage of here is that I don't actually even have a local Docker daemon running. I'm using something called test containers cloud, which is actually running my Docker container for my Postgres database actually up in the cloud. Okay, so it looks like that all ran and worked. That spun up. We can scroll through the output here and see that sure enough, it used test containers cloud for my Docker container, spun up that Postgres database, ran my test, my assertion passed, and now I'm good. So let's just go a little bit further with this. Let's now go and get our customers out of our database. So let's now call cr.findAll. FindAll uses another coroutine concept called a flow, which is a stream. And so that flow in Kotlin is also using coroutines underneath the covers. But now let's do another assertion here. Let's do an assert true. And let's say that my customers dot count is what I want here. Equals 1. And you'll see this count. This is using another feature of Kotlin, which is called extension functions. So flow, if I want to be able to do a count on a flow, I actually have to import the extension function on flow that gives me that count function. So it's not in the base flow class, it's provided as an extension on flow. Okay, let's rerun our test now and make sure that our test still passes, that we were able to find our customer that we added to the database, and that we should have now one customer in the database. By default, test containers will run in a scope not shared, and so it's going to reinitialize that container every time we run our test. But you can configure container reuse and some other things there. But there we go, our test works. So great, we are now talking reactively to a Postgres database that is being spun up and managed by test containers, and using Kotlin coroutines as our way to handle the async pieces of that. So great, our database access, reactive database access is all working. Now let's go on to the next step, where we actually want to expose this database out as a REST endpoint for our application. So to do this, we're going to add in some additional stuff here in our application, our Spring application. Before I do that, I do actually need to make one change to my build. So I'm going to be using the test container stuff when I do my boot run to run my application, but you'll see that the test container stuff is in this test implementation scope. So there's a little trick that I can use here in my build, where I'm going to say tasks with type, and then I'm going to get the boot run. Let's see if it can find it here. Yep, the boot run type, and then I'm going to set my class path in my boot run task to be equal to my source sets, and I'm going to get my test source set and get the runtime class path from this. And this is just going to make it so when I do my boot run, it's going to have my test container stuff available in the class path. Okay, so that should all be good there for that piece. Now let's come in and start building our actual REST application. So in my demo application class, let's come in here, and I'm going to add a bean. So this is a Spring bean. And I'm going to create a function. This is just going to be my HTTP handler. It's going to take a parameter here, which is going to be my customer repository. So that'll get injected in here. And then let's come in and actually, let's not do a block. Let's come in here and create something called a co-router. So this is some nice stuff that Spring has for being able to use coroutines and some Kotlin features to define our routing for our Spring application. You can use the traditional Spring annotations for like get mapping and post mapping and that sort of thing if you want to. But I like this co-router API when I'm working with Kotlin. It's just feels a little more Kotlin, taking advantage of some Kotlin stuff. So now in my co-router, what I'm going to do is I'm going to to add a handler. So I'm going to say, all right, when we get a GET request to /customers, then I'm going to do something. And let's just start with something basic here. I'm going to create a server response. And I'm going to say okay, and then let's I don't know, let's give it a body. I think we can give it a body value and await here, and let's say hello world, and let's just see if this thing is going to actually work. So to run this, I need to come into my Gradle tasks and run my boot run task, because that's the one that has the right class path on it. So let's see if this thing is actually going to work here. I do have some ways to make my HTTP requests to my application, but we'll let this application get all booted up. And you'll see that because I am connecting to my test containers Postgres database, it is spinning that up, and even though I'm not using it yet. Okay, so I think my application is up and running. Let's make our GET request to /customers, and sure enough, we see that hello world was what we returned there. So that was good. That's what we expected. Let's go and do a little more here on our co-router. So in our co-router, I'm right now doing this server response, a 200 response, okay, and then I'm doing body value and await. So if we look at body value and await, this is a, you can see it up here, a suspend function. So that's a function that uses coroutines and is suspendable. And right now, I don't really have anything reactive, anything non-blocking in here. But one of the cool things that we can do is we could come in, just as an example, and I can put a delay in here. Let's put a 2-second delay in our body that is going to be called when there's a GET request to /customers. So we're going to wait for 2 seconds, and then we're going to return our server response with the body value and await and hello world. Let's go start up our server again here, and we'll test this and make sure that this is actually going to work. So I'll take a second to get that up and running, and let's go here in our browser let's open this inspector panel and the network inspector. All right, so we can see how long this request actually takes. So let's go to our local host 8080 customers. And you'll see that there we go. Our request returned a 200 response, said hello world. But here's the cool thing, is that it took 2.21 seconds. There's probably just a little bit of initialization time here. If we do it one more time, it should be a little closer to 2 seconds. There we go. So here's the cool thing with the reactive underneath the covers, is that request comes in from the browser. We hit this delay, and because that's a suspend function, we actually take the thread that is allocated at this moment to handling this HTTP request, we deallocate it from this request so that it can be used to do other things. And then after the 2-second delay, then we come into this next part, which is doing the server response and returning the body value and await. So that all is reactive and great, most efficient way that we could use our resources on our system. But doing a delay is silly. We likely wouldn't do a delay in a real application. So now we get to the point where we can connect our web application up to our reactive coroutine CRUD repository database access. And now we have something to not block on. We don't need our delay anymore. What we're actually going to do is go get our customers from our database. So what we're going to do is replace this body value and await with something called body and await. Body and await allows us to return not a value, but a stream of objects. And so that's an extension function here. Now what we're going to do is we're going to make our find all customer request flows, so our reactive request to the database to get our customers, and the body and await will link together the reactive database call, which is the efficient utilization of threads asking for data from our database, with our HTTP handler. And so when the request comes in, we're going to fire off the request to the database, but when we're just waiting on the database to respond, the thread that is talking to the database and the thread that is handling the HTTP request, both of those get released and can be used for other stuff. Then when we get the data back from the database, then we resume those threads and return the data. So let's go try this thing out. Let's restart our application and just make sure that this get customers is going to work. We won't have any data in our database yet. But that's okay. We'll just make sure that the handler is going to actually return a response. So let's go back here, make our GET request to /customers, and we see, sure enough, we get an empty array in our response there. Great. So that is seems to be working as expected. And it is reactive from the HTTP request all the way down to the database, and using coroutines in Kotlin to handle that async and streaming pieces. Okay, so the next thing I want to put into my router is a post handler. My post handler, also for /customers, what we're going to do in our post handler is we're going to have a function that takes a request, and then we need to be able to get our customer that has been passed into the post request out. So to do that, we can say request, and then we're going to get the body from body. Let's see, there's a function on here to get the body await body. Let's actually do await body or null. So then we need to tell it what we're deserializing into. We're deserializing a customer, and this await body or null. So that's again a reactive parsing of the request body. And then or null, this is nullable, so we're taking advantage of Kotlin's nullability. So what we need to do is we need to say, all right, in the case that you were able to actually parse a customer out and it's not null, we are going to chain some logic onto that non-null case, and we do that with a question mark. And then I can do a little function here called let, and let allows me to say, all right, when that customer is not null, here's the logic that's going to be executed. So what I want to do is I want to take my customer, which is I can access through this little keyword it. I could also put a function parameter there if I want, but I want to take my customer and I want to save it into the database. So I'm going to say my customer repository, now save it, which is my customer, and that is a non-blocking reactive call. But once that customer has been saved, now let's return our server response. And I'm going to say a typical REST-ism here is to just return no content, and then we're going to say, all right, let's build and await that. I think it's build and await. Let's make sure. Let's check out. Yeah, I think build and await is our way to assemble that server response and return it. So that handles the non-null case, but I do need to, so that I am correctly dealing with nullability, I do need to provide the case when that customer was null. And so there's something in Kotlin called the Elvis operator, because if you turn your head, it looks like Elvis. And what I can do is provide the default case. So when I wasn't able to parse a customer, let's return a server response, and I'm going to say bad request, and then I'm going to do a, let's see, build and await on that one. And great, now everything's happy. I've now got non-blocking post request to /customers that parses out the customer. If for some reason it can't parse it, then we return a bad request. If it could, we save it into the database and then return our no content response. And I could clean this up and add better kind of error messages and all that kind of stuff with some more time. But hopefully you see what's going on here, and you'll see all the chaining of coroutines. IntelliJ indicates everything that was a non-blocking coroutine where we can relieve the use of the thread while we're waiting on something to respond, and then resume when we have it. So all that kind of non-blocking chaining happening here. Okay, let's go restart our server here, and let's see if this is all going to work. Be able to create our customer in our database and then get it back out. All right, let's open up our HTTP requests. So first, let's go make our post request to /customers, and it's a application JSON, and it just has the name. We're not setting the ID, obviously. So let's make that request, and we see a response, no content. That's good. That means that the save should have succeeded. Now let's go get our customers, and then sure enough, we see our response here that we get back is our list of customers, and I have my customer James. So that all kind of worked as expected. We can come in and add one here for Karen, rerun this one, make sure that that all works. We should see again the request no content, and if we make our get customer request, then see we get our list of customers with our second one. Great, so that's all working as expected and is async and non-blocking and reactive all the way down through to the database using Kotlin coroutines as the async way to do something that is a request response essentially. And then the flow, which is the ability to do a stream, which is what the find all returns. Okay, so all of that worked. We were able to combine together Kotlin with Spring and with reactive database access and with test containers for being able to manage our database resource underneath the covers with Test Containers Cloud for where those actually ran. Of course, you can run those in a local Docker container as well. And that's it. So hopefully that was a good kind of quick run through of how to use all that stuff together and take advantage of some of the great things in Kotlin and in Spring together. And you can see how nice.
Hey, thank you very much, James. I hope everyone enjoyed the James talk and the presentations. So please give a big hand to James. So he has done a great job in explaining the presentation and the demonstrations. So if anyone has any questions, please type it in the chat box right now. We are having the dedicated Q&A sessions after one more speaker. So let's have the next speaker, which is the last speaker of the today's entire session of the event. So the next speaker we have got is Maithili Bhide. She is a machine learning engineer at Zillow Group. So the topic she is going to cover is JMH Microbenchmarking, benefits of benchmarking. So let me introduce her on the stage.
Hello everyone, my name is Maithili, and today I will be talking about JMH Microbenchmarking for Java applications and highlighting some of the benefits of benchmarking. We will go over two different ways of setting up microbenchmarks using the Java Microbenchmark Harness or JMH and see a demo of a situation you might encounter in your day-to-day job where benchmarking proves invaluable. We will conclude this presentation by discussing some common pitfalls while setting up Java benchmarks. If you have any questions, please hold on to them and ask me during the Q&A session. Now let's dive in and understand what is a microbenchmark. Large programs or software systems that are designed to solve specific problems, such as routing app drivers from point A to point B, or matching delivery drivers with customers for order fulfillment, are comprised of many small components and operations. These small operations or subroutines work together to achieve the end goal of a software system or product. A micro-benchmark is a way of measuring and creating a reference point for the performance of small but critical operations in larger software applications. Here are some scenarios where a micro-benchmark can be useful. The first one talks about comparing two different approaches to concatenate strings in Java. String Builder is a simple and widely known functionality for string concatenation in Java. A micro-benchmark that compares String Builder with the regular string concatenation gives us a quantifiable way of measuring the exact benefit of the String Builder class. Consider an application that relies on users searching for terms within an app. String search is a critical component here, and the performance can be benchmarked to prevent deterioration of user experience. JMH, or the Java Micro-Benchmark Harness, is a way for building, running, and analyzing such benchmarks for applications written in Java and other JVM-based languages. Now that we know what a micro-benchmark is, let's discuss what can be measured using the Java Micro-Benchmark Harness. The four main characteristics that we can measure are throughput, average time, sample time, and single shot time. Throughput measures the number of operations of a specific type that can be performed per unit of time. For example, operations per second. Average time is essentially the inverse of throughput and gives us the average of the time required for performing each operation. Sample time randomly samples the time required for each operation and gives us a percentile-based view of the time for each operation. Single shot time measures the cold performance of a system, that is, performance without any warm-up invocations. The JVM needs the warm-up period because Java has lazy class loading and just-in-time compilations. Typically, we care more about the performance after warm-up and will not measure single shot time. These are some of the key parameters that we can tune while setting up a JMH micro benchmark. We will see examples where we specify parameters such as the warm-up time, iterations, forks, time unit, and the various modes of JMH benchmarks in subsequent slides. More details about each of these modes can be found in the JMH documentation. In the next few slides, we will see two different ways of setting up JMH benchmarks. The first method describes a mechanism for setting up an ad hoc benchmark, and the second one describes how to integrate JMH and JUnit so that we can have automatically triggered benchmarks in CI/CD pipelines. This first example demonstrates a way to set up an ad hoc JMH benchmark. This is useful if you want to perform a one-time analysis or comparison between two different methods and pick the best one, or to understand the performance of a method when called multiple times. This particular example involves a benchmark for a string murmur 128 hasher called over 100, 200, 300, or 1000 iterations. We want to measure the performance across the different iterations and will focus on the throughput mode for our benchmark. Note the tunable parameters for fork value, warm-up iterations, measurement iterations, and JMH mode. The main method serves as the entry point for this ad hoc benchmark. From the results, we can see that an increase in the number of iterations causes a proportionate decrease in the throughput of our murmur 128 hasher function. If we recall, throughput gives us the number of operations of a specific type that can be performed per unit of time. In this case, the operation is calling murmur 128 hasher n times, where n equals the number of iterations. Here, we see that a 3x increase in the iterations causes a proportionate approximately 2.99x decrease in the throughput, and the same is true for the 10x increase in iteration count. Intuitively, the results make sense, since increasing the unit of work, that is iterations, has an inverse effect on the number of operations that can be performed per unit of time, that is 1 second. The JMH benchmark gives us a quantifiable measure of this relationship, and we can use it to establish contracts around the murmur128 hasher function that can be shared with consumers of this hashing function. In this second example, we will see an integration between JMH and JUnit. JUnit is a commonly used unit testing framework in Java. JUnit tests can be integrated in CI/CD pipelines so that code changes are automatically tested before being deployed to production through the pipeline. Integrating JMH with JUnit is a great way to catch regressions in performance of critical components of a software system and to record the performance of the system against specific code commits. The example on the right demonstrates the use of a JUnit test for benchmarking two different string concatenation methods using the JMH options builder class. Note the tunable parameters for garbage collection, fork value, warm-up, measurement iterations, and JMH mode are used here. This JUnit test can be integrated in the CI/CD pipeline. From the results, we can clearly see the benefits of using the string builder class for concatenation. While this example is just an illustration of integrating JUnit and JMH, in the real world, we might have a JUnit JMH combination test that ensures the performance of an operation doesn't deteriorate beyond a certain threshold. For example, if you have a critical function for string search and need to ensure that the performance of this critical search function stays less than or equal to 200 milliseconds, you can add a unit test that will fail if the JMH benchmark reports an average time greater than 200 milliseconds and alert the developers. Gating changes with JMH JUnit tests will prevent deterioration of the user experience, since these bad changes will not get deployed through the CI/CD pipeline. Now, let's look at a scenario that you might encounter in your jobs and see how benchmarking can help us. In this example, we have a very simple service that processes user information, transmits it in the Avro format, and serializes it. The service endpoint is callable on localhost, and the user information is serialized to a Kafka topic when it's received, and then deserialized and read from the same topic. For the purpose of this demo, we only care about the Avro format of the transmitted user information and the time spent and throughput while serializing this user information. Let's make an example request to our endpoint that passes in a fictional user, Sherlock Holmes, to our backend service, which then serializes this information, that is, writes it out to a Kafka topic. Here, I'm making a post request to the REST endpoint of the service on my local host for transmitting user information. The request was successful. Now let's look at the application logs for this request. We can see from the logs that our user information request got serialized to bytes and the message was written to the Kafka topic. This serialized data was then deserialized and read back by the Kafka Avro message consumer. Now let's send in a second request, Dr. John Watson, to our backend service. As we can see here, our user info is currently very basic and only includes the first name, last name, and age. Let's look at the Avro schema that is currently being used for this user information. Here is the Avro generated code, which defines the user class from the Avro schema that we just saw. This will be used in our JMH benchmark tests. Now imagine that the product team wants to enhance our product with some region-specific information. Software engineers will then be asked to enrich this user info with the user's geographical information. User location data comprises of details such as the street address, state or province, the zip code, and the country. Adding all these fields to our Avro user info schema will increase the size of the payload. We might worry about increasing the overall time required for serializing this new user information, which contains geographical information. An alternative could be leveraging plus codes or hash codes that map specific geographical locations to the long-form address. If our product teams or data scientists want to filter users by location or target specific geographies, plus codes can certainly be used, and additional details about the user's long-form address can also be inferred from plus codes. This will make our payload size smaller than the previous instance where we were using long-form addresses. Now let's look at the two modified schemas with geographical information. In this first instance, we see that the schema with the long-form address adds several fields like street, city, state or province, country to the original user info schema. In comparison, the schema with the plus codes only adds one additional field, that is the plus code. A JMH benchmark can be used to clearly measure the performance benefit of this change. Let us now look at a pre-written JMH benchmark test for checking user information serialization with the two different schema representations of geographical information. Here, we see a benchmark for average serialization of a fictional user named Sherlock Holmes with the address 221B Baker Street, London, England, United Kingdom, and the corresponding plus code GRFR plus GH. As we can see here, the plus code only takes up 7 characters. This benchmark measures the throughput, average time, and sample time for serializing data, which matches the two different average schemas, one with the long-form address and the other with the plus codes. The output of the benchmark will be measured in milliseconds. We have 5 warm-up and 5 measurement iterations running with garbage collection. The JUnit test serves as an entry point for our benchmark and can be integrated in a CI/CD pipeline. Now let's run the JMH benchmark test to compare the performance of serializing these two different average schemas with the user's geographical information. As we can see here, the test suite has started. In order to save some time, let's look at the results from a previous run. Here, we see the readings from the 5 warm-up iterations and the 5 measurement iterations. The final benchmark results will only consider the measurement iterations. We can see that the JMH benchmark tests have run on both the serialization functions, that is, the one with the optimized schema and the long-form schema, and they have measured all the throughput, all the modes that we specified, like throughput, average time, and sample time. The final results are displayed all the way at the end of the test output. As expected, we can see that the schema with the plus code representation for the user's geographical information performs better during serialization. We can clearly see that the throughput for serialization with the optimized schema using plus codes is higher than the throughput for the long-form schema, and the average time is similarly lower for the optimized schema. we can see the percentile-based breakdown of the sample time results for both the serialization methods, and we can verify that the total count of the samples viewed for the optimized schema is higher. This is a clear quantification of the results that we expected. While we looked at a hypothetical scenario where our service just dealt with the serialization of two fictional users, Sherlock Holmes and Dr. Watson, in the real world, this might be a small component of a larger software system. If the system has very high data volume, or if serialization is a critical bottleneck for downstream consumers of the service, the Avro schema changes for geographical information and serialization considerations can have a large impact on the overall service level agreements. Being able to measure the impact will allow developers to make appropriate choices. While the test results clearly indicate that plus codes perform better than long-form addresses, whether we should use them or not is a separate consideration. This makes for a very good segue into our next section, which talks about the pitfalls and considerations while making trade-offs related to the performance of microbenchmarks. While microbenchmarking is very advantageous in certain scenarios, there are some common pitfalls that we should be aware of. This section draws our attention to them. Don't let these pitfalls dissuade you from benchmarking your Java applications, but knowing they exist will help you in being alert and avoiding them in your use cases. Donald Knuth is a very famous computer scientist, and I think his quote about optimization is very appropriate in the context of microbenchmarks. He says, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet, we should not pass up our opportunities in that critical 3%. Microbenchmarking, if used correctly, is a tool that will help us squeeze out performance optimizations in the 3% scenarios. This slide highlights some of the considerations while setting up JMH benchmarks. This is not an exhaustive list of all the things to remember, but highlights the most important pitfalls. From our demo, we can recall that we saw the performance of two different Avro schemas across the throughput, average time, and sample time JMH modes. The serialization method using the Avro schema with plus codes performed better than the one using the long-form addresses across all modes and iterations of the benchmarks. Now imagine a situation where our application or service only has a few hundred users and is not very large scale, or a situation where we don't really care about the latency of serialization and data freshness of user info. Should we invest in the optimized schema for saving a few milliseconds here? In such a situation, investing in the optimized Avro format that uses plus codes does not make sense because we are giving ourselves the additional overhead of tracking the mapping from plus codes to long-form addresses. For this application, we are not operating within latency constraints for serialization, so this is not a factor we should be worried about right now. This is a premature optimization that should be avoided. Loop optimizations. Tunable parameters in JMH, such as measurement iterations and warm-up iterations, should be used to run the benchmark more times for additional readings instead of wrapping the benchmark code in a script that runs a loop. This is an important consideration in the case of ad hoc benchmarks, where developers might feel the need to run the same benchmark code in a loop to get multiple readings. Java uses a just-in-time compiler, and the JVM also performs several optimizations, such as dead code removal and saving the values of frequently used and computed constants. When writing JMH benchmarks with constants and frequently recomputed values, it's imperative to remember that these optimizations may get applied to the micro benchmark, but may not necessarily be applied to your production code. The first request made to a Java application is often substantially slower than the average response time during the lifetime of the process. The JVM has a warm-up period due to the just-in-time compiler and lazy class loading. JVM warm-up is a necessary step for measuring accurate benchmarks. It is recommended practice to leverage warm-up iterations in JMH before the actual measurement iterations in order to ensure consistency in benchmark results for a method. We must always remember the end goal or the main point of our optimization efforts. Losing sight of the big picture may land us in situations where we are making optimizations that have unintended consequences on the overall system. As we conclude today's discussion about JMH benchmarking, let's remember that even though there are a few pitfalls to consider while benchmarking Java applications, there are also several benefits to having timely measurements of application performance and micro-benchmarking critical components. These are some reference documents for understanding the Java micro-benchmark harness and how to use it for some of the examples that we went over today. My intention in highlighting these here is to call out that there are rich resources, official documents, and blog posts available around the JMH setup and usage. Hopefully, this will make it easy for you to get started on your benchmarking journey. Thank you everyone for attending this presentation today. I hope you found it useful. Please feel free to reach out to me via
Thank you very much, Maithili. It was a wonderful talk. I hope everyone enjoyed it. So if anyone has any questions, please type it in the
email
Q&A
or on
box.
LinkedIn if you have further questions or comments.
Okay, sorry to interrupt. Thank you very much, Maithili. I think everyone enjoyed. So if anyone has any questions, so we are having a Q&A sessions right now. So please don't be shy to write the questions. We are giving you enough time to type the questions. If you are any thoughts or any comments, anything you want to know, please type it right now. So thank you very much, Maithili. You did a great job. So I'm inviting now all the speakers on the stage. So in the meantime, please guys type the questions in the chat box so we can have the Q&A session thoroughly. Okay, and we have got James. He's not online at the moment. Hello, Maithili and Andres. How are you doing?
Hi, how are you?
I am very well, thank you. So I think people are typing the questions in a chat box, and we have a couple of questions at the moment. So just a second. I think, is it James joining? Okay, we have questions coming up. Okay. So the Andres, the question for you. Karate and Cucumber seems be similar. Why should we use Karate over Cucumber?
Great question, because there are a lot of similarities, and behind the scenes is use Gherkin to write the test. But the main difference that is you can create a test with Karate outside of your application. In fact, my example is not connected in any way with my microservices, and have a good way to write. Imagine that you can share your test with anyone, business analyst, PMs, I don't know, anyone that more or less can write or understand a sentence can use Karate. And Karate have integration with many other features like Kotlin or Selenium, many of them, and in a native way. And there is a lot of difference with Cucumber because there are not these kind of integrations. So you can reuse your test to do a lot of things, not just create an integration test or something like that.
Okay, I hope everyone got the answer for that. The next one is got for Maithili. How to determine what's among the top 3% critical optimization is the most used features using by the final user, the best indicator for that?
Hi, everyone. So I think for the top 3% critical optimizations, they will differ by your application and by what your service is trying to achieve. So in my opinion, I think gathering data around the usage of your service and gathering data around your latency numbers will help you understand what the bottlenecks are. And then you can decide by prioritizing with the rest of the team what your most important efforts should be for optimization.
Okay, I hope everyone got the answer. So the couple of questions regarding the testing, you talking about entries. So is there any possibility that we can run the test in parallel in the Karate?
You can run in parallel to optimize the time that expend the application to run all the tests. As a suggestion, the idea is reuse the test to create some kind of low performance test, try to not run in parallel because you spend more resources of your machine. Imagine that you have two different scenarios. And one thing that you need to consider, if you run in parallel some scenarios, take in consideration that if modify in some way the database or an external resource could be a problem. For that reason, try to run sequentially. There are a lot of constraints. You need to think in the trade-off of each alternative. It's not so simple. But one thing that I don't mention during the talk, try to use simulation to your external connection. Imagine that you create an integration test or component test using Karate, and you run in the same source code your application and run the Karate test. Try to use WireMock or Docker or something like that to simulate the external connections and the database, because you don't need to use a real database, because the idea is that your tests are idempotent, so I can run many times without modify anything.
Yeah, because generally I have used Cucumber, so I know the step definitions and feature files and hooks and all. So do they have hooks like before class, after class, everything in Karate as well?
Yeah,
like before suit, before class, before method. So is it something there as well?
Yeah, there are a lot of similarities. In fact, if you want, you can run the integration test or the Karate test in a manually way, specifying all the tests and before and after method. It's like a JUnit 5, and you can specify in the same way. But as a suggestion of Karate and integration test or component, try to do in a way that is agnostic to the behavior of the application. So run your application, execute your test, and download the application, and everything needs to work.
So
it's the idea of black box test. Like I don't need to modify anything in the environment of the application.
Okay, so in Cucumber we write the feature files and we run the features file, so it will create the empty steps, right? And null blank skeleton of the feature steps into the console. So that's the first way. If you don't want to do that, there is a plugin called Chrome add-on called Tiny Plugin, Tiny Gherkin. It will create the step definition for you. So if you don't want to run generally in Cucumber, you have to run the program, then it will create the step definitions for the feature files. So if you don't want to do that, you have to use add-on, Chrome add-on, which is Tidy Gherkin. And so yeah, so it will create the step definition skeleton for you. So is there something similar in karate as well?
I'm sure. There are a lot of features inside of karate. There are a lot of models. In fact, in the talk, I think I told just less than 5% of all the models that exist.
It's okay.
You can do a lot of things like create functions or reuse the scenarios in another way. Insert things in the database using, I don't know, risk hat outside of the application if you don't want to, in the Docker database, not the real database. And you can do everything. I'm not sure, I don't check with Cucumber and Karate if it's possible or not.
And I think last two questions. The plugin I use is IntelliJ for Cucumber, and there's another one I use as well for Eclipse. So which plugin do you, IDE, not plugin but IDE, sorry, would you recommend for Karate?
Good question. I use both Eclipse and IntelliJ, but some years ago I migrated to IntelliJ because I develop on Kotlin. But according to the last survey in some of the official sites, most of the developers now using IntelliJ, and the stability of the plugin of Karate or the Cucumber is more stable in IntelliJ. In Eclipse, spend more resources. I don't know why there is some bug or something like that consume a lot of resources when you try to open a file and try to highlight the keywords. Spend a lot of resources. I don't know why, because I use the latest version of Eclipse and the latest version of the plugin. So as a recommendation, use the IntelliJ with the feature with the plugin. Everything works fine, open so quickly, and see. For me, it's okay.
I have one more question for you, but I'll come back to you in 1 minute. Question for Maithili. You are a machine learning expert and got the knowledge as well. So what do you think the future of machine learning and AI? I think everyone is talking about AI, so future is great, but I'm talking about like the chat GPT is here, and there are so many other tools coming up as well. So what do you see? Are they really going into the deep dive of the ML, AL, ML, or it will be something like flicking around and then settle down? What will be in next 5 to 10 years?
I think that's a very loaded question. I don't know if I can comment on where the industry will go 5 to 10 years from now. In terms of machine learning engineering, I think most of my work has focused on distributed systems required for ML modeling and orchestration. So I think that's an exciting space to work in. The problems are challenging and always evolving because the ML models are ever evolving. So I think in terms of fundamentals, we are making progress, but whether like about chat GPT specifically, I don't think I can comment on that because
No, I mean, it's chat GPT is great. Is a trained model, but say like my company is Weird Technologies, right? If I type Weird Technologies, it says, sorry, I don't know anything about Weird Technologies, blah, blah, blah. That is fair question. But if I say Weird QA, it says it's a testing company is providing testing services, which is completely wrong. So I think what it interprets is based on the words we had QA is getting the answers from the whole world of the like deep learning it's going into deep learning and coming back with VHAT and QA, and it just summarize everything based on the what it coming up like. It's a software testing company where it doesn't exist. So my company name is Weird Technologies, where when I type Weird QA, there's nothing like that. So I think what people in a LinkedIn everywhere talking about is answering great, but when you type something, ask something wrong which doesn't exist, it still try to give you answer based on the text and the keywords you providing, which is I think going off track, isn't it? So
So
not talking about particular chat GPT, but how do you see, like, what your experience, you do you see like AI and machine learning will do the great stuff in the future, or they will still struggle? Because AI and ML is 50 years old technology. they are they invented and then they just hide somewhere around 20 years, and the AI just started again now. Google and everyone realize that this is the great technology. So this is not something very new invented recently. This is very old technology, but it's some 20 years nobody focus on it, and it just hide in a corner. Even Google and Microsoft, everyone, they hide it in a corner. They didn't realize the value of it. Now everyone started using it and everyone jumping into it. Now if you see the LinkedIn chat gpts, and there are so many articles, tools similar to chat gpts and blah blah blah, and they'll do it for you everything, which is, in my experience, I'm not machine learning expert, but what I am a tester, so in what my think I am thinking is they're doing at some extent is good, but at some point they're going off track. So you cannot trust 100% the like whatever the result they're giving. Am I right or wrong? I don't know, but
yeah,
that's just
so
some my view. People,
yeah,
I'm saying people relying on AI ML nowadays, people talking about, but I think 100% relying on it, I think it will give you somewhere wrong prediction. Am I right?
yeah. So they have a disclaimer about the results that are generated and how they can be wrong sometimes, and how the model doesn't have enough information about the latest events in the world. So for machine learning models in particular, they're only as good as the data that you feed them. So they learn from the information that they're trained on. So for instance, in your example, like maybe the model had not been trained on any data that had information about your company. So that's why it's not able to predict what your company does or give any information about it. So in terms of the evolution over the years, I think the models have gotten better because the hardware has gotten better. So we can train larger models, we can show them more data, and we can have more refined predictions because of that. So I think they will go hand in hand. So as you make progress along the hardware axis, you will also simultaneously make progress along the machine learning modeling axis. How the industry will move forward, in my opinion.
Okay. I think it will get mature day by day and year by year. People learn from mistakes and all stuff as well. So it's a great thing, but yeah, it's something somewhere you have to be very careful in terms of results or something, especially say like content writer or anyone. They use it AI tool for plagiarism, and they just see this text or this paragraph is totally plagiarized or not, but is little bit, you have to be, human eyes needs to be there, whether it's completely right or wrong. So I think we are getting there. I mean, we all. So I think it should be fine. So question for Andres. So as you said, as you know, Cucumber, we are using build file moving and pom.xml, and we use ant as well. So anything similar you use in karate?
To verify the results?
No, the build file, pom.xml. We use Maven and Ant or Gradle.
Yeah, sure.
Like all the libraries we mentioned there, and it will take it
Yeah.
from the Maven centrals and all stuff. So it's something we can do in karate as well.
Yeah, we can do it. I think the example, no, the example is so trivial. Don't include a lot of things, but you can do it. I think if you want to run, for example, or put in some way in the life cycle of the application, like, I don't know, MBA, verify, or Gradle integration test or something like that, you can do it. As a suggestion, try to include in this part of the life cycle of the application. I always use, for example, the pre-verify or to run all the containers, like, I don't know, my database, my WireMock. After that, run the application, check the results in some way, and the post verify to stop everything in my application, the containers and application. And you can do the same with Gradle, and with Ant. Perhaps you need to define all these steps if you want to use it. Of course, the Maven and Gradle give to us this kind of definition, so you can override and add some behavior inside.
Yeah, I think you said right, because Maven, I prefer Maven because it's very easy, and life is very easy in Maven and in Gradle as well. But in Ant, it's like you have to write. You have to be writer. You have to go through each line and everything. So it has to be everything perfect, no syntax error and everything. So I prefer Maven. I'm a fan of Maven.
Yeah, I always or try to use Maven because there are a lot of things that are native in a simple way. For example, the start the containers and manage if something wrong happened during the execution of the verify of the goal, and you need to stop the container. The container don't continue working because you use a port. And in Gradle, all these manage. You need to do like a craftsman.
But both are using the same central repository. Is all
both
from
of them
Maven.
use. Yeah,
It's just writing is different, syntax is different, flow is same, but all Maven is taking all from Maven central repository, and Gradle is doing the same.
Yeah.
So it's just a personal choice, I guess.
Yeah.
Yeah. So anything you want to ask, Maithili? Do you want to share something about ML or AL, something? You must be Python expert. So anything related to Python?
I thought this was like for Java devs.
You are machine learning expert, so you must be Python one, right? TensorFlow and all.
Yeah, but this session today is for Java, right? So
okay.
I don't know if I want to share anything about Python here.
One comment that you did, I learned 10 years ago, more or less, something about data mining on my university, and you're right. The way that the machine learning learns is with the how many is the information that have to have a decision. If you have a short piece of information, perhaps did a bad answer or produce a bad answer, and this don't change with the time. More or less past 10 years, and the idea is more or less the same.
Yeah.
How
so
you need to train the algorithm with information.
Well, it's actually so AI is an interface which is asking questions, right? Whatever question you're asking goes through AI, and the AI asks the machine learning database, which is a huge sea of the data, and that's called deep science. And then all the queries AI asks, which go back and come back with the answer. So if there is no data inside the data science C, then it will return something unpredicted or something not relevant. That's why it goes wrong. So if you type something in chat GPT, which is something doesn't exist, it will say, sorry, I cannot answer this," which is fine. But if you write something else, and is giving you something wrong result, you will realize that it's talking about, it's just making his own. So that's what I see as a AI, because in AI and ML you have to keep looping into with the new and fresh data and all stuff. So it is good, it is helping one way or other, but we can't just blindly trust. We have to still verify at the end. After the result, we have to still verify the prediction whether it's 100% correct or not. I think that's just my view. Okay, anything else? Hello, Julia.
Hi, Julia.
Hello, Shahil. Thank you for your moderation, guys.
No worries.
Thank you for your, I don't know, your topic. It was very interesting, incredible, and we are really happy that you join us. And I guess it's a time to wrap up our conference. And I want to say you many thanks. And I don't know, I hope you enjoyed what I can say.
No worries. Thank you very much, everyone. And I think it's the end of today's day. We are having another day, pro day, tomorrow. So Julia will continue with the new day, new session, new moderators, new speakers. So enjoy the day and enjoy rest of your evening. So we just discussed the topics today in the Q&A. I think what we felt, I think Andres was talking, this event is for Java devs, so excuse us. But I think Maithili says this is something off track for Java dev. But Andrew's topic was for testing related. So we just asked some more questions regarding around. And your topic, Maithili, your topic was regarding ML. So we just talk about it because just to get some idea of it. So I hope everyone enjoyed.
I guess
And
we're open to every question, so just can discuss something out of topic a little bit.
no worries.
Thank
Enjoy
you
the
for
rest of the
having
day,
me.
and yeah.
So guys, thank you. And I want to say thank you. And I want to say also thanks our program committee members, because these guys, they did a lot of work to search nice topics, to do evaluation, to build our program. And I'm really happy that we have a really cool program committee. Also, many thanks for all our speakers and moderators. Today it was a lot of content, a lot of talks, really long, nice talks, really nice information. And my main thing, what I want to say, that's many thanks to our audience, because you guys still alive, you still here, you are watching us, and it's really nice. It's really a pleasure. It's a really big pleasure for us. And also, I have to say many thanks my team, because my team was here all event, before the event, and we did a lot of job to be here and to make it possible. Also, I want to say many thanks to our sponsors, Microsoft, and I want to remind you that you can find in the chat information with how to. You can click a link and check special offer from Microsoft. And also, what I want to ask you guys, if you enjoyed this day, please, we will send you our feedback form, and please fill out this form and provide your feedback. We are waiting for this because it's really important to know that you do something important. And also I want to say thank you for joining us for this talks information, and I want to remind you that tomorrow it will be our senior track, and you can find our tickets. It's $99, and just only today you can buy these tickets, and join us tomorrow for more senior and interesting content. And also join our next Java event. It will be next year, and it will be also very nice and cool conference. And hope see you soon. Thank you, guys. Thank you very much. Thank you for joining us.
Same to you. Bye.
Bye-bye.
Bye.
Bye-bye.